Welcome to the fifth part series on Azure Basics. In this particular chapter, we'll concentrate mostly on containers. So we'll start off this course by talking about Docker and all the basics that is involved with Docker containers. We'll have a few examples, and then later on we'll proceed towards all the services that is provided by Azure for Docker containers. So that includes services like app service and container instance, as well as container registry. In this particular topic, we'll not be talking about Kubernetes. So that is something that we'll talk about in the next chapter. So I hope you have a good time and I hope you learn. I'll see you in the course. Okay, so before we start talking about containers, let's talk a bit about virtual machines. So in our previous chapters, especially in our chapter one, we had created a virtual machine. So what exactly is a virtual machine? So a virtual machine is just a virtualization of a computer system. So whenever you're creating a virtual machine in Azure or any other cloud service, it's not actually a machine that is allocated for you. And on top of that, a operating system is installed. So what exactly happens is just a virtualization or an emulation of that particular computer system is made over a bare metal server. So let's look at how the infrastructure or the architecture of any cloud service would look like. So at the bottom is the infrastructure, which includes basically the hardware, things like memory, RAM, etc. Now on top of that, it's basically the most important layer, and that is the hypervisor. So the hypervisor virtualizes your physical hardware. So this is a very important thing to remember. So the hypervisor virtualizes the physical hardware. So the result is that each virtual machine contains a guest operating system as well as the virtual copy of the hardware that is created by the hypervisor, and that is required by the operating system to run the application and its associated libraries and dependencies. So here you can see an infrastructure. So this particular infrastructure could be just one server, one physical server. Now on top of that is a hypervisor. Now on top of that particular hypervisor, you can have multiple virtual machines. So it is possible for one physical server to have multiple virtual machines running on top of that. Now, the most important thing to remember is that each virtual machine has its own guest operating system. Now, these operating systems are able to run because the hypervisor virtualizes the physical hardware for each one of these virtual machines. Now, a few important things to remember is that the operating systems can be of either Linux or Windows. So it is possible for a single server on top of which is a hypervisor to run virtual machines that can either be a Linux operating system or a Microsoft Windows operating system. So that is one of the advantages of using a virtual machine. And another very important concept to remember is that these virtual machines do not recognize or know about the existence of other virtual machines within the same infrastructure. So this makes it very safe and secure, and it's much safer as compared to containers, as we'll see in the upcoming chapters. So that's it for virtual machines. Well, virtual machine is a large and huge concept to understand. And now I will share a few links that you can go through in the description below. So that will hopefully give you a better understanding of what virtual machines are. So I will see you in the next chapter. Okay, so now that we know what virtual machines are, which are basically just virtualizations and emulations of a computer system, so how is it different from a container? Containers are abstractions of the application layer that packages code and dependencies together. Now, multiple containers can run on the same machine and share the same operating system kernel with other containers. Now, each of these containers would run as its own separate and isolated process in its own user space. So you could think of these applications as small miniature operating systems which runs its own processes and which runs its own applications. Now, all these containers have one thing in common. They share resources from the host operating system below them. So in a sense, each container can be considered as a virtualization of an operating system within which your application resides and runs. So here one point to note is that your host operating system shares resources across containers. Now that is unlike your virtual machine in which resources are exclusively for that particular virtual machine and no resources are shared between virtual machines. So this makes virtual machine a little more secure as compared to containers. So that's it for this lecture. We'll see in the next lecture where we'll talk about the differences between containers and virtual machines. So I'll see you there. So now let's look at some of the differences between virtual machines and containers. Now virtual machines are heavyweight in the sense that they require a lot more CPU, RAM, and memory as compared to containers. Now, some of the other differences include that each virtual machine runs its own operating system, whereas for containers, there is a host operating system on which your container resides. Now, virtual machines are hardware level virtualizations, whereas containers are operating system virtualization. Now, this is probably the most important differentiation between both of them. Now, the startup time for virtual machines are a few minutes, whereas containers startup time is probably a few milliseconds. For virtual machines, you have to allocate a specific fixed, whereas containers require very little memory space. And also, finally, virtual machines are fully isolated and hence are more secure, whereas containers are process level isolations and possibly less secure as compared to virtual machines. Now, these are some of the major differences between virtual machines and containers. So, in our next chapter, we'll talk about Docker. So, I'll see you there. Okay, so now let's talk about Docker. Docker is a software as a service tool that is used to create and run containers. Now, containers are miniature virtual machines within which contains applications that you want to run. And these containers run on top of a host operating system. So now let's look at all the components of Docker. Okay, so now let's talk about the architecture of Docker. Docker contains three main components. That is the Docker daemon, the Docker client, and the Docker registry. The Docker daemon is arguably the most important part among all these three. So it is in the Docker daemon that objects such as images, containers, networks, and volumes are managed. A daemon can also communicate with other daemons to manage Docker services. So all these functionalities, that is the images, containers, networks, and volumes, are something that we'll talk about in the later chapters. So the only thing you need to remember is that the Docker daemon is basically the heart of everything that happens within Docker. And one more important thing to note is that it is this particular Docker daemon that interacts with the Linux kernel to create containers and to manage these containers as well. So containers, images are topics or are subjects that we'll talk about in the upcoming chapters. And then the second important aspect of the Docker architecture is the Docker client. So the Docker client is the primary way in which you as a user can interact with Docker. So the Docker client includes commands like Docker build, Docker pull, Docker run, etc. And it's the user who would use these commands to interact with your Docker daemon. So whenever we interact with the Docker daemon, it would be through the Docker client. And then the third most important aspect of the Docker architecture is the Docker registry. A Docker registry stores your Docker images. A Docker hub is a public registry that anybody can use. And a Docker is configured to look for these images on the Docker hub by default. So you can even run your own private registry. So when you use the Docker pull or Docker run commands, these images that are being asked for are pulled directly from the Docker registry. So when you use the Docker push command, your images are pushed to that particular configured registry. So these are things that we'll talk about in the upcoming chapters. So the only thing you need to remember is that there are three main components of Docker. That is the Docker daemon, the Docker client, and the Docker registry. So that's it for this particular chapter. I'll see you in the next. So there are two objects in Docker that I would want you guys to know initially itself. That is the image and the container. So a Docker container image is a lightweight standalone executable package of software that includes everything that is needed to run an application. That is the code, the runtime, the system tool, the system libraries, and a setting. So you could consider this to be akin to a virtual machine image. The only difference is that this particular image runs on top of Docker. Now, whenever an image is run, it's called a container. So an image becomes a container at runtime. And in the case of Docker containers, image become containers when they run on a Docker engine. So that's one important thing to know. So a running image is called as a container. Okay, so I've installed Docker in my machine. So for this particular chapter, we'll pull two different images. The first image would be just an operating system. And the next image that we'll be pulling would be a web server, that is Apache web server. So the first thing we'll do is we'll go to hub.docker.com. Okay, so all that you need to do is you need to go to hub.docker.com and you can click on the explore button and you can get all the publicly available images for your application. So for example, if you want to install Ubuntu operating system on top of your Docker, you can just click on Ubuntu and you can get the official image for that. Or for example, if you want to install an HTTP web server, that is an Apache web server, you can just click on HTTPD and you can just run this particular command. So for the first example, let's get Ubuntu into our Docker. So all that you need to do is you just need to run this particular command. So the Docker pull command will pull the image from this repository into your local. So let's copy this and let's paste it in our local. So I currently have Docker installed, so you can just type Docker version and you get the relevant information. The next most important thing for you to remember is the Docker image ls. So this will give you a list of all the images that are available in your current repository. So if you click on Docker image ls currently, you will see that there isn't any. So let's run this Docker pull Ubuntu. So I'll copy this and let's paste it. and it will currently pull the Ubuntu image from our hub.docker.com. So let's wait for this to finish. And let's do a Docker image ls again. And you can see that there is an image that is there in our local repository. Now, if you're using Windows, you also get an application called Docker for Windows. Now, this is a very useful tool. So this will give you a application which will give you all the images that are currently available. So if you click on images, you can see that there is an Ubuntu image that is currently available and it's 72.78 MB. So this is basically the same thing that you see over here as well. Okay, so now that you've created your Docker image, the next thing that we'll do is we will run this particular image and create a container out of it. Now to do that, what you need to do is you need to run the docker run command. And for this particular instance, I will run it as an interactive terminal. And all that I need to give is just the name of my particular image, which is Ubuntu. And you can also give a tag if you wish. So the tag that we have is latest. So if there are other tags, you can give that as well. So let's run this particular image. And now you can see that I have entered the terminal for this particular container. Now, if you go back to your Docker in Windows, you can click on your container and you can see that there is a running instance of this particular image. And if you go back to your image, you can see that this is the particular image. So this particular image is being run as a container, which is this. And within this particular terminal, you can run commands like who am I, pwd, etc. So these are Linux commands that you're running within that particular Ubuntu container. So that is it for this lecture. In this lecture, you saw on how you can pull an image from a Docker hub and create a container out of it. And once you've created a container, how you can interact with that particular container. So in the next lecture, we'll see on how we can create a Apache web server using the same method. So I'll see you there. Okay, so in our previous chapter, we were able to create a container out of an Ubuntu image. In this particular chapter, we'll do something different. We will create an application, Apache web server, and then we will deploy it in a container. So the first thing you need to do is you need to pull the appropriate image. So we have the HTTPD official image. So what we'll do is we'll pull this particular image. So I'll just copy this command and I'll go to my prompt and let's exit out of, and let's run this particular command. Okay, now let's do an Docker image ls. So you can see that we were able to get the HTTPD image in our local repo. So all that we need to do is we need to run it. So now the difference between our previous example and this example is that in our previous example, we just wanted to interact with our Ubuntu operating system. Now this is going to be a little different. So in this particular example, we need to interact with our web server using our web browser. So what we need to do is we need to connect the port of our container with the port of the host operating system, which in our case is Windows. So the diagram would look something like this. So we have a container and the container has Apache running on it. And this particular Apache web server would run on port 80. And this particular port 80, we will expose to port 8080 of our operating system, the host operating system. So what we need to do is we just need to do a localhost 8080 to interact with this particular Apache web server. So let's do that. So all that we need to do again is just run the docker run command. So let's run the docker run command. And here I need to map the port. So what I'll do is I'll map the port 8080 of my local operating system to port 80 of my container. And all that I need to give just the name of my particular image. So that would be HTTPD. And if you wish, you can also give the tag as latest. And let's run this particular command. So this should be HTTPD. And you can ignore this particular warning for the time being. So let's go back to our browser and let's see if you're able to connect. So let's do a local host. And it should be port 8080. And let's run this. And you can see that you get an output like this. So all that means is that the Apache web server is working. So you can also go back to your Docker for Windows and you can click on containers and you can see that it's running currently on port 8080. And you can also click on this particular icon, which will open it in a browser as well. So just click on this and you can see that it gives the same output. So that is it for this lecture. In this lecture, you learned how you can create an Apache web server and host it on a container and expose its particular port to the host operating system. So I will see you in the next chapter. Okay, in this particular chapter, we'll talk about uploading your images to your own private repository. So whenever you create your account in hub.docker.com, you have the opportunity of downloading your images within your own private repository. So to do that, the first thing that we need to do is we need to create a tag for a particular image, and then we need to upload it. So let's go back and let's see how this is done. So let's exit out of this. So first thing is let's do a Docker image ls. And currently you can see that there are two repositories. Now the name of my particular private repository is this. So I need to create a tag with this particular name provided by the name of my particular image. So let's do that. So to create a tag, all that you need to do is just run the docker tag command. And then I need to give the source name, which is basically Ubuntu, and the destination tag name, which is the path of my private repository. And I will also call this Ubuntu as well. And you can also give a tag called latest, or it could be anything else as well. So let's call this as version 1. And let's run this particular command. Okay, so, and let's do a docker image ls once more. And you can see that it got created as this. So the tag here is version 1. So all that I need to do is I just need to push this particular repository now. So to do that, let's just run the docker push command. Now, of course, I need to be logged in as well. So let's do a docker login. Okay, so I had already previously done the authentication, so that's why it's just authenticating with the existing credentials. So if you're authenticating it for the first time, you'll just need to give the username and password. So now all that I need to do is just give a docker push command, and I just need to give this particular name. And the version is version 1. So let's run this particular command. So it's going to push it to this particular repository. So this is my private repository, and this is going to be the name of my particular image within my private repository. So let's wait for this to be pushed. And once your push is done, you can go back to your UI again. You can go to your Docker Hub and click on repositories here. And you can see that your Ubuntu repository is available. So all that we need to do is we need to just pull it from this particular repository. Now, again, to do that, let's go back to a console. All that you need to do is just do a Docker pull, and this time you need to pull it from your own repository. So instead of just giving Ubuntu, you need to give this as Ubuntu. And let's click on enter. Now the reason why it failed here is it's expecting a default tag as latest, but what we put is version 1, as you can see over here. So all that you need to do is you just need to run this command, and you also need to put the version as version 1. And let's run this again. So you can see that it has been pulled to your particular account. So let's do a docker image ls. So as you can see that this particular image was already there. So let's remove this particular docker image and let's do a pull after that. So to remove your image, you can just do a docker image rm, and here you need to give the name. So I'll just copy this, paste it here. You need to mention the version as well. And let's do a docker image ls now. And you can see it's not there. So let's do a docker image pull again. So again, I'm going to pull the docker image from this particular version. Let's run this again. And let's do a docker image ls. And there you can see it's currently available for use in your local machine. So that's it for this lecture. In this lecture, you've learned how you can use your remote repository to store images. So I hope this was a useful lecture. I will see you in the next. Okay, in this particular chapter, we'll talk about something very important, that is creating our own image. So in the previous chapter, we had pulled an image from the Docker Hub, and we had used that particular image to run our container. In this particular instance, what we'll do is we'll create our own image and then we will run that as a container. So let's see how we can do that. So the first thing that we need is an application. So in our example, we'll be using a Node.js application to do that. So this is the application that we want to run within our particular container. It's just a very basic Express application, and it just returns a hello world back to the user and nothing more than that. And it will run on port 80 and it will run on localhost. So what we have is just a very basic server.json and package.json file. So we will create an image for this particular application that will run this particular Express application. So to do that, what we need to do is we need to create something called as a Docker file. So let's do that. So I will click on new file and I'll create my first Docker file. And let's open our Docker file. So the first thing that the Docker file must contain is a base image. So it's on top of that particular base image that we will create our own image. So for our example, what we'll use is basically a node image, and it is going to have a tag called slim. So let's check out what this particular image is. So I go back to my Docker Hub, and in my Docker Hub, I will search for node, and I get the official node image. And within this particular node image also, I will choose a very specific tag. So if I go to my tags and if I choose the latest, so if you look at the latest, you can see that it has a massive size of around 332 MB. We do not want a very large base image. So instead of using the latest, we'll use something called as slim. And this particular slim tag for our node app, for our node base image has just a size of 60.72 MB. And this particular slim tag is good enough for us to create an Express application. So we'll be using this particular tag. Okay, so now that you've set your base image, the next thing that we need to do is we need to create a work directory. And this work directory by convention has this particular path, that is user source app. I mean, you can have any other path you want, so it's basically just up to you. So this particular work directory becomes our current present working directory. So that's one thing you need to remember. Now, if you need to have more information about work directory, you can go to the official Docker file reference, and this particular Docker file reference will have all the information relevant to your work directory. So the work directory instruction sets the working directory for any run command, entry point copy, or any add instructions that you want to follow in your Docker file. So if the work directory doesn't exist, it will be created even on its own. So it's not mandatory that you need to create your own work directory. So once your Docker file is created, if that particular work directory is not there, it will set on its own. Okay, so once you've created your work directory, let's go back to our Docker file. So the next thing that I need to do is I need to transfer my package JSON to my work directory. So to do that, I just need to run the copy command. So I'll run the copy command and I need to just copy the package.json file, which is basically my source, to my work directory. And this particular command does it. And once I've copied it, okay, and once I've copied my package.json, I need to run the run command. So this run command will execute my particular package.json file. So all that I need to do is I need to run npm install. Now, one thing to remember is that because I have my node as the base image, so it will automatically have my npm installed, pre-installed. So that's something I do not need to worry about. And once I've done that, the next thing that I need to do is I need to copy my server.js file as well. So let's do that as well. So I'll again do a copy server.js and I will copy it again to my work directory, that is user source app. And after this, all that you need to do is you just need to expose port 80. And it's on port 80 that your application would be running. And after that, finally, you can just run the command. And within this command, you need to have the executable as well as the parameters. So what we'll execute here is node, and the parameter would be server.js. And that's it. Our Docker file is ready to go. So now all that I need to do is I need to build an image out of this particular Docker file. Now to do that, let's open a terminal. And all that I need to do is I just need to run the Docker build, and I need to give a name for my particular. So let's tag this particular application as well. So let's call this as node app, and it's going to be the latest version as a tag. And that's it. And I just need to give the dot path. So this is the path to my Docker file. And let's run this particular command. Okay, so our Docker build command is done. So let's do a Docker image ls. And here you can see that our image is created. So now let's run this particular image. So all that this particular image will do is return a hello world back to the user. So let's run this. So again, this time what we'll do is we'll run it using the application that we have. That is this particular Docker on Windows application. So let's go back to our images. So it's in our local. And this is our particular image that we just created. So let's just run this. So let's click on run. And here let's set the optional parameters as well. So here the container port is port 80, and let's make the local OS port as 80 as well. So it's going to listen on port 80, and let's run this particular application. And once you've done that, all that you need to do is you just need to go to your containers. And here you can see that this particular application is running. So all that I need to do is I just need to open it on a browser. So let's click on this particular open in browser. And you can see that my hello world works here. So that's how you can create your Docker image and run it as a container. So the next thing that we'll do is we'll open our particular container. So let's open it in a CLI and let's see what's there in the work directory. So let's do a pwd. So now I'm currently in my work directory, and here you can see all the relevant files that were moved from your local to your container. So this is the package.json that was moved, and this is the server.js that was moved. And this node modules was created when we did an npm install in our work directory. And finally, to see your running process, you can run this particular command. So this particular command I got from this particular Stack Overflow page, and this particular page I will give in the description below. So this particular command returns this output, and you can see that our node application is currently running within this particular container. So that's it for this lecture. I hope this was a useful lecture for you. Lecture you learned how using the Docker build command you can create your own image and use them as a container. So I will see you in the next chapter. So in this particular chapter, we'll talk about how you can persist data in your container. So the data that you store in your container is only valid as long as your container exists. So as your container exits or is shut down, then that particular data that you have stored is no longer accessible to anybody. So to overcome this situation, you can either store your data as volume or as a bind mount. And if you're using Linux, you also have the option of storing it as temporary mount within your memory. But again, this is only valid as long as your container exists. So if your container goes down, then your temporary mount also goes down. So the best way to do it is using volumes. So if you're using volumes, then your data is stored within a Docker area in your file system, within your host operating system. So this particular area is only accessible to Docker containers, and no other application or process can access this particular Docker area. Whereas if you're using bind mount, the data that you store can be used by other non-Docker processes as well. So the best way to store your data is to use volumes and not to use bind mount. So let's start our next chapter by creating a volume, and let's see how it works. Okay, so now to explain how volumes work, I'll be using a Cloud Shell environment. Now you can use any Linux environment and it should work fine as long as Docker is installed in it. So let's see if Docker is installed in my particular Cloud Shell environment. You can see it is. So the first thing I'll do is I will create a volume. So to create a volume, all that you need to run is the Docker volume create, and you need to give a name for your volume. So I'll just call this as my volume. And you can see that my volume has been created. Now to get more information about your volume, you can just do a Docker volume inspect, and you just need to give the name of your volume. So the name of my volume is my volume. And you can see that the mount point is this in our host operating system. So if I go to this path, it'll give an access denied. So let's copy this and let's paste it. So you can, however, use your sudo to access that particular path. So let's do that cd again. And you can see that currently this particular directory is empty. So let's exit from our sudo. Okay, so now that you've created your volume, the next thing that we'll do is we'll create a container out of the Nginx image that we have. And we'll be using the volume that we've just previously created. So this particular volume will be mounted on /app within our container. And after we've done that, we'll just run the bash command. So let's run this particular command. And currently we are connected to the container and we're using the bash shell. So what we'll do is we'll go to the cd app and let's add a particular file to this particular path. So I'll just do a touch ABC. And once I've done that, let's just exit out of our container. And currently I'm back in my host OS again. So again, let's do a Docker volume inspect for my volume. And let's go to this path again. So this particular path, which is in a host directory, should contain the file that we just created. Again, we need to do a sudo su. And let's go to this particular path. And you can see that this particular file that we had created within our container is accessible in this particular path. So that is how your volume works. So your volume data will be available to any container that is attached to this particular my volume. So that is it for this lecture. In our next lecture, we'll see how the bind mount works. So I'll see you in the next chapter. Okay, so now let's talk about bind mounts, which have been around since the early days of Docker. So when you use a bind mount, a file or a directory on the host machine is mounted into a container. So the file or directory is referenced by its absolute path on the host machine. By contrast, when you use a volume, a new directory is created within your Docker storage directory on the host machine, and Docker manages the directory's contents. However, that is not the case when you're using a bind mount. So the problem with bind mount is that it can also be accessed by other non-Docker based processes as well. It is less secure when compared to volumes, and volumes are generally preferred over bind mount. So let's see how we can create a bind mount. So let's go and look at this particular documentation. Now, this particular URL I will send in the description below, so you can just check that out. So if you go and look at this particular diagram, you can see that whenever you're creating a volume, the volume is created within a Docker area, and this Docker area is a protected environment and it can only be accessed by a super admin, whereas the bind mount can be accessed by anybody and it's within the general file system. So let's create our first bind mount. So all that you need to do is you just need to run this particular command. And again, it's a Docker run command, and we'll be creating a container from this particular Nginx image. And the important arguments that you need to know here is that this particular argument mount and it's of type bind, and the source here is the present working directory in our source operating system followed by a /target. So this particular path should be present in your source operating system. So you must always remember to create a target folder, and then the output is basically the /app within your container. So it's within this particular folder that your data will persist in the container. So let's copy this. Okay, so first thing that we need to do is we need to create a target absolute path for a particular bind mount. So let's do that. So we had chosen a present working directory, and then to we have to create a folder called target. And it's within this particular folder, that is the target folder, that our bind mount would be created. So okay, so once you've created the folder, let's run that particular command that we had previously seen. So this is that command. So again, it's going to be a Docker run that will create a container out of this particular image. And then again, the mount is of type bind, and the source here is the absolute path that is presented as source operating system. That is the present working directory that points to this, and then a target folder. And it will be mounted on this particular /app in our container. So let's run this particular app command. And okay, so I'm in my bash within my container. So let's go to the /app folder and let's create a few files here. And let's exit out of our container. Okay, so once we exited, let's go to the target folder that we had created. So let's do a cd target. And if I do an ls, you can see that these two files are present here as well. So we have mounted this particular folder on our container. So let's also create another container. And let's use, instead of using Nginx, let's use an Ubuntu image. So we'll run the same command again, and of course the source again would be the same, and the target would be again /app within this particular Ubuntu container that we'll create. And let's run this once more. Okay, so I need to go to my present working directory and let's run this. So the problem here was I was in the target directory, and within this target directory is expecting this particular path which isn't there. So I have to go back to my previous path and run the same command again. So let's run this again. Okay, so there is a container by that name. So let's call this as, okay, so we are in our Ubuntu container now. And let's go to a /app and let's see if we are able to access these two files. So if I do an ls, you can see that these two files are present even in my Ubuntu container that I created. So this data does persist, and you can create other containers, and those containers can access this data as well. And let's create a file within our Ubuntu container as well. So let's do a touch abh and let's exit out of this. And let's go to our target folder and let's do an ls. And you can see that this abh is present here as well. Okay, so that's it for this lecture, and always remember that volumes should be the preferred way of persisting data in Docker and not your bind mount. So I will see you in the next chapter. So apart from volumes and bind mounts, if you're using Docker on Linux, you have a third option of storing files, which is outside the container's writable area, and that is called as the temporary file system. So let's look at this diagram. So when you create a temporary file system mount, you're creating data that resides within the memory of the host file system. The limitation of using temporary file system is that you cannot share your temporary file system mount with other containers, and this functionality is only available if you're using Docker on Linux. And the third disadvantage is that this particular data is not persistent. So as long as your container is up, your particular container can access that data. So if your container goes down or if it's removed, that data also disappears along with that particular container. So let's create a temporary file system mount. So again, the command is literally the same. The only difference here is that the type you have to give is the temporary file system, and you only need to give the destination. So you do not need to give the source within your host operating system. So let's run this particular command. So I just copy this. And now let's run this docker run command. So here I'll give a new name for my Docker. So let's just call this temp container. So again, everything remains the same. The only difference here is that the mount type is temporary file system and the destination is /app. And once I run this command, I will open the bash shell. So let's run this. So currently I'm in my bash shell. So let's see if there's a /app path present. And you can see that there is. And within this particular path, you can store any file that you like. And this particular file or anything that exists within this folder will only persist as long as your container is running. So that's it for this lecture. I will see you in the next. Okay, so now let's talk about networking. So previously we had talked about containers, images, and volumes, and this is going to be the final topic on Docker, and it is networking. So networking is a very basic concept to understand. So you have multiple containers within the same host, and you want these containers to communicate with each other. So networking makes it possible for containers to communicate with each other. So in this particular exercise, we'll talk about the two very basic networking patterns that is followed in Docker. That is the host and the bridge network. So let's start our next chapter by talking about the bridge network. I'll see you there. So now let's talk about the default network that is available in Docker, and that is called as the bridge network. So in Docker, a bridge network is basically a software bridge which allows containers connected to the same bridge to communicate with each other while providing isolation for containers which are not connected to the bridge network. So the Docker bridge directly installs rules in the host machine so that containers on different bridge cannot communicate directly with each other. So let's start off by creating our first bridge network. Now, of course, one thing to remember is that whenever you create a container, it automatically goes to a default bridge. So you have the option of creating a new bridge network and inserting your containers within that new network. So let's do that. So let's go to a console. So I'm back in my console. So the first thing I'll do is I'll check all the networks that are currently available. So for that you can run the docker network ls, and you can see that these are the networks that are currently available. And this second one is basically the default network that is available to you. And whenever you create a container, and if you do not specify any network, then it automatically goes to this particular network. Okay, so for our example, we'll create a new network. So let's create a new network. And let's call this as my new network. And let's do a Docker network ls again. And you can see that this particular network got created. So the next thing that we'll do is we'll create a container and we'll specifically mention that particular container should belong to this particular network. So let's do that. Okay, so now that you've created your network, let's create a few containers. So I'll create a container out of my Ubuntu image. So let's do a Docker run and I'll open it in the interactive mode and I will specify the network. And the network here would be my new network and the name of my image. And let's open the bash shell. So let's run this particular command. Okay, so I have created one particular container. So let's create another container. So let's open another command prompt. And let's run the same command again. I need to specify the network, which is my new network, the name of my image, and the bash shell. Okay, Okay, now that we've created these two containers, let's try to ping each of these containers. But before that, we need to know what is the IP address of both these two containers. So let's open another prompt. So what I need to do is I need to run the Docker network inspect my new network, which is the network that we've created. And if you open this, you will get a JSON file, and the JSON file has got a key called containers. And within this containers, you get all the information that you need. So the IP address is 179.19.03 and 179.19.0. So what we'll do is we'll try to ping these containers. So let's run the ping command. And you can see that the ping command is not there. So what we need to do is we need to install the ping command. So let's do that. So to install the ping command, what you need to do is you need to run your app get update. So let's copy this, let's run it. And similarly, you also need to install this particular library as well. So let's get this done. Let's do it for the other container as well. Okay, so I've installed ping in both the machines. So we can just do a ping just to verify. And yeah, so the ping is installed. So all that we need to do now is we need to find the corresponding IP addresses for these containers. So this corresponds to the container ID and this corresponds to the container ID of the other container. So let's open the command prompt once more and let's run the container uh, docker container ls, and this 898090 corresponds to this particular container, and similarly 21412 corresponds to this. So again, let's run the docker network my new net inspect. And here you can see that unruffled Shirley has this particular 214.1.2 has this particular IP address. So what we'll do is from unruffled Shirley, we'll try to ping this particular machine. So what I'll do is I just copy this particular IP address and let's ping the other machine. And you can see that the ping worked and it was able to send a ping request to the other machine. So in this way, you know that these two containers are connected with each other. So that's it for this lecture. I hope this was useful. So one last thing we'll do is we'll just exit out of this. I'll create another container and that container will not be connected to this network, but it will be connected to another network that is the default network. And let's see using that particular container whether we are able to connect to these containers that are within another network. So the first thing we'll do is we'll create a container again, docker run, and this time I'll not specify any network. So I'll just run it in the iterative mode and let's run it with bash. And let's try to ping this particular machine. So let's do a ping 172.19.02. Okay, so we need to install ping. So let's do the installation of ping once. Okay, so I installed the ping command. So let's try to ping the other network, that is the my new network from our default network. And you can see that it doesn't work because it's not within the same network. So once again, let's exit out of this and let's run the docker inspect network for my new network. And you can still see that this particular inspect for that network has just two containers. So the other container, that is the one that we recently created, is not present in this particular network, but is present in the default network. And we can verify that as well. So instead of inspecting my new network, let's inspect bridge. So you can see that the bridge network has this particular container. So I hope this was a useful lecture. In this lecture, you've learned how to create a new bridge network and add containers to it. So I hope this was useful. I will see you in the next. Okay, so now that you know a bit about Docker, let's go back to our Azure services. And the first service that we'll take care of is the container registry. And the container registry is just like your Docker registry, and it's just used to store your images. So let's click on container registry. You can either search for your container registry on the search bar, or you can go to your all services and you can find your container registry within your containers tab. So let's open a container registry. So the first thing that you need to do is you need to create a new registry. So just click on create and you can place it in any resource group. And let's give a name for our registry. So I'll call this as VLC and let it be a standard container registry. So let's click on review and create. And let's click on create. Okay, so our registry has been created. So let's click on go to resource. And what we can do here is we can upload our container images within this repository. So let's click on repositories here. And here at this moment, because we haven't created any repository, so what we'll do is we'll create a registry. So the easiest way to get this done is you can go to click on quick start and you can get all the relevant commands that you want. So what we need to do is we need to create our image in a local machine. And then once we've done that, we just need to Docker log into our Azure registry, that is the container registry. And then we just need to push our particular image. So let's do that. So let's go back to our Azure Visual Studio Code. So what we'll do is we have this application. So the first thing that we need to do is we need to create an image in our local machine. So let's do that. So this is a very simple Express application which just has a server.js. and a package.json file. The first thing, again, like I said, is we just need to build an image from this particular piece of code. So let's do that. To do that, all that you need to run is the docker build command. And let's give a tag of express app, and let's just give this current path. And let's create an image out of this in our local. Okay, so once you've created the image, let's log into our Azure container registry. So to do that, I just need to copy this. Let's paste this. And it'll ask for a username and password. Now to get the username and password, you again go back to your console and you just need to click on access keys. And here, let's just enable this admin user. And let's copy the username and password. So this is the username. And similarly, the password as well. I'll copy this. Okay, our login is successful. Now let's do a Docker image ls. And now let's tag our image. So I'll do a Docker tag, and our image is express app. And we need to tag it as, I'll just copy this path. And the name of our repository in our container registry would be express app as well. Now you can also mention a tag. However, if the tag is not mentioned, it will automatically pick it up as latest. So let's run this Docker tag. And now let's do a Docker image ls once more. So you can see that the tag is latest, and this is our repository. And now all that we need to do is we just need to do a Docker push. Okay, so our repository has been pushed. Now let's go back to our container registry and see whether it's available. So I'm back in my container registry. Let's go to the repository. And you can see that our Express application repository has been pushed. And it has one particular tag, that is the latest tag. Okay, so that's it for this lecture. In our upcoming chapters, we'll be using this particular image to create containers. So I will see you there. Okay, so now that you've stored your image in your container registry, let's make use of that container registry to create a container. So to do that, you need to go to your container instance. Now, of course, you can search for your container instance in the search bar. You can find it here, or you can go to your all resources, and within your containers, you can find your container instance. So let's click on this. And here, let's create a container instance. So I'll click on create. And here, let's create a first container instance. So we can just put it in any resource group. So let's put it in a resource group, or let's create a new one. Click on OK. Let's give a name for our container instance. And here you have the option of either choosing a quick start image, or from a Azure container registry, or from a private or a public Docker Hub registry. So let's start by using the quick start image for this particular chapter. In the next chapter, we'll do the Azure container registry, and then after that, we'll use the Docker Hub. So let's click on review and create. And here you can also choose the size. So let's choose the most minimum CPU and memory. So let's click on OK. So this seems fine. And let's click on review and create. So we passed the validation. So let's click on create. Okay, so our resource has been created. Let's go to that particular resource. And let's click on containers here. And you can see that a container has been created and it's pointing to this particular image, that is the hello world latest. So let's open it in our browser and let's see what we see here. Let's copy this and let's paste it. And you can see a default welcome to Azure container instance. So that is it for this lecture. So this lecture was not very useful. So you're just pulling a basic Microsoft image and making a container out of it. So in the next lecture, we'll see how we can use a container registry and pull an image from our container registry. So I'll see you in the next chapter. Okay, so in this particular chapter, we'll again create a container instance, but this time we'll be using the image that we had put in our container registry in the previous section. So let's do that. So again, I'll be using the containers resource group that I had previously created. And let's call this my container registry. And this time we'll be using the Azure container registry. So we had created an Azure container registry by this name, and it has an image called Express app. And there's only one tag, that is the latest tag. So let's create this particular container using the image that we had previously created. So let's click on review and create. So everything is very straightforward. So all that you need to do is click on create. Okay, so our deployment is create. Okay, so our deployment is done. So let's go to the resource. And all that we need to do in our application now is to just copy the IP address and let's paste it somewhere. And here you can see the hello world. So this is basically just the Express application that is running in that container. So I hope this was a useful lecture. In the next lecture, we'll see how you can use your Docker repository, both public as well as private, to create your container. So I'll see you there. Okay, so now let's finish off this section by creating an instance using our Docker public repository. So let's click on create. And we'll create this within the containers resource group. And let's create an Nginx web application using our container. So let's just call this as Nginx web app. And let's make this in US East. And here the only difference is that I just need to click on this Docker Hub. And I can either give a public image or a private image. So let's give the most commonly used Nginx. And let's use the latest tag for Nginx. And that's all that you need to do. Everything else remains the same. So let's click on review and create. And let's click on create. Okay, so a resource has been created. So let's go to the resource. And let's open this public URL. So I'll copy this and let's see if we can. And you can see that we can see the Nginx page. So that is how you can use your public repository. So let's go back to our application once more. And we'll create one final container instance. So let's click on container instance once again. Let's click on create. And we'll create this within the containers resource group as well. And here the only difference is that I'll click on Docker Hub and let's use the Docker Hub private repository to fetch our image. So what I'll do is I will go to my Docker Hub. I'll just copy this URL. So the name of my particular image is this. I'll copy this. I'll paste it over here. And if you look at the tag mentioned here is version 1. So I'll copy this. I'll paste it over here. And let's give the username and password as well. And the password is this. So everything seems fine. So let's click on review and create. Okay, I need to give a name for my And let's click on create now. And let's go to our resource. Let's click on containers. And here you can see that your particular container instance got created. So now this particular instance is not connected to any web server. So it will just exit after it has been created. So that is it for this chapter. So in this chapter, you learned how you can connect both to your public Docker as well as to your private Docker account. So I hope this was useful. I will see you in the next chapter. Okay, so in our previous chapter, we've learned how you can deploy one particular container into your container instance. In this particular chapter, we learn on how you can install multiple containers into your container instance. So let's see how this can be done. So now to install multiple containers into your container instance, there are three ways in which you can do it. You can either create a container group using a YAML file, or you can use a resource manager or a Docker Compose. So a Docker Compose is something that I'd explained to you previously. So let's not go into that. And the resource manager is something that I'll explain to you while I talk about infrastructure as a code. So for the time being, let's see on how you can deploy your multi-container instance group. So let's click on this. So all that you need to do is you need to configure a YAML file, and the YAML file looks something like this. So it has these properties, the API version, the location, the name, as well as all the properties related to the container. So here in this particular example, you can see that there are two containers that have been deployed. So what we'll do is we'll copy this and we will use it in deploying our images that we already have. So let's copy this and let's go to VS Code and let's paste this particular application. And let's paste this YAML code. And what I will do here is I will install two web servers. So the first thing I'll do is I let the location be East US, and here I need to give the name for my instance, container instance. So let's call this as my web server. And let's install two containers in this. So the first would be a Nginx, and I'll just give this as Nginx and we'll pick it up from Docker. And this I will just map it to port 80. And similarly, I'll also have one more. I'll copy this and I'll paste it here. So I'll just call this as HTTPD and it'll pick up the Apache Web Server application image. And this would be read on port 8080. And the only other thing I need to do is I need to go to ports and I need to map both these ports here as well. So this represents your Nginx and this represents your HTTPD. So let's run this application and let's see whether it works. So I'll go to my terminal and let's run this particular application. Now to run this application, you just need to run the Azure container create. And here you need to give a resource group. So the resource group I've given is containers. And I also need to mention the location of this YAML file, which is multi.yaml. So let's run this. Now let's go back to our console and let's see whether it has worked. So I'll go to my container instance. So there's a my web server that gets created. And you can see that there are two containers. And let's go and click on containers. So now you can see one of these containers failed. Now the reason for that is if I go back to my YAML file, you can see that there is no port mapping allowed. So my particular HTTP application, even though it's reading from port 8080, the image from which I am reading this particular application expects the user to communicate via port 80. So there is no port mapping that can be done from port 8080 to 80. So this is a very common concept in Docker where you map ports together. Now, because of that reason, your particular configuration here fails. So what I need to do is I need to create an image and that particular image should be reading from port 8080. And that is precisely what I have done. So I have gone and created a new Docker image. So let me show you that particular Docker image. So it's a basic node application, and this particular node application would be reading from port 8080 and not port 80. And I'll be using the image that I've created of this particular application to run our container instance. So let's go back to our previous file. And here what I'll do is I will just change this from HTTPD and I'll call this as a node application. And let's fetch that particular image that I had created. So I'll go back to my, so let me open my Docker Hub account. So this is the application that I have created, and this particular application has port 8080 open. So I'll be using this particular application. So let me just copy this. And this has the tag of latest, so I do not need to change that. And here, instead of HTTPD, I'll just paste this image. So now this particular Express application has port 8080 opened, and that port 8080 will connect to this port 8080, and I can communicate to this application via port 8080, and it should work fine. So let's go back to our web server, and let's remove this application. Click on yes. And now let's run our YAML file again. So again, it's the Azure container create. It's the same resource group and the same YAML file. And the only difference here is I'm using another image, and this image has port 8080 open. So let's run this application now. Okay, so now hopefully my containers, both of them should work. So let's go back to our console now and let's refresh this. And let's open our web server. And here now, if I go to the containers, you can see that both of them are in a running state and none of them are in terminated state. So let's click on overview and let's see if we can access both those applications. So I'll copy this and let's paste it. So this is the Nginx, which is running on port 80. And if I go to port 8080, you can see that my node application is running, which just displays hello world. So that is how you can run multiple containers in your container instance. So the only thing to remember is that your port mapping does not work in the YAML configuration. So you need to manually configure it in your Docker before you use it in your container instance. So I hope this was useful. I will see you in the next. Another way of creating multiple instances in your container instance is using the Docker Compose file. So this is how the Docker Compose YAML file looks like. So it has the version, and here you need to mention the services, and here each service represents a container image. So here I have two services. The first is the Nginx, and for the Nginx, I will give the container name as Nginx container, and this is the path of the image. So image would be just the Nginx image that I'll pull from Docker. And the second image is the node application, and this node application I will pull from my container registry in which I have uploaded this particular image. So this is the same image that I had used in my previous chapter. And this particular image opens port 8080. And this port 8080 is open to port 8080 of our container instance. Now, one thing to note is that you cannot do a port mapping in container instance. So you cannot map port 8080 to any other port. So this has to be the same. So that is one thing, and that is probably one of the biggest disadvantages of using container instance. That is, you cannot do any port mapping. So this is how our Docker Compose file looks like. So let's use this Docker Compose file to create a container instance and to push these two images into a container instance. So let's do that. So one thing to note here is that this thing works only using CLI. You cannot do this using the console. So first thing I'll do is I'll just do an AZ login. And let's log in using my account. Okay, so I've logged in to my account now. So let's clear this. So the next thing I need to do is I need to create a context. Now to get more information about context, I will send you a link in the description below so you can just check that out. So let's create a context. So to create a context, you need to run the docker context create ACI, and you can give a name for your context. And here you need to choose in which particular resource group you want your particular project to be in. So let's put it in our containers project, which is in Central India. So let's choose this. And we've created a context. So let's do a Docker context ls. And these are all the contexts that are currently available. So currently it's this context that I'm currently pointing to. So let's move it to this particular context that I've just created. So to do that, let's use the Docker context use and I will use this new context that I just created. Okay, so there's a, okay. Okay, so now that you've created your context, all that you need to do is you just need to run the docker compose up command. Now you can also run this locally, but it'll do the same thing. So there isn't much complexity involved in this. So let's just do a docker compose up and create a container instance and push these two images into that particular container instance. Let's click on enter. And currently it will create a new container instance and it will upload all these two containers into it. So let's wait for this process to finish. Okay, so our process is done. So let's go back to our console and let's refresh this. And you can see that our container app got created. So let's open this. And within this, you click on containers and you can see that there are three containers. Now, these two are containers that we had uploaded. And this is one of the containers that Microsoft uploads for monitoring and configuration. So let's use and check whether the other two containers that we have created work. So let's click on overview. So one of them, the Nginx is on port 80 and the other one is on port 8080. So let's click on overview and let's copy this and let's paste it. And you can see that port 80 points to Nginx and port 8080 points to the node application. So that is it for this lecture. So in this lecture, you learned how you can use Docker Compose to create multiple containers in your container instance. So I hope this was useful. I will see you in the next. Okay, so in this particular chapter, we'll be creating a CI/CD pipeline for our application. So the first thing that I need to do is I need to create a project in my GitHub, and then I will build that particular image and store it in my container registry. And once that is done, I will push the code from the container registry to my container instance. So all of this should happen seamlessly. So let's see how this is done. So the first thing that I'll do is I'll go to my GitHub and here I will store my application. So I created a repository and this repository has just the server.js as well as the package.json and the Docker file. So the first thing that I need to do is I need to move this to our container registry. So let's do that. So what I need to do is I need to open my Azure DevOps and I have created a project. So let's open this project. And what I'll do is I'll go to my pipelines, click on pipelines, and I'll create a new pipeline. So let's click on new pipeline. And here I need to choose GitHub. So let's click on GitHub here. And this is the repository that I've created, which contains my code. So let's click on this. And here I need to give permission. So click on approve and install. So here you need to configure your pipeline. So the first thing that I will do is I will build and push an image to my Azure container registry. So let's click on this option. And here you need to choose your subscription. So let's choose the subscription that we have and click on continue. And here you need to log in. So let's log in with the user that I have. So let's click on next. Click on sign in. And here I have a container registry. So within this container registry, my repository will be stored. So let's click on this and click on validate and configure. And the first thing that we will do is we will store this in our repository. So all that I will do is I will just click on save and run. And This will set up a CI/CD with Azure pipeline. So let's click on save and run. And let us wait for a repository within the container registry to be created. So let's wait for this to be over. So let's go back to the container registry, and within this container registry, there should be a repository that should be created. So let's refresh this and let's wait for that build to be over. And you can see that it has succeeded. So let's go back to our registry and let's refresh. And you can see that a repository got created. So let's open this. And there is a build that got created. Okay, so now let's add another task to this particular pipeline. So let's go back to our pipeline. And this time what I'll do is, okay, so now let's go back to our pipeline. So we'll add one more task to a particular pipeline. And this particular task will deploy our application in our container instance. So let's edit this particular pipeline that we've created. And what I need to do is I need to add a task. So unfortunately, there is no direct task to deploy a particular image to our container instance. So what I need to use is basically the Azure CLI. So let's do that. So first thing you need to do is you need to make sure that your cursor is pointing at the right place. So it has to point to the end and it should point at the exact line where your task is. So let's add the Azure CLI and let's use the subscription that we have. And we'll be using the shell command. And the script location would be just an inline script that I'll add. And here I need to add the appropriate Azure CLI. So let's look for the Azure CLI to create a container instance. So I'll be using this particular command to do that. So let's just copy this and let's update it. So here I already have a sample of that particular command. Here I'll change the name and here I need to give the login server. The build ID will be automatically populated. And again, the login server, the container registry name and the password. And again, the DNS name symbol. So this is a unique name that should be there. So these are the appropriate values. Now to get more information about this particular command, I will send a link in the description below. So that particular link will help you out. So all that you need to give as a variable is the resource group, the container registry login server, as well as the container registry login name and the password. Now to get that information, let's go back to our cloud registry once. And within this registry, you can click on your access keys. And here you find the username, the password, as well as the server. So you can get all these three information from here. And the resource group in which you're going to put that particular resource would be just any of the resource groups that are currently available. So I will put it in the containers resource group. So these are the four variables that I need to populate. So let's copy this. And let's paste it here. And let's click on add. And here I have added the other task as well. So this particular task, it will just run the Azure CLI to create a container. And one more thing is the four variables, the resource group, the login server, the username and the password I have stored in this particular variable. I need to store in this particular variable. So let's click on new variables and let's store all those values. So let's just collect all those values before I do that. So let's add these values one by one. So I'll just copy this, click on variables, new variable, and the resource group would be containers. So let's just copy this, paste it here. Okay. And similarly, let's add the other ones as well. copy, paste. This is the username. Okay. And finally the password. So I'll just copy this, click on OK. And let's click on save. Okay, so we are all set now. So now what this particular task will do is it will first build this particular image, and then it'll call this particular Azure CLI script to create a container instance. So let's save it and run this. So now this particular pipeline will also get saved in the Git repository as well. So I will share that particular Git repository in the description below. So you can just go have a look at that. So let's click on save, and let's run this particular workflow. So this should create a new workflow, and let's just wait for this to complete. Okay, so our pipeline has finished and it just took around 2.5 minutes to run this. So let's go back to our application and let's look at a container instance and let's see whether an application has been created. And if you go to the container instance, you can see that this particular container got created. And this was the same container that we had created in our pipeline. So let's open a URL and let's see whether it works. And you can see that there is a hello world. So the final thing that we'll do is we'll update some change in our GitHub, and that should automatically trigger the build. So let's go back to our GitHub. So let's click on the server.js and let's edit this particular file. So let's just call this as hello world version 1 and let's save this. And let's go back to our pipeline and let's refresh this. And you can see that there's a new trigger that got created, and you can see that there is a new build that is getting created. So this particular new build will update the code. So let's wait for this to finish as well. So if I go to the build, you can see that the processes that are running currently. And if you go back to the GitHub repository, you can see that there is a Azure pipeline.yaml file. So if you have any issues, you can just refer to this particular YAML file. And this YAML file has all the tasks that is mentioned in the pipeline. So this particular link to the repository I'll give in the description below. So you can just go check it out. So let's wait for this particular process to finish. Okay, so our build has finished, and if you go back to the URL, you can see that it has been updated and it's Hello World version 1. That is the text that we had added in the Git is present here as well. So that is how you can create a CI/CD pipeline using your Azure pipelines. I hope this was useful. I will see you in the next chapter. Now, apart from your container instance, you can also deploy containers in your app service. So let's see how we can do that. Now, app service is a topic that I had discussed in my previous section. The link to that particular section I'll give in the description below, so you can just check that out. So let's create an app service and let's create it in a resource group. So I will create a new resource group. Okay. And here I need to give a name for my app service. Now here you have the option of either deploying your code directly or you're deploying your Docker container. So here we need to choose a Docker container and we need to choose Linux, or you can also choose Windows. So let's choose Linux for this particular example. And let's create our web app. And once we've created this web app, into this web app, we'll deploy our containers. Let's click on review and create. You can do it directly here as well, but let me explain to you after I've created my web application. Click on create. Okay, so it has been deployed. So let's click on go to resource. And here what you need to do is, the first thing we'll do is we'll click on this URL and see what we get here. So if I copy this and if I paste it in my browser, you can see that you get a default page. So what we need to do is we need to go back to our console, and here we have to go to a container, deployment container. And here you have the option of either deploying it through a container, a GitHub, or Azure pipeline. So what we need to choose here is the container registry. So the first thing you can choose, and here you can either choose single container or Docker Compose. So if you want to just have one container in your Azure App Service, then you choose this. Or you can also choose Docker Compose if you want to have multiple containers in your app service. So for this example, let's choose single container. And here you have the option of either deploying it from your Azure Container Registry, your Docker, or any other private registry. So we've already gone through all of this before. So let's choose the Docker Hub and let's make it a public repository. And all that I'll do is I will just deploy the latest Nginx server that is available. And that's it. So let's just save this. And let's refresh our page now. Okay, once you've deployed the Nginx directly, so let's also deploy something else. So here what I'll do is I'll go to my public, instead of public, I'll go to my private repository and let me log into my private repository. And I will use a private repository. The private repository that I have created, I'll be using this to deploy my application. So let's copy this. I'll just copy this and let's check out the tags for this. And the tag here is latest. So I'll be using the latest tag to deploy this. So let's go back to our Docker console. And here all that I need to do is I just need to copy that. And now let's save this and let's see whether our container gets updated. Okay, so we've deployed our application. So let's refresh this page and let's see whether it gets updated. And you can see that it's pointing to the Hello World. So it's pointing to the node application that we've created. So that's it for this lecture. I will see you in the next. Okay, so one advantage of using your app service is that there is continuous deployment that is already inbuilt for you. So all that you need to do is you need to go to your deployment center. And so currently I'm using a single container that is connected to my Docker Hub private account, and it's reading from this particular image. So what I need to do is I just need to enable my continuous deployment, and I get this webhook URL. I just need to copy this and I need to go to my Docker Hub account. So here I'm in my Docker Hub account and I'm in that same repository that is connected to my application. So all that I need to go do is I need to go to my webhooks and I just need to create a webhook and just need to paste that particular value and click on create. And once I have done this, let's go back to our application. Let's make a few changes. Okay, so I'm in my application right now. So let's add something in my application. So hello world, this is version 1 of my application. So let's build this particular application now and let's deploy it. So let's clear the screen. So I'll just do a Docker build. I will use the same tag, and this goes to the latest. And let's build this application. So let's clear the screen. Let's do a Docker image ls. So this is my application. I just need to tag it to my private repository. So let's do that. So let's do a Docker tag. This is my source image and this is my destination. and let's put the tag as well, and let's tag this application. And finally, let's do a Docker push, and let's push this to our repository. And now when this particular push is done, it will automatically trigger a new build in our app service. So let's wait for that to happen. Okay, so this is done. So let's go back to our GitHub account now. And let's go to our webhook and let's see if there's any history now. And you can see that one webhook was triggered. So all that we need to do now is we can just go to our deployment center again, and let's go and check the logs, and let's refresh this. And you can see that there is a new pull that is happening. Okay, so now if you check the application, you can see the changes are reflected in this particular URL. So that is how you can do continuous integration with your registry. So I hope this was useful. I will see you in the next. Okay, so in this particular chapter, we'll use the Azure pipeline to create our CI/CD. So the first thing that we'll do is we'll connect our GitHub to our Azure container registry using Azure pipeline. And once we've done that, we will use that image that we've stored in our container registry to push it into our app service. And this too shall be done using Azure pipeline. So let's see how we can do this. So let's go back to our console. And here what you need to do is you need to use the Azure pipeline, but we'll not be using it directly in app service. What we'll do is we'll go to our dev.azure.com and we'll create it from there. Okay, so I'm in my dev.azure.com. I've created a new project, and within this, let's create a new pipeline. So let's click on pipeline and let's click on new pipeline here. Okay, but before I do that, let me show you the GitHub repo from where I'm going to pull the code. So let's go to our GitHub account and let's go to a repo. And here I'll be using this container CI/CD. And this is the container that we'll be using. And this particular container just has a package.json, a server.js, and a Docker file. So we'll be using this repository to connect to our container registry via pipeline. So let's go back to our new pipeline. So the first thing you need to do is you need to connect your GitHub. So let's click on GitHub and let's choose the repository. So what I need to choose is this container CI/CD. So this is that particular repo. So click on that. And I need to push my code into my Azure container registry. So let's click on this. And let's open a subscription. So here you need to log in again. And you can choose the container registry. So I have one container registry and I'll be using this. And here you can give a name for your particular repository. So let's just call this as my Express app. And this would be the name of my repository. And this is the name of my registry within which this particular repository resides. So let's click on validate and configure. And let's save and run this. So when I click on save and run, what is going to happen is that, so when I click on save and run, this particular first part of our pipeline will be complete. That is, the GitHub would push the code to my container registry and it will build an image out of that particular code. So let's click on save and run and save and run. And if you go back to your repository, you can see that there's a file that will get generated, and this file has got all the commands that is needed. So you can see that there's a file called Azure pipeline.yaml file that gets created, and this has all the configuration that is needed. So let's wait for this particular build to finish. Okay, so the build is done. So let's go back to our repository. So let's click on our container registry, and there should be a new repository that gets created. So let's open this and click on repositories here. And you can see that this Express app repository gets created. So let's open this And you can see that there is one image present in our container registry. So once this is done, let's do the second part of our configuration, that is connect our Azure Connect container registry to our app service. So let's go back to our CI/CD pipeline again. And what I need to do is I need to edit my current pipeline. I'll click on edit. And I need to choose the appropriate task. So the task that I need to choose is Azure Web App for Containers. Let's open this. And here again, let's choose a subscription. So let's create a new subscription. Click on authorize. Then you can choose your app name. And here, let's deploy this. And you can just give a app service resource name and it'll be in production. And this is the important thing, that is you need to give the image name. So let's go back to our repository once again. So you can go to your access keys first. And you need to copy the login server. So let's copy this, paste it here, slash, and you need to give the name of your repo now. So this is my repo name, paste it here. And you also need to give the build ID, which represents our tag. So I'll just copy this variable and I'll just paste it here. And that's about it. So let's add this particular task here. Okay, so we just need to reformat this. Okay, now it's properly formatted. So let's just save this, save, and let's run this once. Click on run. And you need to authorize this as well. So let's click on view and permit here. Okay, so this is completely low. Let's go back to our app service once more. Click on this. And let's click on our URL. And you can see that there's Hello World version 1. So the next thing that we'll do is we'll make some changes to our code. So let's go back to our code here. Click on server.js. I'll edit this. And let's make this version 2. And let's save this. And this should automatically trigger a run. So let's go back to our pipeline once. And you can see that there's a new build that is happening. So let's wait for this particular build to be over. Okay, so our build has succeeded. Let's go back to our URL. And you can see that it has changed to version 2. So that is how you can use your pipeline to create a CI/CD. So I hope this was useful. I will see you in the next chapter. Hi, welcome to Azure Basics Part 2. In this particular series, we talk about Azure architecture, network, compute, and load balancers. But before we go through this particular series, it is important for you to know certain concepts like Azure Active Directory, resource group subscription, and resources. So please go through the first part of the series before you tackle this. The link to that first part of the series I will send in the description below. Just go through that before you tackle this particular series. So I will see you in the next chapter. Okay, now let's talk about region in Azure. A region is a set of data center that is deployed within a latency defined parameter, and it is connected with each other through a dedicated regional low latency network. And a basic definition of data center is that it's a physical building that houses a group of network computer servers together. So let's look at all the regions that are available in Azure. So as of September 2001, these are all the regions that are available in Azure. So the link to this particular URL, I will send in the description below. So you can just check out this particular URL to see all the regions that are currently available. One more thing to note is that the ones which are in gray are the ones which are coming up and are not currently available. So if you watch this particular URL in a later date, you might see that some of them have turned to green and are not gray anymore. Now, one thing to note is that these regions contain a set of data centers, and each of these data centers are connected with each other through low latency networks. So that is one thing you must remember. And anytime you create an Azure service, be it a virtual machine or a cloud storage account, these services are created within these particular regions. So that is one thing that you must always remember. So I hope this was a useful lecture. In the next lecture, we'll talk about availability zones. Now, if you go through your regions within Azure, you will notice that some of these regions have something called as an availability zone. So for example, if you click on US East, it states here that this region is with availability zone. And if you look at some other regions, so for example, if I open South India, it says that it is just a region. So what it implies is that this particular region does not have an availability zone. So let's look and see what an availability zone is. So availability zones are unique physical locations within an Azure region. Now each zone is made up of one or more data centers and is equipped with independent power, cooling, and networking. To ensure resiliency, there is a minimum of three separate zones within each particular region. So in this particular diagram that you see that there is an Azure region with three availability zones, and each of these availability zones has its own power, cooling, and networking facility that is independent of each other. The physical separation of availability zones within a region protects application and data from data center failures. So the main concept here for you to understand is the concept of high availability. So let's assume you have an application and this application is present in all the availability zones. So in case even if one of the availability zones goes down, you still have the application present in the other two zones, thereby making that application highly available. Now the concept of high availability is very important to make your applications resilient to failures. Now, one thing to note is that not all regions have availability zones within them. So, for example, East US has, but South India does not. So, if you're making an application that requires high availability, then you should make them in a region that has availability zones within it. So, that's it for this lecture. In the next lecture, we'll talk about geography. Okay, so now let's talk about Azure geography. And Azure geography defines an area of the world containing at least one Azure region. Now, geographies define a discrete market and typically contain two or more regions. So, what is the need to have a geography? So, what is the need for geography? The main need for geography is to preserve data residency and compliance boundaries. So, there could be a situation where you've created an application and data, and that has to reside within a certain geography. So, in order to do that, there is this segregation of geography that is present in Azure. So, now let's look at the map and see how Azure geography looks like. So let's open the infrastructure map for Azure. So if I open the infrastructure map and just search just based on geographies, you can see that these are all the geographies that are available. So if you open the China geography, you can see that this China geography has 5 regions. So it's not mandatory that all geography should have more than one region. So for example, if I open the Greece geography, you can see that it has just one region. So the important thing to remember is that if your application has to meet with certain data residency and compliance requirements, then that particular data should reside just within the regions of that particular geography. So for example, if I'm creating an application in India and the data should reside just within the Indian geography, then I will store the data within these 3 regions of the India geography so that it meets with all the regulations and the data compliance. So that is something that you should always remember. So in the next chapter, we'll talk about region pairs. So now let's talk about regional pairs. A regional pair consists of 2 regions within the same geography. Now, Azure serializes platform updates across regional pairs, ensuring that only one region in each pair is updated at a time. If an outage affects multiple regions, at least one region in each pair will be prioritized for recovery. So now this is helpful, especially if you're planning for disaster management. So whenever you want to take a backup of your application and data, it should be in one pair of that particular regional pair. So now let's look at all the regional pairs that are present currently in Azure. So I will send you a link to this particular document. This particular document shows all the regional pairs for all the geography. Now, for example, if you're in China, then there is a regional pair between China North and China East. So if you're building an application, let's say in China North, you would want the backup of this particular application to be in China East. Now, Azure also uses the concept of regional pairs internally in a few of its services. The most important service is the storage account. So you can use storage accounts to store objects like files, tables, etc. So what you can do is when you click on this create storage account, what happens is when you choose the geo redundant storage, a backup if your data is taken in one region of that particular regional pair. So this is done internally itself, so you do not have to worry about manually taking backup of your data in storage account. This also is applicable for Cloud SQL and other services as well. So this helps in making your disaster recovery easy, especially for your storage and for your SQL. So that's it for this particular chapter. I will see you in the next. So how do you design an application architecture in Azure? So whenever you're designing an architecture in Azure, you should make use of the fact that there are multiple availability zones and you should create virtual machines across availability zones and they should be replicated synchronously. The same is the case if you're using a database as well. Your database should reside not just in one availability zone, but it should be synced across multiple availability zones. So that is how you can achieve high availability in Azure. But for some unforeseen reason, your entire region goes down. That is when disaster recovery kicks in. And you should always have your backup stored in your region pair. And this should be done asynchronously. So all the data and all the application data that you have, they should be asynchronously stored in your region pair. And whenever the region goes down, you should make use of the data that you have backed up to again bring up your application. Now, these two concepts are very important when you're developing your architecture, that is high availability and disaster recovery. So this is a very brief overview, and in the upcoming chapters as we design architectures, we'll be making use of these two concepts to design architectures that can not just handle availability zone failures, but it should also handle region failures as well. So that's it for this particular chapter. I will see you in the next. So now let's check out all the services that are available in Azure. So to get the latest services that are available, you can always refer to this particular URL. So let's look at this particular URL. So if you go through this particular URL, you can see that the services are based on certain categories. So for example, there is one for AI and machine learning. There's one for compute, there's one for containers, database, etc. So the most important ones are the compute, the containers, the database, identity integration, etc. So we'll be going through these services one by one. So let's look at the most basic ones, that is the compute one. So if you go through the compute one, you can see that there is Kubernetes available, there is static web apps available, there's virtual machine scale sets available, virtual machine. So we'll start off by talking about compute because compute has most of the main services that we would be using initially itself. And then there's also one for containers. So containers include things like container instances, container registry, Azure functions. So even these come under containers. And then there are databases that are also available. So this includes things like Redis, Cosmos. So this list is very comprehensive. So you can just go through this particular URL and these services keep changing and there are new ones that keeps getting added. So just make sure that you bookmark this particular URL and this will always come in handy if you want to check all the latest services that are available. So that's it for this particular chapter. I will see you in the next. So now your services in Azure can also be categorized based on whether it's a zonal service, a zone redundant service, or a non-regional service. A zonal service is one which is pinned to a specific zone in a region. So an example of this is a virtual machine. So when you create a virtual machine, you're creating it in one particular zone of your particular region. So a zonal service is not inherently highly available. It has to be made highly available by having it synchronously replicated across zones within a particular region. A zone redundant service is one which is already replicated and distributed across zones automatically by Azure itself. So a primary example of this would be the Azure SQL database. So whenever you create an Azure SQL database, the primary hassle of replicating and distributing it across zones is done by Azure itself. So it is inherently highly available. So you do not need to make any other settings to make your particular resource highly available. And then there's also something called as a non-regional service. Now these are services that are available even if your particular region goes down completely. A very important example of this would be the DNS. So even if your Azure region goes down, your DNS still has to be up. So that is the reason why you have a non-regional service is one which is not dependent on a particular region. So even if a particular region goes down in Azure, your non-regional services would still be up. A primary example of this is basically the CDN and the DNS. So your DNS should be up even if your particular region or one particular region goes down. So DNS is a very basic example of a non-regional service. So now let's look at some of the services which are zonal and zone redundant. So if you look at this particular list, you'll see that the Linux virtual machine and the Windows virtual machine are zonal services. Now these can be made zone redundant by having them in a virtual machine scale set. Now that's something that we'll talk about later as we discuss about the compute services available in Azure. And if you look at the database, you'll see that the Azure SQL database is primarily a zone redundant service. So you do not have to worry about replicating your SQL database in multiple zones in a region. So I will send the link to this particular list in the description below. So you can just go through this particular list and just check. So whenever you're creating a highly available application, just make sure to go through this particular list and see which are redundant and which are just zonal services. And whichever are zonal, they have to be made redundant so that your entire application becomes highly available. So that's it for this particular lecture. I will see you in the next. Okay, so the first service that we'll talk about in this particular course is not going to be compute or storage or database, but it's going to be VNet. And I feel that if you want to understand any cloud platform properly, you should understand how the private network for that particular cloud works. So in Azure, the Azure Virtual Net or the VNet is the fundamental building block for creating your private network in Azure. Now you can create your Azure private network using the following RFC 1918 IP range that is mentioned in this particular screen. Now, your Azure VNet can also be divided into subnets. So what does subnet do? So subnet enables you to segment the virtual network into one or more subnetworks and allocate a portion of the virtual network's IP address to each of the subnet. So now let's look at this diagrammatically and let's see why VNet is so important for you to understand. So a VNet here is basically a private IP range. In this particular example, the IP range that I have given is 10.0.0/16. Now this is an RFC 1918 private IP range. Now this network also consists of 3 subnets, and these subnets have a range of /24. So that is equivalent to around 255 IP addresses for each subnet. Now of course some of the IP addresses are used by Azure itself, so you can round it about to around 250 usable IP addresses for each subnet. Now what are the services that you can put in these subnets? So the services include the following. You can have for compute virtual machines like Linux or Windows. You can have virtual machine scale sets, Azure Batch, Cloud Service, etc. Now, these are very important services, especially the first one, that is the virtual machine Linux or Windows. So, your backbone of any application would always be a virtual machine, and your virtual machines would reside within the VNet. So, that is one important concept you have to understand. Now, apart from that, the next most important ones are basically the Azure Kubernetes service and the container service, which also are fundamentally used for creating applications. You also have data like Redis cache and Azure SQL managed instances. Now, these are also important for creating applications. So just remember how important VNet is. So most of the services that are actually important for you to create your applications resides within the VNet. So it's important for you to understand the concept of VNet initially itself. Now, apart from that, you can also peer your VNets. So here in this particular diagram, you can see that two virtual networks appeared. And the advantage of this is that you can actually communicate between virtual machines in both these networks using just the private IP addresses. So you do not have to go through the internet to communicate with each other if you have peered networks. So that's one important concept you should remember. And finally, if your application within your virtual machine also wants to use other services like storage account, your event hub, your service account, it can do that via the service endpoint as well. So this enhances the functionality of your application within your virtual machine or your container. And apart from that, you can also have a site-to-point communication where if you have a workstation which you want to connect to your VNet, you can do that via the site-to-point. Or if you have an on-premise network which you want to connect to your VNet, you can do that via the point-to-point communication. Now, these are some of the basic functionalities of VNet. Now, I will explain these in details while I'm explaining to you all these services. So one important takeaway from this particular lesson is that VNet is very important and it forms the bedrock of all the application that you would be creating in Azure. So I hope this was a useful lecture. I will see you in the next where we'll create a VNet. So I'll see you there. Okay, so I'm in my Azure portal. So what we'll do is we'll create a VNet. So to do that, you can just type VNet here and you can open your virtual networks. You can also go to your all services and you will find VNet under networking. So you can just click on networking and you'll find virtual networks here as well. So let's open our virtual network. And here you can see that I already have a VNet present. So let's create a new one. So you can click on create and you can either use an existing resource group or create a new one. So let's create a new resource group. I'll call this dev VNet. Click on OK. And here you need to specify a region. So a VNet is a regional construct, so it has to be within a particular region. So let me just make it in East US. So I'll click on East US and click on review and create. And you need to give a name for your VNet as well. So I'll just call this as VNet, dev VNet. Click on review and create. And by default, you can see that it creates a VNet with this particular address, and it just creates one default subnet. So what we need is we'll create a few more subnets once this particular virtual network is created. So meanwhile, everything seems okay. So let's just create this particular VNet. So as I said previously, this VNet would have this particular address space, that is 10.0.0.0/16, and it will have one particular subnet within it, and that will be the default subnet, and it will have this particular address. So let's create this VNet, and once we've created this VNet, we'll add a few more subnets within this particular virtual network. And again, the name of my virtual network would be just dev VNet, and it will be created in this particular new resource group that I've created called dev VNet as well. So let's create this particular virtual network. Been created. So a resource has been created. So you can just go to our resource. So you can click on this particular button, and you can see that this particular virtual network has been created. It has this address space, and let's check out the subnets. So currently there's just one subnet by the name of default, and it has this address space. So let's create a new one. And it has so many IP addresses available within it. So let's create a new subnet. So let's click on subnet again. So I'll just call this as subnet 1, and it'll have this particular address space. So that's about it. Let's click on save. And let's create one more subnet. Click on subnet again, and you can see that the address space changes from 1 to 2. So I'll just call this as subnet 2. Click on save. And you can see that I've created 3 subnets. And that's it for this particular chapter. So now you know how you can create your virtual network and you can create subnets within it. So in our upcoming chapters, we'll be using these subnets. So in the next chapter, we'll be using these subnets to create virtual machines within them. So that's it for this particular chapter. Now, one more thing, there are other settings within these virtual networks as well. Now, these other settings we'll explain as we proceed further towards in this course. So that's it for this chapter. I will see you in the next. Okay, so now that you've created your VNet and your subnet, let's create a virtual machine in one of these subnets. So whenever you're creating a virtual machine, you're not just creating that virtual machine, you're also creating other resources to enable your virtual machine to work properly. And these other resources include the disk, and the disk contains the operating system which would be running your virtual machine. Apart from that, it also creates an NIC, that is a network interface card. And this network interface card will be connected to an IP address, a public IP address, and a private IP address through which your virtual machine can communicate with other devices. And finally, it creates a network security group. And the role of the network security group is to allow egress and ingress traffic to and from the virtual machine. So in total, there are 5 resources that gets created. There is the virtual machine itself, then there is the disk, the NIC, the public IP address, and the network security group. So in our next chapter, we'll create our first virtual machine in Azure. So I'll see you there. So here I'm in my dashboard. Now to create a virtual machine, you can just search for virtual machine here, or you could go to all services and underneath compute, you'll find virtual machine. So let's click on virtual machine. I'll create one. I'll click on create virtual machine. And we'll be choosing all the defaults. So the only thing that you need to fill up is basically the resource group. So I'll be choosing the resource group that I had created previously. You have to give a name for your virtual machine. So I'll just call this as VM1. And it's going to be in the East US region. And here you can choose the image that you want to run. Here you have multiple choices. You can choose your Red Hat. You can also choose Windows machine as well. So if you're using Linux, then you have quite a few options. You can choose Ubuntu, you can choose Red Hat, you can choose Oracle Linux, Debian, etc. So let's choose the default, that is the Red Hat Linux. And then another important parameter is the size. So if you click on this particular all size, you have the option of choosing different VM sizes. So I've chosen the least expensive one, which is B1S. So if you have a workload which is more CPU intensive, then you can choose a more expensive machine. So here you have multiple choices. So I will give you a documentation on all these VM sizes. So you can choose based on the kind of workload that you're running. So because this is just a very basic application that we'll be running on this virtual machine, so I'll just choose the most basic, that is the B1S. And then here is the authentication type. You can either have it as an SSH public key or a password. So for this example, let's just choose password. And I will just give a name for my user. Call this as Azure user. And here is basically the inbound port rule. So select which virtual machine ports are accessible for the public internet. You can specify more limited or granular network access on the networking tab. So currently I've just chosen SSH22. So currently I can access this particular machine through SSH. And now let's go to disk. And here you can see that a disk gets created for you, and it's going to be premium SSD. Here you have the option of choosing premium SSD, standard SSD, and standard HDD. So this particular premium SSD gives you the maximum performance. So I will give you a link in the description below. You can just check that out to see the differences between all these three disk types. So we will just leave this as premium. And you can also additionally add disks if you like. So currently, let's not attach anymore. Let's just keep one disk for the operating system. Let's go to the networking tab, and this is a very important tab. So here basically you can see that it's connected to the virtual network dev VNet. If you want to change it, you can change it as well, but let's just keep it in dev VNet. And it's going to go to the default subnet. So this is the first subnet that was automatically created when we created this subnet. You can place it in another subnet as well. So let's place it in subnet 1. And here it will also create a new public IP address. So this is one thing that will get created apart from the disk that you saw in the previous tab. And it also creates a new NIC group. And this NIC group is going to be basic. And it allows the following SSH22. So this is the same port number that we had specified in the first page as well. So it's basically this particular inbound rule. Now, if you want your virtual machine to have no access to the internet, you can just click on none. And when you do that, and if you go back to your basic, you can see that that particular setting also changes, and it gets changed from allowed select ports to none. So for the time being, let's just keep it as allow the selected port, and let's choose SSH22. And load balancing is something that we'll see in the upcoming chapters. So the management is something that we will also see in the upcoming chapter. So another important factor is the auto shutdown. So you can basically auto shut down your virtual machine at this particular time if you wish. So this is also auto enabled, and its shutdown time is 7 p.m. So this is the standard setting that we have. And in the advanced tab, you can also add custom data. So this custom data is something that we'll see in the upcoming chapters. Now, this is also something that's very important. So in your custom data, you can add scripts that can be run when your virtual machine gets created. So this is something that we'll use extensively in the upcoming chapters. So let's just leave it as it is. And apart from that, the others are all tags and review plus create. So let's click on create. So you can see that the validation has passed as well. And here it gives you a pricing per hour. So this is based on your local currency. Let's click on create. And let's just wait for this particular machine to be up. Okay, so my virtual machine has got created. So what we'll do is we'll try to connect to this virtual machine. So all that I need to do is I just need to copy the public IP, and let's just open PuTTY. Here I just need to give the IP address and click on open. Click on yes. So I can just give the user and the password that I created previously. And you can see that I'm logged into the machine. And the last thing that we'll check is we'll go to a resource group, and we'll see all the resources that have got created. So this is the dev VNet that we had previously created in our resource group. Now, apart from that, you can see there's a virtual machine, a public IP address, a network security group, a network interface, and a disk that got created within this particular resource group. Now, apart from the VNet that we had previously created, all the other resources were created when we created this particular virtual machine. So I hope this was a useful lecture. I will see you in the next. So in our previous chapter, we had created a virtual machine. In this particular chapter, we'll create an availability set. An availability set is a logical grouping of virtual machines that allows Azure to understand how your application is built, to provide for better redundancy and availability. Now, to understand availability set and how virtual machines are grouped together, you have to understand two concepts, and they are the fault domains and the update domains. The fault domain defines a group of virtual machines that share a common power source and a network switch, whereas the update domain indicates groups of virtual machine and underlying physical hardware that can be rebooted at the same time. Now, these reboots generally happen during maintenance. So, whenever there is maintenance, all the virtual machines within a single update domain would be rebooted at the same time. Now, one important thing to remember is that only one update domain can be rebooted at a time. So, this particular diagram that you see has 3 fault domains and 5 update domains. And virtual machines are distributed across this particular availability set so that it gives you the maximum redundancy and availability. So, let's assume that you have around 7 virtual machines. So in that case, the first virtual machine would be in update domain 0, and the fifth one would be in update domain 4. Again, the sixth one would again go to update domain 0, and the seventh would again go to update domain 1. Now let's assume that there is maintenance for update domain 0. Now in that case, virtual machine 1 and virtual machine 6 would be rebooted at the same time. And similarly, if one of the fault domain goes down, let's say fault domain 0 goes down, then again your virtual machine 1 and 6 would be down at the same time. So let's go ahead and let's create an availability set. Okay, so let's create an availability set. Now to find your availability set, you can just search for availability set here. Or you can go to your all services, and underneath compute, you can find your availability set here. So you can just open this, click on create. And here you need to give a resource group. So let's create it in the same resource group. Let's go down. And we need to give a name for our availability set. So I'll just call this as availability set 1. And here you can mention your fault domain and update domain. So what we'll do is we'll have 3 fault domains and we'll have 5 update domains. So now these update domains can be configured till 20. So let's configure it till 5. And let's click on review and create. And let's create this availability set. Okay, once you've created your availability set, you cannot add an already existing virtual machine to an availability set. So what you need to do is you need to create a new virtual machine. So let's do that. So let's wait for this to deploy. And once this is deployed, let's create a new virtual machine. So as you can see that this particular this particular availability set is created. So let's go back to our virtual machine again. So as you can see that there's an already existing virtual machine. So let's create a new one. So let's click on create virtual machine. And we'll create it in the same resource group. I just call this as VM2. And here under the availability options, you can open your availability options and you can search for availability set. So you can just click on availability set. And once you've done that, you'll get a new drop down, and underneath you get the availability set that you just created. So you can just click on the one that you've created and everything else remains the same. So let's click on review and create. And you can create this virtual machine. So you can keep adding more and more virtual machines and you can keep adding them in the same availability set. And Azure will make sure that your virtual machines are evenly distributed across both fault domains as well as your update domain. So that's it for this chapter. I will see you in the next. Okay, so now let's talk about custom data. So custom data is basically a text field that is available whenever you're trying to create a virtual machine. Now in that particular text field, you can enter what is called as a cloud init configuration YAML file. Now using that, you can install packages, write files, or configure users and security during the initialization phase of your virtual machine. Now this cloud init is a standard configuration that is used across cloud platforms. So you can just check out this website and see all the providers who use Cloud Init to initialize their virtual machines. Now, at the bottom, you can see a very common configuration. Now, in this particular configuration, all that the Cloud Init does is it does an upgrade on your package manager, and then after that, it just installs the HTTPD, that is the Apache web server. So let's look at an example and let's create our Cloud Init file. So here I have a very basic Cloud Init file. Now, this particular Cloud Init file, what it does is it installs 2 packages, that is the Node.js and the NPM. And after that, it writes a particular file called index.js. And the contents of this index.js file is this. So this is a very basic web server using an Express framework. And after it's written this particular file, all that it does is it runs these certain commands. So it goes to this particular folder which has this particular file, and then it runs an npm init, and it installs the Express framework. And after it's installed the Express framework, the next thing that it does is it installs a framework called Forever. Now, using Forever, you can run this particular application in the background itself. So all that it does after this particular Forever install is it just runs this index.js file, that is this particular file in the background, and then we can access this particular URL. So let's see how this works. So what I'll do is I'll just copy this. Now this particular file I will also send in the description, so you can just check that out as well. So let's go to our virtual machine. So what I'll do is I click on create. I'll create a new virtual machine. So I'll click on dev VNet. So this is a resource group. I'll call this as VM itself. Now what's important here is that you need to also open the port 80 for your web server. And that's about it here. So all that we need to do is we need to go to the advanced tab, and under custom data, so this is the text field I was talking about. You can just paste that particular script, and that's all that you need to do. You can just click on review and create. Okay, so the validation has passed here. Now if you go to the bottom, you can see that the cloud init is yes. So that means there is a cloud init for this particular virtual machine. So what I'll do is I'll just click on create. Okay, so a virtual machine is created. Let's go back to a virtual machine. Click on home, virtual machine. And let's try to access this using a public IP. So I'll just copy this. So this takes a few minutes to start up. So let's just wait for this to finish. And you can see that I get this particular message. Now this is the same message that I had printed here as well. So hello world from host. So this is how you can use your custom data to initially install softwares and packages itself. So I hope this was a useful lecture. Now CloudNet itself is a huge topic, and it takes a lot of time to understand CloudNet. So just go through the documentation, and if you have any issues with that, just please do not hesitate to get in touch with me. I'll help you out. So I'll see you in the next chapter. So in this particular chapter, we'll talk about user data. So user data is a set of scripts or any other metadata that you would want inserted into your Azure virtual machine at provision time. Now, this can include information like if you have a storage account and if you want to know the URL of that particular storage account, or maybe even the environment that you're running. So all these metadata, if you want your VM to access it, now these information can be stored in your user data. And this information can also be retrieved by using the metadata service. So a metadata service is basically a URL through which you can access all the user data information. The first thing we'll do is we have already created a virtual machine. We'll insert some user data, and then we will log into that virtual machine, and using this particular URL, we'll try to access that particular metadata. So what I'll do is I'll try to insert this particular metadata. So this just has some random information, the name of the virtual machine, the location, and certain property like storage profile, the URL for your particular storage. Now this could be any JSON format, so it really doesn't matter. So let me just copy this. Let's go back to our virtual machine. So the first thing I'll do is I'll go to my configuration, and in my configuration, there's something called as modify user data. So I can just open this and I'll just paste the information. So I've already pasted it here. So it's basically the same JSON. So let me just paste it again. And all that I need to do is I just need to save this. And now the next thing I'll do is I will log into this virtual machine, and I'll try to access the same data using the metadata service. So let me fetch the public IP address. So this is the public IP address. Let me just copy this and let's try to log in. So I'll be using putty to log in. And let me just copy this particular URL. So all that I need to do is I'll just copy this. And let's just clear the screen. And you can see that I get the same information. So this is basically the same JSON that I had pasted in my configuration. So if I go back to my configuration, so it's basically the same JSON file that you see over here. So user data comes in handy whenever you want to store some data that you want your virtual machine to access. So now one important caveat is that you should never store your secret or your password within your user data. So that's something that you should always remember. So that's it for this chapter. I will see you in the next. So in this particular chapter, we'll talk about virtual machine scale set. So Azure Virtual Machine Scale Set lets you create and manage a group of load balanced virtual machines. So the number of virtual machine instances can be automatically increased or decreased depending on the load or depending on a defined schedule. Now, ScaleSet provides high availability to your application and allows you to centrally manage, configure, and update a large number of virtual machines. So with virtual machine scale sets, you can build large scale services for areas such as compute, big data, and container workloads. So virtual machine scale set is just an auto scaler. So based on whether your demand increases or decreases, or based on a certain schedule, you can increase the number of instances or decrease the number of instances. So let's go ahead and let's create a virtual machine scale set. Okay, let's create a virtual machine scale set. To do that, you can just search for virtual machine scale set here, and you'll find it here. Or you can go to your all services and you'll find it under compute. So under compute, you can find your virtual machine scale set. So let's open our virtual machine scale set and let's create one. So let's click on create. And I'll be using the VNet resource group. You need to give a name for your virtual machine scale set. So I'll just call this as VNet V scale set. It'll be in the east of US, none. And it's going to be an Ubuntu and the most basic size. And let's have this as a password. So as you can see, this is as good as creating a virtual machine, but there is an exception. So let's create this username first. Okay, let's go to next. So all this remains the same. And here I'll be using the VNet virtual network. Now the virtual machine scale set and the load balancer, they work hand in hand. But for this particular lecture, let's just leave it as unticked. I will show you how the load balancer works in the load balancing section. So let's just leave this as unticked for the time being. So now let's go to the most important part, and that is the scaling. And now here under scaling is the most important tab. So here the initial instance count is the number of virtual machines that will be created initially when you create this virtual machine scale set. And this is by default set to 2. And here there are two policies, the scaling policies, that there is one manual and then there is one custom. So if you set it to manual, there will be always two instance counts. There will be always two instances that would always be running in this particular virtual machine scale set. So let's just leave this to manual. In the next topic, we'll discuss the custom. So let's go to management. And the management here is akin to the management that you will find in creating a virtual machine. And here is the health check. So health check enables you to check the application for your particular virtual machine. So what this does is it'll do a ping on HTTP port 80. And if it returns a 200 response, that means the virtual machine is working properly. So this is just to check the application health and not the health of the particular server. So this is something that we'll use extensively as well. And then apart from that, let's go to advanced. And here under custom data, what I'll do is I'll copy the same script that we had used previously as well. So what this does is it creates a Express node application and it runs it on the background. So let's copy this. Now this particular script I will paste in the description below, so you can just have a look at this. So all that this does is it just creates a node web server and it runs it in the background. And let's go to our next, click on review and create. And let's just validate all that let's just validate all the settings that we've made. So the initial instance count is going to be 2. So once we run this, there'll be 2 virtual machines that will get created. So there is also a health check. So what this health check, again, like I said previously, it'll just ping on port 80 on the web server that we'll create. And if it returns a 200, then this particular health check will pass, else it will fail. So let's create this virtual machine scale set. So our scale set has been created. So you can go to our instances now. And here you can check the status of your particular instances here. So you can see that there are two instances that have gotten created and they're both in the running state. And here the other thing you need to check is the health state. So the health state for this particular application is healthy. So what this means is that our web server is also running properly, the node web application that we had created. So the next thing that we'll do is we'll go to our scaling section and we will change the instance count from 2 to 3. So currently I have 2 instances running. So if I change this to 3, then the scale set will create a new instance and there'll be a total of 3 instances that gets created. So let's click on save. And once that is done, if we go to our instances, and if you go back to the instances, you can see that there are 4 scale sets. So what happens is that there are 2 new virtual machines that get created, and out of the previous 2, one of them will get deleted. So there will be 3 total in total that's running. So let's just refresh this and let's wait for this particular process to complete. And now you can see that there are a total of 3 instances, and this is taking some time for this to turn healthy. So this is how you can scale up your application. And similarly, if you want to scale down, you can always change this from 3 to, let's say, 1, and it will be scaled down to 1. Now, if you do not want this process to be created in such a manner that one extra resource or one extra virtual machine gets created, you can always go to your configuration and you can enable the over provisioning. So here what happens is you can disable this over provisioning, and if you turn this to off, there will be always 3 resources that gets created instead of 4. So what this does is that whenever over provisioning is turned on, the scale set action spins up more virtual machines than you asked for and then deletes the extra virtual machine once the requested number of virtual machines are successfully provisioned. So if you do not want that to happen, you can always turn this to off, and then instead of 4, there will be only 3 resources that virtual machines that get created. So that's it for this lecture. In our next lecture, we'll talk about how custom auto scaling works. So I will see you in that particular chapter. So I will see you there. Okay, so in our previous chapter, we had created 2 instances and the scaling that we had used was manual. So in this particular chapter, let's use custom auto scale. So let's click on custom auto scale, and what we'll do is we will create a custom auto scale based on CPU utilization. So let's imagine that your CPU utilization goes below 50%, your average CPU utilization for both the instances. Then what we will do is we will decrease the instance count by 1. And if in case the average CPU for both the instances goes above 70%, then we'll increase it by 1. So let's do that. So to do that, let's go to our scaling here. You can just click on custom auto scale. And here what you need to do is you need to scale based on a metric. And here you need to add a scale. So before doing that, let's also change the minimum. So the current minimum is 2. Let's make it as 1. And let's make the maximum as 3. And after that, let's add a rule. So the first thing that we'll do is we'll add a rule to decrease the number of instances based on the CPU utilization. So what we'll do here is we'll take the average. The metric namespace remains the same. And here you choose the percentage CPU. Of course, you can choose it based on other metrics as well. But the most commonly used one is the CPU percentage. And here it shows the current CPU average. So what I'll do is I will just change it to if it's less than or equal to 50%. And here the duration is 10 minutes. So what this duration means is that it will check the duration for your CPU utilization for the last 10 minutes. So you can increase this or decrease it based on how much you want the duration to be. And finally, the operation here is increase count by. So what we'll do is we'll decrease count by 1. And the cooldown period here specifies to the amount of time to wait after a scale operation before scaling again. So for example, if it scales down, then it waits for 5 minutes cooldown, and it's only after that the next scaling operation takes place. So let's click on add. Okay, we've done a scale in policy. Let's do a scale out policy. And this will be similar as well. So the only difference here is that I will increase count by 1, and the matrix and the average CPU utilization here should be greater than 70%. So if it's greater than 70%, then the CPU utilization increases by 1 count. And just remember that it can only increase up to a maximum of 3. So if it goes, it cannot go beyond 3. And everything else looks correct. So let's just save this. And the first thing that it should trigger is that it should trigger the scale in policy because the CPU utilization is currently less than 50%. So if I go back to the instances what should happen is that one of the instances should get deleted, and that's precisely what's happening. So one of the instances is getting deleted, and the scaling in is kicking in. That's why you'll just see one particular instance. So let's just refresh this. And you can see that just one of the instances is running right now. So the next thing that we'll do is we will simulate a situation where the CPU utilization for this goes above 70%. And once that happens, then the scale out policy will kick in and another CPU and another virtual machine will be created. So let's do that. Okay, so the next thing that we need to do is for this particular instance, we need to spike the CPU utilization. Now to do that, you can't access this particular machine via the public IP because it does not exist. So you have to access it via the private IP. Now to do that, I need to create another virtual machine that has a public IP and that is within this particular virtual network. And once I log into that machine, I can SSH into this particular machine. So let's do that. So I go to my home instance. I go to my virtual machine. Okay, so we have a virtual machine that is within the same network. So what I'll do is I will log in using the public IP address. So let's copy this and I'll be using putty to log in. And from here, I'll SSH using the public private IP address. So I go back to my scale set. Instances. I'll open this instance. And let's just copy this private IP. So I'll SSH into this using the private IP. Okay, so once I'm logged in, what I need to do is I need to run a command that will increase the CPU utilization. So I was able to find a command like that. So the command that I have used is this particular commands. So I'll be using this particular command to increase the CPU utilization. Now, this particular page, I will send a link in the description below. So there are other ways to do it as well. So this was the easiest way I found. So I'll just copy this and I'll paste it here. And once that happens, let's do a PS. And I can run the top command to get the CPU utilization. Now you can see that the CPU utilization has gone above 99%. So now let's wait for another instance to get created. So let's go back to our console again. Let's go to our scale set. And here you can see one new extra instance got created because of the scale out policy. So I hope this was a useful lecture. You can always try other kind of varieties as well. So currently what I had tried was the CPU utilization. You can always go and check it out for other metrics as well. So instead of using the CPU percentage, you could also use something else as well. So for example, you have a wide variety of options. You could even go for CPU credit or even data disk or some of these other options as well. So I hope this was a useful lecture. In our next lecture, we'll see on how we can scale in and scale out based on schedules. So I'll see you there. So you can also have a scaling policy based on a schedule. Now to do that, you need to go to your custom auto scale again. And here you need to add a new scale condition. Now the default scale condition does not have a schedule property. So you need to create a new one. So let's click on this. So here you have the option of having a schedule either based on a metric or on a specific instance count. So for this particular example, let's do it on a specific instance count. And here, what I will do is I will keep the instance count as 3. So what will happen is you can either have it on repeated days or you can have it on a specific start and end day. So what I will do is I will take my local time zone, which is Indian Standard Time, and currently the time is 12:43. So at 12:45 on this particular day, I will increase the count from 1, which is the current number of instances that is running, to 3. So let's just make this as 45. And similarly, I also need to specify the end date. So the end date I will specify would be just 1 p.m. So for 15 minutes, there will be 3 instances running. And after the 15 minutes is over, it's again going to go back to 1 instance. So that's all that it will do. So let's just save this as well. So let me repeat the scaling schedule again. So at 12:45 on this particular day, the number of instances will increase or scale out from 1 to 3. And similarly at 1 p.m., that is after 15 minutes, it will again scale into 1 from 3. So let's save this and let's go back to our instances and let's see what happens. So currently you can see that there's just one instance running. So let's just wait for 12:45 and let's see what happens. Now, if you refresh this, you can see that three instances have got created, and similarly, one of them will get deleted after all these three have been created. Now, this is again because of the property that I spoke to you in our previous chapter, because there is over provisioning enabled. So that causes it to create extra instances. So once all the instances are up, one of them would get deleted. So that's the reason why you see one extra instance here. So once this is done, this is going to just run for 15 minutes. And after that 15 minutes, again, it's going to go back at a scale into just one instance. So let's just wait for this 15 minutes to be over and let's see what happens at 1 p.m. Okay, it's 1 p.m. and currently there are three instances running. So let's just refresh this and let's see what happens. And here you can see two instances are getting deleted. Now this is a very useful functionality, especially if you want instances running just at a particular time. For example, when you expect a lot of traffic to visit your website, then at that moment in time, you can use your scheduling to create more instances. So I hope this was a useful lecture. I will see you in the next. Okay, so in our previous chapter, we had created a scale set, and within that scale set, we have two instances. So in this particular chapter, what we'll do is we'll make one of these instances as unhealthy. And once it becomes unhealthy, this particular scale set will spawn a new virtual machine and it will just discard the old one, which is unhealthy. Now to do that, you need to go to your health and repair, and underneath your automatic repair policy, you just need to enable this. And once that is done, you can also specify a grace period. Now, this grace period can be anything between 10 minutes and 90 minutes. So let's just make it as a default 10 minutes. And what I'll do now is I will just save this. Okay, once this is saved, what we'll do is we'll go to our instances. And what we need to do is we need to log into one of these instances and we need to shut the service that runs the web server. So what I'll do is I will create a virtual machine and within the same network. And then after I've done that, I will connect to this via the private network. So let's go to a virtual machine. So here I've already created a virtual machine within the same network. And what I need to do is I will just log into this virtual machine. So I'll just copy this. I'll log in using putty, open. Okay, once I've done that, let's go back to a virtual skill set. Instances. So what I'll do is I'll log into this particular instance. So I'll just copy this private IP address. And I'll SSH into that particular machine. Okay, once I've done that, all that I need to do is I need to run the forever stop command. So I'm using forever to run my web server on the background. So what I'll do is I will just run the forever stop command to stop that particular background job. And I will run the and this particular process has been stopped. So once this process has been stopped, what we'll do is we'll go back to our scale set, and this particular health state should turn into unhealthy. And you can see that it has become unhealthy. So now what should happen is, because I have changed the health and repair to auto enable, what will happen is this particular instance will be discarded and a new one will be created. But this takes a few minutes to happen. So let's just wait for this to create a new instance. So I'll see you there. Okay, you can see that the vScale set _2 has been discarded and a new one has been created. And that particular new one also has a health state as healthy. So this is how you can use your automatic repair policy to regenerate virtual machines that have become unhealthy. And if you have any issues, please do not hesitate to get in touch with me. I'll gladly help you out. So I'll see you in the next chapter. Now let's talk about the Azure load balancer. Now let's talk about the Azure load balancer. Now the load balancer is a very simple concept to understand. So you have a load balancer whose job is to evenly distribute traffic across multiple resources or servers in the backend. So a situation does not arise where you have a lot of servers in the backend and only a few of them are receiving traffic, whereas the others are not receiving traffic at all. Now to compensate for a situation like that, you have something called as the Azure load balancer. So let's look at how the architecture of the Azure load balancer looks like. Now here you have the architecture of a load balancer. So you can see that there is a load balancer in the middle, and this particular load balancer accepts connection from the client. And the load balancer then forwards that request to the backend. Now the backend pool can consist of either virtual machines or a virtual machine scale set. So in this particular diagram, you can see only virtual machines, but it can be a virtual machine scale set as well. And here the important thing to remember is the load balancing rule. Now the load balancing rule connects the IP address and the port of the front end and connects it to the backend port. So here what would happen is the port 80 of the front-end IP address is connected to port 3000 of the virtual machine in the backend. So the port 3000 for the virtual machine should be open and should be ready to accept inbound connection. So now let's create our load balancer and let's see how this works in practice. So the first thing that we'll do is we'll create a few virtual machines, and this virtual machine would run on port 3000 as mentioned here. This particular script I will send in the description below. So this is just a very simple web server that will just accept inbound connection. So let's create a few virtual machines. So I'll click on create. So I'll create it in my VNet resource group. I'll just call this as VM and it'll be in East US. And let me just give a and let's open port 80 as well. Now let's go to the networking tab. And in this networking tab, I will just disable the public IP because I do not want any public IP for these virtual machines. I want just private IP addresses, and my load balancer will connect to these virtual machines using the private IP, and everything else remains the same. You can actually even create a load balancer from here itself, but we'll not do that. We'll create a load balancer separately. So let's just leave everything as it is. And in the advanced tab, in the custom data, I'll just paste that particular script. So I'll just copy this and I'll paste it here. And let's click on review and create. And let's create our application. Okay, our deployment is done. So let's go to the resource. So we've created a virtual machine. Now make sure that you note which particular network your virtual machine is in. So you can see that it's in the VNet virtual network. So let's create another virtual machine within the same network. So let's go back to our virtual machine. We'll create another one. We'll use the same resource group. I'll just call this as VM1. Copy this. And let's create a virtual machine. Okay, so we've created two virtual machines without any public IP address. Now, one thing I've forgotten to mention is that we need to open port 3000 because our application would be reading requests from port 3000. So let's do that. Let's go to a virtual machine. Let's go to our networking tab. And here we need to add an inbound port rule. So let's open this. And here, let me just mention this as port 3000. And it's going to be a TCP and allow. Okay, so let's click on add. And similarly, I'll do the same for the other virtual network as well. So let's go back to VM1, go to the networking tab, and let's add an inbound port rule. And again, this will be 3000. Click on add. Okay, so now that we've done this, let's go and create our load balancer. So I'll go to my load balancer here. And here you get the option of choosing between application gateway and load balancer. This application gateway is something that I'll teach you in the next chapter. So this is the layer 7 OSI model load balancer. What we'll be using for this one is the load balancer. So let's open this. Let's click on create. You need to specify your resource group. And you can just give a name for this. I'll just call this as load balancer. Let's go down. So here you can mention what type of load balancer you want. So if you want a public facing load balancer, then you need to select public. Whereas if you want a private load balancer that has no connectivity to the internet, then you need to select the internal load balancer. For our example, we'll select the public one. And here the SKU that you need to select is standard. Now the basic is only if you want to do some kind of prototyping or if you want to create a POC. For production level load balancer, you need to select the standard. And if you want your load balancer to have a regional or a global construct, then you can choose one of these. Now the global load balancer is something that I'll teach you in the upcoming chapter. So for the time being, let's select the regional one. Let's click on front-end IP config. So here you need to select the IP for your particular load balancer. So let's create a IP address. And here, let's create a new one. So I just call this as load balancer IP. I click on OK. Click on add. Okay, so we've created a front-end IP address. And let's go and create a backend pool. So our backend pool will consist of the virtual machines that we've just created. So here I'll just need to give a name for my backend pool. I'll just call this as backend pool. And here I need to select the virtual network. So our virtual machines are in the VNet virtual network. So let's select that. And here you have the option of either selecting your virtual machine or your virtual machine scale set as I had said previously. So let's select the virtual machine. So I'll click on add. And here for some reason it's showing me virtual machine 2. Now virtual machine 2 does not exist. So what we need to select is virtual machine and virtual machine 1. So if I go back to my virtual machine, you can see that I have just 2 virtual machines in my account. So I need to select virtual machine and virtual machine 1. So I'll click on add again. Add. Okay, let's go to our inbound rules. So here I need to create my load balancing rule. So I'll click on my load balancing rule here. I need to give a name for my load balancing rule. And here I need to give my front-end IP address. So this is the IP address I just created. And here my port would be 80. So I would be expecting requests from port 80 of my front-end IP address. And here is the backend port. So my application is currently expecting requests from port 3000. So I need to give a backend port as 3000. And the pool is basically the pool that I created in my previous tab. And here you need to create a health probe. So the health probe will check the health of your application. So you can just select your HTTP. And here what you need to do is you need to again select port 3000 because your application is running on port 3000 and click on OK. To give a name for my health probe. So I'll just call this as probe. Click on add. And the outbound rule is something that I'll teach you in the upcoming chapters. Let's click on tags, review and create. And let's create a load balancer. So the validation has passed. Let's create a load balancer. Okay, so our load balancer has been created. Let's go to the resource. And here you can see that it's connected my port 80 of the front-end IP address to the port 3000 of the backend pool. So let's get our public IP address and let's see if this works. And you can see that it's connecting to one of the virtual machines. So and you can see now that it's connected to the other virtual machine because the name here was VM1. So let's copy this and let's run a curl command. So let me just clear this. So if I run a curl command on this IP address, you can see that it gives host VM. Let's run it again. And now it's hit the other virtual machine. So it's giving it as VM1. So if I keep doing it, you'll see that it keeps giving different responses. And that's because that it's hitting different virtual machines in the backend pool. So it's basically load balancing between both the virtual machines in the backend pool. So I hope this was a useful lecture. This was a very simple lecture on how you can create a load balancer. So I'll see you in the next chapter. Okay, so let's create our application gateway. So the first thing that I'll do is let me show you the architecture. So the architecture is going to look like this. There are going to be three backend pools. There's going to be one backend pool for the main home path. There's going to be another one for the user, and there's going to be a third one for the account. So I'll be basically creating three virtual machines, and I'll be placing all these three virtual machines within these three separate backend pools. So let's do that before we proceed. So I'll be creating three virtual machines. So let's do that. So let's click on virtual machine. Click on create virtual machine. And let's create a new resource group for this. So I'll just call this as app gateway. And I'll just call this as my virtual machine home. So this will be pointing to my home backend pool. And let's put a password. Let's go to next. Next. So I'll be creating a new virtual machine as well. So it's going to be the app gateway VNet. And all that I need to do is I need to go to the advanced tab, and here in the custom data I need to put my application code. So this is the application code that I'll be using, and this application code will just contain one path, and this is going to be the main path. So let me just mention this as the main, and whenever a user logs in with just the URL, it's going to be redirected to this particular virtual machine. So again, it's going to be reading port 3000, so we need to configure 3000 as well. Port 3000 as well. So let's copy this. Now this particular piece of code I'll be sending in the description below, so you can just have a look at this as well. So let's click on review and create. And let's create this application. So the validation passes. And just like this, I'll be creating two separate virtual machines, one for account and the other one for user. So I'll click on my virtual machine again, click virtual machine. So I'll put it in the app gateway resource group. I'll call this as VM account. This is going to be on East US. So everything remains the same. The only thing I'm going to change is just the password. And let's go to our advanced tab. And now I'll paste the same piece of code. Now the only difference is I'll add another path to this particular custom data. And this path is going to be the account path. So whenever a user navigates to the account page, he's going to be redirected to this particular endpoint. I'll just copy this, paste it here, click on review and create. And let's create this virtual machine as well. And similarly, we'll create one more for the users. Again, it's going to be in the same resource group. I'll just call this as VM user. And again, let's change this to password. So everything remains the same. All that I need to do is, again, I'll go to my code And here the redirect has to be through a user path. So I'll just create a new path for my user. And here I'll just return it with a user. So whenever a user logs into this particular URL, he's going to be sent this particular response. So I'll just copy this. I'll paste it, review and create. So we've created a third virtual machine. Now, one thing to remember is that these virtual machines, these applications that you see, they'll be listening to port 3000. So we need to open 3000, port 3000 for all three of them. So let's create this. And after this, let's open the port 3000 for the other virtual machines. So let's start with the first one. So I've already created my VM home. So I'll go to my networking. And here what you need to do is you need to add an inbound port rule, and the destination port should be 3000. So I'll just put 3000 here and I'll add it. So now I've opened port 3000 for my first virtual machine, and similarly I need to do the same for the other two as well. I go to my account, networking, click on add, and let's refresh this and the third one. And here I go to my networking again, click on add inbound port rule. Similarly, I'll open port 3000. Okay, so we've created three virtual machines. And what I need to do now is I need to create an application gateway. And once I've done that, I need to place all the virtual machines that I have created into the respective backend pool. So let's do that. So I go to my application load balancer. I need to open my application gateway here. I click on create. Now this has to be in the same resource group. So I'll put it in the application gateway resource group. I'll just call this as app gateway. Now this is in the East US region. So and here you can also have an auto scaling for your application gateway if you want to make it highly available. So you can have a minimum and a maximum instance count. So let's not have auto scaling enabled. Let's keep it as no. And I just have one instance for my application gateway. And here you need to choose which particular virtual machine, which particular virtual network you want your application gateway to be in. So I will put it in the application gateway in VNet because this is the virtual network that contains all my virtual machines. And once I've done that, what I need to do is I need to create a subnet specific for my particular application gateway. So this is something new. So whenever you're creating an application gateway, you also need to create a separate subnet specifically for this particular application gateway. So let's do that. So you can go to your manage subnet. So currently you can see that there is only one default subnet for my particular VNet. So I can click on subnet and I'll create an exclusive subnet for my application gateway. And I'll click on save. And now I'll select the one that I've just created. Next, I'll go to my front end, and here I need to create a IP address for my application gateway. So I do not have one currently, so I'll click on add new, and I'll just call this as app IP. Click on OK. So now I've created a front end IP address for my application gateway. So let's go to our backend now. So I have to create three specific backend pool, one for my home page, one for my account, and one for my user. So let's just create for my home first. Here you can choose your IP address, a virtual machine scale set, or an app service. So currently, let's just choose the app virtual machine. And here I will choose the VM home. And finally, we'll create the third backend pool for the user. And again, let's connect this to the user. Click on add. So we've created three backend pools, one for each microservice. That is the user, the home, and the account. So let's go to our next. So now that you've created your backend pool and your front-end IP, we need to create a rule to connect both of them together. So let's click on add a routing rule. Here you can give a name for your rule. So I'll just call this as rule. And here you need to give a name for your listener. So I'll just call this as listener as well. And here you need to give your front-end IP. So this is the IP that you just created over here. And then the port to which your user would be listening to the application. That's going to be port 80. So whenever you log in or connect to this particular front end, it's going to be through port 80. And everything else is the same. Now let's go to our important backend targets. Okay, so now that you're done with your listener, let's go to our backend targets. And here you need to connect your backend pool with your listener. So the first thing I'll do is I'll connect my home backend pool. And the HTTP settings, I need to add a new one because there isn't one. So the HTTP setting tells you in which particular port you would want your backend pool to be listening to. So again, this is going to be port 3000. Application is currently listening to port 3000. So I'll click on add. I need to give a name for this. I'll just call this as HTTP 3000. Okay, so I've connected my main page to the home backend pool and I'll be connecting it via port 3000. So now that you've done that, let's do the path-based routing. So to do that, you need to click on add multiple targets to create a path-based rule. So the first path would be the user path and you need to give a name. So let's just give it as user. And here again, you need to give an HTTP setting. Now, because my user application is also listening to port 3000, so I can just give the one that I had previously created. So this would do fine as well. So if you want to, if your application is listening to another port, then you can just click on add new and create a new HTTP setting. And let's choose the backend target. So the backend target here would be user. Click on add. And similarly, I'll create one more for account. So again, here the path would be account. You give a name for your target and I'll use the same HTTP settings because again this particular application is also listening to port 3000 and the backend pool again would be account. Click on add. Created your rule that connects your backend pool to your front end. So let's go to tags, click on review and create, and let's create our application gateway. Okay, our application gateway is done. So let's copy this URL, public URL, and let's try to connect. So if I connect it without any path here, what happens is it points to the home backend pool. So that's because of the configuration that I had made. So if you go to your rules here in your application gateway, you can see that the backend target is just the home backend pool if there is no path involved. And that's precisely what's happening. And let's also now go to the account page. And similarly, if you go to the account page, you can see that it points to the account backend pool. And similarly, if I use the user, it points to the backend pool for the user. So if I do anything else, it's going to give an error. So if I try to put any other URL apart from these three, it's going to fail. So I hope this was a useful lecture. So this is a very easy way of creating an application gateway. If you have any issues, please do not hesitate to get in touch with me. I'll gladly help you. I'll see you in the next chapter. Hi, so let's start this section by talking a bit about Terraform. Terraform is basically an open source software that is generally used to create architecture, or should I say infrastructure. It's widely used across most of the cloud providers these days, and it has become a sort of a standard for creating infrastructure in cloud. So you can see Terraform that is used widely across most of the major cloud providers that include Azure, GCP, and AWS. So what makes Terraform special is that it is absolutely simple to use. You can probably master it within a week if you have the right resources. So Terraform basically consists of an input, which is basically a configuration file. And that configuration file, when it is deployed or in Terraform jargon, when it is applied, it creates infrastructure within that particular cloud provider. So in this particular course, I'm going to give you a lot of examples, a lot of assignments, and a lot of quizzes for you to absolutely understand and to get into details about Terraform. Now, once you've completed this course, I am guaranteeing you that you will have absolutely no problem in figuring out anything about Terraform. So I hope you have a nice time and I hope you enjoy this particular course. And please do not forget to give me a rating for this course as well, as I have put in a lot of effort in making most of these slides. So thank you again and I hope you have a good time. Okay, so now that you know that Terraform is used to create infrastructure in multiple cloud platforms like Azure, GCP, and AWS, let's talk about a few advantages of using Terraform. The most important advantage I feel is that Terraform is a very simple tool to learn. You could probably master it within a few weeks, if not less. The second advantage of using Terraform, I feel, is the HCL, that is the HashiCorp configuration language. So this is a custom language that they use to build their code. So HCL is a very simple language to learn and it's much simpler than using JSON. Of course, you have the option of writing your Terraform script in JSON, but HCL is a much better and a more preferred language. And all the examples that I would teach you would be in HCL. So look out for the HCL chapter and you will realize how easy and simple it is to use HCL. The third advantage of using Terraform is that it has providers for all the cloud platforms. So basically HashiCorp works with most of the major cloud providers including GCP, AWS and Azure. And these providers make it possible for Terraform to communicate with these cloud vendors to create architecture. So these cloud providers have a close collaboration with HashiCorp to create the Terraform providers for their respective cloud platforms. It is arguably the best tool for creating cloud-based infrastructure, and it is also agentless. So what I mean by agentless is, let's say you're creating a virtual machine using Terraform. Now Terraform will not have its piece of code within those virtual machines. So Terraform doesn't work like how Puppet or Chef works, where those platforms do have agents within each of those virtual machines. So Terraform is basically an agentless tool. Okay, since Terraform does not have any agents running within virtual machines created by them, it is not recommended to use Terraform as a configuration tool. A configuration tool is a tool basically which is used to insert, update in software or programs or applications within virtual machines. But it does combine with other tools like Ansible to do the same. So you can always consider Terraform to be a tool that is to be used specifically for creating infrastructure, and it's not advisable to use Terraform as a tool for configuring software or applications within virtual machines. So that is one of the disadvantages of using Terraform. So if you have used any of the cloud vendors, you know that these cloud vendors do provide native infrastructure as a code tool. For example, if you're using Azure, Azure provides a tool called Azure Resource Manager, which has templates, which is also written in JSON. And if you're using AWS, AWS has its tool called CloudFormation and GCP has its own CloudFormation. And most of them are either written in JSON or YAML. Now, what makes Terraform special is that if you learn Terraform, then you have the potential of creating infrastructure in any of these tools without having to relearn anything extra. So all that you need to do is you need to just change the provider name and the resource configuration. So using those two changes, you can create infrastructure in any of these cloud vendors. So it's just one language that gives you the capability of creating infrastructure in any of these cloud vendors. If you are a DevOps engineer, then it's imperative that you learn a tool like Terraform, which will give you a more holistic view on how to create infrastructure, unlike if you're creating it using the native infrastructure as a code tool. Another very important factor about using a code like Terraform is the simplicity. So Terraform is specifically built for creating infrastructure, whereas a tool like Deployment Manager or even CloudFormation is very complex. And if you go through the code of CloudFormation or Deployment Manager, you will understand the complexity and the sheer number of lines that it takes you to create architecture. Whereas if you look at a tool like Terraform, since it's specifically built for creating infrastructure, it is more well thought out and it's a much simpler tool to learn. If you look to your left, it is a code to create a virtual machine in Azure. And if you look to your right, I have just copied a snippet of code to create a virtual machine in Azure Resource Management template tool. And it takes a much longer time to create infrastructure using the ARM rather than using a tool like Terraform. Now, if you used any of the cloud vendors, you would realize that there are CLIs or REST APIs that are available to you to create resources. So you might always wonder, why is it that I cannot use those CLI or REST API commands to create resources? Why do I need to use a tool like Terraform? Well, the most important reason as to why you should use a tool like Terraform is idempotence. So what that means is, let's suppose you've created a virtual machine using the same configuration twice. Now there is a possibility that the second time that same command would give a different result. It might throw an error saying that you've already created a resource, or it might, even in the worst case, create another resource which you do not intend to. However, if you're using a tool like Terraform, there is always idempotence that is present. So for example, if you have run that code once, and if you run it again by mistake, then the second time it will just skip that particular process itself and it will not recreate, or it will not throw an error. So let's look at a live example of how this works. So I'll be showing you a bit of Terraform code. The main intention is that you do not understand the code, but you understand the concept of idempotence. So here I have a Terraform code that just creates a VNet, and then after you've created a VNet, it creates a subnet within that particular VNet. So let me just run this particular piece of code. So to run this code, I just need to do a Terraform apply. So that will create this particular set of infrastructure that I have in my piece of code. So you just need to give a yes. So like I said previously, this is just a demonstration of our idempotence. All the configuration and everything else will be taught in the upcoming chapters. So as you can see that it has created 3 resources. So one is the resource group. It has also created a VNet, and then it's also created a subnet within that VNet. Okay, so what I will do is I will just run the same command again. So as you can see, the next time I run the command, it doesn't do anything because it already knows the state and it already knows that that particular set of resource has been created. So it doesn't throw an error or doesn't create the same infrastructure again. Okay, so now that we've run this, let's see what happens if we run these same commands using CLI. So I have a set of commands that can be used to create same set of infrastructure. So I will be creating a subnet. I'll be creating a VNet, and within that I'll be creating a subnet. So let me run this twice and let's see what happens. So let's run this initially once. So I need to do an AZ login. So I'll run the fetch command to create the VNet. Okay, so the VNet is created. So let me create a subnet within that particular VNet. Okay, so I've created a subnet. So now what I'll do is I'll try to create the same subnet with the same input again. So let's see what happens the next time I run this. So if you run the same command twice, you can see that it throws an error saying that this particular subnet already exists. So that is one of the advantages of using Terraform. So you do not need to handle any of those errors, and the concept of idempotence is built into Terraform. And that is the main reason why you should use a tool like Terraform, which is idempotent, rather than using CLIs or REST APIs to do the same. Now you can install Terraform in Linux, in Windows, as well as in OS X. So there is a link on how you can install. The link I will send in the description below. So you can just go through this particular link and get your Terraform installed based on whatever operating system you have. Now let's talk about the concept of modules in Terraform. Now modules are basically containers, or you could consider them to be folders within which there are multiple resources that are usually clubbed together. Now shown below is how a typical module would look like. The main important proponent of a module is the main.tf file. So the main.tf file is basically the file that contains all the code that you need to create infrastructure. So going forward, or even in the next chapter, I'll be showing you a main.tf that contains code to create a resource group in Azure. So after that, there are the variables and the output files. Now these variables and the output files are something that I'll teach you when I talk about the variable module. So here the important thing to remember is that the main.tf file is basically the file that contains all the code that you need to create infrastructure. So I'll see you in the next chapter where I'll be using a main.tf file to create a resource group in Azure. In this particular section, we'll talk about how you can connect Terraform with Azure. But before we do that, let me explain to you a few of the most basic Terraform commands that you would always be using. The first one is Terraform init, the second is Terraform plan, and the third one is Terraform apply. Now, these three commands you will always need to use. So let's go and look at each one of these commands. So the first one is Terraform init. So before we execute that command, let's go through a piece of code. Now, I do not want you to completely understand what this piece of code does, but the main gist of this particular piece of code is that it will create a resource group in Azure. So the name of the resource group would be example, and this is basically the code or the block that creates that resource group. So this particular piece of code consists of three blocks. The first one is Terraform, and then there is the provider, and then there is the resource. Now I'll be explaining each of these blocks in the later subsequent sections, but in this particular section, all that I want to teach you is what these three commands do. So let us initialize this particular piece of configuration. So the first command you will always run is Terraform init. So what this does is it will download all the dependencies that are needed for this particular application to run. So if you look at the folder currently consists of main.tf. When I run Terraform init, it will download all the dependencies. So it's downloading all the dependencies and it will create a folder called .terraform. So you can see that it has created a folder called .terraform. And now this particular Terraform folder consists of all the dependencies that are needed. So the dependencies have been downloaded. The next thing we'll do is we will run the Terraform plan. So what the Terraform plan does is it will tell the user before it creates the resources that these are the resources that will be created. So let us run the Terraform plan command. So you can see that it throws an error saying that it's not able to communicate with the Azure CLI. So that is what I will explain to you in the subsequent chapters of this particular section as to how you can communicate to Azure with Terraform. But for this particular chapter, what I'll do is I'll just run the basic AZ login command. So this is the login command for CLI. So let me just do a AZ login. And I will connect using this particular account. And once that is done, I can again run the Terraform plan command. So this time it works, and it says that it's going to communicate, and it says that it's going to create this particular resource, that is the resource group. And the resource group would be in West Europe, and its name would be example resource. And the ID for this particular resource will be created only once that particular resource is created. So what Terraform plan does is it will just tell the user that these are the resources that will be created, but it does not create them. So what is the command that actually creates it? So it is the Terraform apply command that actually creates these resources. So let me run the Terraform apply command. And you need to enter yes. And it says that finally that your resource has been created. So one resource has been created. So let's go back to our Azure console and let's see whether a particular resource has been created. So I go to my Azure console and I'll just search for the resource groups. And you can see that a resource group by this particular name, example-resources, has been created in West Europe. So this is how you know that your particular resource has been created. So that is it for this particular section. In the upcoming chapters of this particular section, I'll explain to you how you can connect Azure and Terraform. So I already did that using the CLI. There are other ways to do it as well, and those ways I'll explain in the upcoming chapters of this particular section. So that's it for this resource. Let me just summarize what I have taught you. So there are three basic commands. The first one is the Terraform init. The Terraform init is basically used to download all the dependencies. Then there is the Terraform plan. The Terraform plan will just tell you that these are the resources that will be created. And the Terraform applies to basically create those particular resources. So that's it for this particular chapter. I'll see you in the next section. Now, there are multiple ways to configure Terraform with Azure. If you are just running your Terraform locally and not in a CI/CD pipeline, then the easiest way to connect is using the Azure CLI. Now, let's assume you are using your CI/CD pipeline to connect Terraform to Azure, and there are multiple ways to do it. The easiest way is if you have an Azure virtual machine, then you do not need to have any passwords stored. You can just connect your Azure to your Terraform. And then comes the other ways, that is using the service principles. So there are two ways. You can use service principles with client secret, and then you can use service principles with client certificate. So in this particular example, I'm going to teach you how you can connect authenticating using the CLI, using managed identity, and using service principle with client secret. The service principle with client certificate is something you guys can try out in an assignment. So like I said again, if you just want to run it locally, the easiest way is using the CLI. If you want to connect it using a CI/CD pipeline, then you can either use managed identity, provided that your virtual machine is running on Azure. Else, you can either use a service principal with a certificate or with a secret. So let's start by using the easiest way, that is using the Azure CLI to connect Terraform with Azure. Hi folks, in this particular chapter, I'll show you how using the CLI, you can connect your Terraform with Azure. So the link to how you can download CLI, I will give in the resource below or the description below. And I will also have this particular piece of code. So I do not want to explain in depth this piece of code. So all that I will just say about this code is that it just creates a resource group in Azure. And this is the provider. So this provider and this resource is something that I'll explain later in the course. So all that you need to know is that when I deploy this piece of code, there will be a resource group by this name that gets created. So to connect your CLI to Terraform, the first thing you need to do is you need to do an AZ login. Now, of course, you should always have your CLI present. So once again, I will give you in the resource or the description below the link you can use to download your CLI. So let me do a AZ login. So then it'll ask you to log in using your particular account. So this is my account that I will use to log in. So let me just click on this. So once I am logged in, I can go back and here I see all the details regarding my account. It will give you the tenant ID, the username, what kind of user it is, and the name of the subscription. So it's called Azure subscription. So now what I need to do is so the next thing I need to do is I need to download all the Terraform dependencies. So to do that, I will run my first Terraform command. So it's called Terraform init. So what it will do is it will download all the dependencies for this particular application. So let me click on Terraform init. So it will create a folder here and it will download all the dependencies within that particular folder. So you can see there is a folder called .terraform that gets created. So the next thing I need to do is I need to run Terraform plan. So what Terraform plan will tell you is it will tell you all the resources that will get created. It will not create it, but it will just give you a confirmation that these are the resources that will get created. So let me just do a Terraform plan. So if your Terraform plan works without giving you an error, that means you are able to connect your Azure with your Terraform. So you can see that it hasn't thrown an error and it says that it will create a particular resource and the resource will be a resource group and this will be the location of that resource group and this will be the name of that resource group. So if this works without an error, that means you are successfully connected. So the next thing I'll do is I'll just do a Terraform apply. So what Terraform apply does is it creates that particular resource. I need to enter yes. And you can see that the resource has been created. You can go back to your Azure to check whether that particular resource has been created. So let's do that. So let me just log into my Azure account. Now let me go to resource group. So this is my resource group. You can see a resource group by example resources has been created. So if you open this, you'll see that currently there are no resources. So this is how you can connect your Azure with Terraform using the AZ CLI. So in the next lecture, I'll show you using managed identity, how you can do the same. So I'll see you there. So in our previous video, we had used a user who had owner access to the corresponding subscription. So let's assume that that particular user, or let's create a new user who does not have the owner access. Let's assume that he has reader access. So let's see what happens if we try to deploy an application with a user who has just reader access. So what I'll do is I'll just log out and I will log in using another user. So let me just log in. So I will log in using another user, and this particular user just has a reader access to that particular subscription. So let's see what happens. So let me just click on this and it has logged in. So if I create that same resource, now let's see what happens. So I'll do a Terraform apply again. As you can see that it throws an error saying that this particular user doesn't have authorization to perform action. So it is imperative that whenever you create a user, that particular user should have a role that is good enough to create resources. So that is one thing you should always keep in mind. So in this particular chapter, I'll teach you how you can use managed identities to connect Azure with Terraform. So for this, the most important thing is that your virtual machine should be in Azure. So what I'll be doing is I'll be using this particular virtual machine that I just created and I'll install Terraform in it. And after I've installed Terraform, I'll give it permissions using managed identities. So the first thing you do is you go to your identity under that particular virtual machine. You have two options. You can either use system generated or user assigned. So let's start by using the system assigned. So first thing you need to do is you need to enable this. You can click on save, click on yes. So after you've enabled it, the next thing you need to do is you need to give role assignments for this particular managed identity. So to do that, you can go to your subscription. So this is my particular subscription to which I want to assign that particular virtual machine managed identity role. So you can just open the subscription. You can go to IAM and you can click on add role assignment. Here what you need to do is you need to give the appropriate role. So what I'll do is I will just give the contributor role. Now if you're running it in production, it's better to give a more appropriate role with just permissions that you desire. So you can just click on contribute, click on next. And here you need to assign it to a member. You can click on select member. And here you have the option of system assigned or user assigned. So you choose system assigned, and then you choose the service that you want. So you want it for a virtual machine. The subscription is the same, and this is the virtual machine for which you want that managed identity. So you can just click on it, click on select, and you can just review and assign. Okay, so now that you've assigned the managed identity, let's log into this virtual machine. So I'll be using putty to log in. So if you do an AZ login, you will see that this command is not found. So that means Azure CLI is currently not installed in this particular virtual machine. So what I'll do is I will run that same application that I had run in my previous example, and let's see whether it's able to execute. But before that, let me just install Terraform. So Terraform is installed. So what I'll do is I'll create that same application again. So I'll just copy this application that is currently running in my local, and I'll paste it. So I've pasted the same application. So let me just save this and run this again. So as you can see that there is no CLI present in this particular virtual machine. So let's see whether I'm able to run this particular application just based on the managed identity. So the first thing I'll do is I'll just do a Terraform init to fetch all the dependencies. Now, once you do a Terraform apply, you will get an error like this. Now, that is because you have to export a few variables. So let's go back to the documentation. Using a system managed service, what you need to do is you need to export these three variables. So let's do that. So let me just copy this. I'll paste it. And I need to get the subscription ID. So I will just copy this. And the subscription ID, I can go to my subscriptions. So this is my subscription ID. I'll just copy this. And I need to export my tenant ID. So let me just copy my tenant. And I can get my tenant ID from my Azure Active Directory. So this is my tenant ID. I'll just copy this, paste it. And I'll paste this as well. So let me just do a Terraform plan again. So this time you can see that it works. So this is how you use your managed identities to connect your Azure with Terraform without having to use any CLI. So I hope this was a useful lecture for you, and I'll see you again in the next lecture. In our previous lecture, we had used a system assigned managed identity. In this particular lecture, we'll use a user assigned managed identity and do the same, that is connect Terraform with Azure. So to do that, you can again go back to your identity in your virtual machine, click on user assigned. So I already have created a user assigned managed identity, but what I'll do is I'll create another one. So to create a managed identity, you can just search for managed identities. So here's my managed identity. So what I need to do is I need to create a new one. So you can click on create. I will put it in the same resource group, and I'll just call it as Terraform. Review and create. And I'll click on create. So once you've created your managed identity, the next thing you need to do is you need to go to the subscription and give it the appropriate role. So let's do that. Let's wait for this to finish. Okay, your managed identity is done. So the next thing is I'll go to my subscription. So this is the subscription in which I need to add the role. I'll go to IAM go to add role assignment. I will give that particular managed identity the contributor role. So I'll click on contributor, click on next. Here you need to click on managed identity and select member. Here, like unlike the previous one where I chose the system assigned, here I need to choose the user assigned. So I'll click on user assigned. So it's the same subscription. And here I need to choose the one that I've just recently created, that is Terraform. So I'll click on Terraform and I'll click on select. I'll click on next and review and assign. Okay, so now your managed identity is done. So I'll go back to my virtual machine again. Click on my virtual machine. And here I need to choose the other managed identity. So I'll again go back to my identity. So now I'll disable my system assigned and I'll use my user assigned. I'll click on yes. And here I'll click on add. So here you have the Terraform one that you just recently created. So you can just click on it and click on add. So your Terraform managed identity has been added to your virtual. So what I'll do now is I'll again log into my virtual machine and I'll do the Terraform plan again and let's see if it works this time. So again, I'm in my virtual machine. I'll do a Terraform plan. And you can see it works this time as well. You use a user managed identity to connect Terraform with Azure. So in our previous example, we had seen how using managed service identity, you were able to connect Azure with Terraform, but the only drawback is that your virtual machine has to reside within Azure. However, if you want your virtual machine to be either in your local or in another cloud provider like suppose AWS or GCP, and you do not want to install Azure CLI, then the only option you have is to use a service principal. Now, service principal comes in two different flavors. You can either use a client secret or a client certificate. So in this particular example, I'll show you how using a client secret and a service principal, you can connect your Terraform with your Azure resources. So let's start. So to do that, you go back to your console. You have to go to your default directory, your Azure Active Directory. And then the first thing you need to do is you need to click on app registration. So click on app registration. You can click on new registration. This basically creates the registration for your connection. So I will just call this as my Terraform. And I just want it for my default Active Directory. So I'll click on register. So once your application is created, the next thing you need to do is you need to add credentials to that application. So you can click on add a certificate or secret. So like I said before, it comes in two different flavors. You can either add a certificate or a secret. So for our example, we'll be adding a secret. So you can just click on new client secret. I'll just call this as my Terraform as well. I'll click on add. And I get this particular value. So I'll be storing this in a secret place and I'll be using it later. Meanwhile, what I need to do is I need to give this particular application access to my subscription. So I'll again go back to my subscription. Here, like I've done previously, I need to give the IAM role for that particular service provider. Again, I'll go back to my add role assignment. I'll give it contributor again. I'll click on next. Here, instead of using the managed identity, I'll use the first, that is the user group or service principal, and I'll need to select the member. So the member is my Terraform. So I'll just choose this particular service principal. I'll click on select. I'll click on next again and review and assign. So once you've created your service principal, the next thing you need to do is you need to add these 4 variables within your code, within the provider. So you can add the subscription, you can get the subscription ID and the tenant ID from your subscription and your Active Directory. To get the client ID and the client secret, you can go back to your Active Directory. And within the Active Directory, you can click on the app registration. So you just need to open the application that you've just created. So that would be my Terraform. And within my Terraform, you'll get the client ID here. And then you can go to your secret. And within the secret, you can just copy paste this particular value. So this is the client secret. So once you've got these four values and once you pasted them, you can again go back to your console and let's go to terminal and let's do a Terraform apply, or let's do a Terraform plan. So you can see that you are able to create these resources. So that is how you can use your service principal to connect your Terraform with Azure. Now, if you're using Linux, you actually have the option of not hard coding it in your code. You can actually use environmental variables to do the same. I was trying to do it using the PowerShell, but unfortunately it wasn't working. So if you're using Linux, then do not hard code your values. You can just export them as environmental variables. So you can do that as an assignment as well. So I will see you in the next lecture. Now let's talk about the HashiCorp configuration language, also known as HCL. Now HCL consists of arguments and it consists of blocks. Now, of course, we can write our configuration in JSON as well, but I highly recommend that you write it in HCL instead because HCL is much simpler to understand and it's much simpler to learn as well. So let's talk about arguments. So arguments can consist of an identifier and an expression. So here in this particular example, the identifier is image underscore ID, and the expressions can be of the following types. It can be a string, a number, a boolean, or it can be of a complex type, that is a list, a tuple, or a map or an object. Now these primitive types and complex types are something that I will teach you when I'm teaching you about variables. Now let's talk about the block. A block is of the following syntax. It consists of a block type and a list of block labels. Now, based on what kind of block type it is, there will be a corresponding set of block labels. And then it is followed by a curly braces, and within that are a set of arguments. Now, these are the same arguments that we talked about in our previous slide. Now, let's look at an example of a few block types. Now, the most important block type is the Terraform block type. And this particular block type has 0 labels. Another block type is the resource block type. And this resource block type has 2 labels. So here in this example, the block label is the Azure RM resource group. And the next block label is example. And then comes the variable block type. And this variable block type has got one label called as availability zone names. Now here is a very common example of a Terraform configuration file. It consists of a provider block followed by a provider configuration block. And after that comes the variable block, the resource block, the data block, and the output block. Each block I will teach you in the subsequent lectures. So suffice to say that your entire configuration file is basically a set of blocks. Now this is something that you have to keep remembering, that configuration file in Terraform is basically a set of blocks. So let me reiterate again what I have said. HCL consists of arguments and it consists of blocks. Now your argument consists of an identifier and an expression, and together both of them form the argument. And then a block, and then comes the most important thing, the block. So the block consists of a block type and then a set of block labels based on what kind of block type it is. And within the block are a set of arguments. And each configuration file in Terraform is basically a set of blocks. So that's about it. Now this is a very important chapter and I hope you go through it a few more times. And it's a very short chapter, but it's very important to remember all the points that I have reiterated in this particular chapter. So as you begin your journey in Terraform, there will always be the complications with regards to correct syntax. Now there is a command called Terraform FMT that makes sure that your syntax is proper. So you can always use this command, especially if you're worried about the syntax. So let's look at this particular block. So this is a Terraform block and I have my curly braces in the next line, which is an incorrect syntax. So let's run the Terraform FMT and let's see what happens. So it says that an argument or a block definition is required. To set an argument, use the equal to introduce the argument. So what it says is that it considers this as an argument and not as a block. That is because your curly braces is in the next line. So what I'll do is I will just change it to the same line. So now let's run the Terraform init again. So Terraform FMT, sorry, again. So now you can see that there was no error. Another important factor is basically the differentiation between a single quote and a double quote. So a single quote is not allowed here. So let's just change this to a single quote and let's see what happens. So I'll run the Terraform FMT again. So it says that it's an invalid expression. So again, to make it work, you have to change this to double quotes. I'll run the Terraform FMT again. And this time it works and it validates. So the next chapter is going to be an assignment in which I have a few questions with regards to the validity of the syntax. So you can use the Terraform FMT command to check whether that particular syntax is valid or not. So meanwhile, I'll see you in the next section. So I'll see you there. So let's talk about the variable, the local and the output block. So here I have, for the sake of simplicity, considered my main.tf to be a function. And this particular function can be considered a function in any language. So if this particular function takes in an argument, then that argument that it takes in is basically the variable block. So here, for example, I have created a variable a and that has a value of test. Now let's assume that you want to create a variable that scope is only limited to your main.tf. Then you would create a local block. So for example, here I've created a local block called a that has a value of 100. Now let's assume that you want to return your function to another module, for example. Then you can use an output block. So for example, here I've created an output variable, and this particular variable I have defined as var.a. So that basically means that it will take in the value of 100 that I have defined in my local. So based on this, you could consider the input variables are like the function arguments. The output values are basically the function return values, and the local values are basically functions temporary local variables whose scope is just based or defined within that particular function. So now let's dive into some more theory about the variable block. So the variable block has the following arguments. It has the default. So you can use the default to set values for your particular variable. This is an optional block. Then there is the type. So the type defines what type of variable it is. So there are the following options that you have. You have string, number, boolean, list, or map. Now I will give you examples about these types in a later lecture. You can also set a description about that variable, which again is an optional block. You can also set validation for the values of that particular variable. And you can also have a sensitive argument in your input variable. So you can use this if you do not want to display your output for that particular variable in the output field or in the output block. Now inputs can be defined either in your main.tf and your variables.tf. Now there's a distinction between defining variables and assigning values to them. So this is basically where you define your particular variables. You can either define them in your main.tf or in your variables.tf. So I will show you an example later on in this particular section as to using both main.tf as well as using variables.tf. Now, once you've declared your variables, you can assign values to them as well. So there are multiple ways in which you can assign values. So the most important ones are using the /var command when you're running the Terraform apply command. So you can have a /var option where you can actually assign values to the variables that you have defined. A second option is using the .tfvars files. So within .tfvars files, you can assign values to variables that you have already declared in your main.tf or in your variables.tf file. You can also assign variables using the environmental variables. So the precedence is also as follows. The environmental variable has the least precedence, and using the /var command has the highest precedence. Now let's look at all the types of input variables. There are three kinds of input variables. There is the string, the number, and the boolean. Apart from that, the other types include the complex types, which can be of either collection types or the structural types. So if you're using collection types, then it consists of lists, maps, and sets. So you use collection types when you want to allow multiple values of another type to be grouped together as a single value. And you use structural types when you want to allow multiple values of several distinct types to be grouped together as a single value. So one important distinction is whenever you're using a structural type, then you also need to mention the schema for that particular type. Whereas for collection types, you do not need to mention the schema. You just can mention what type it is. So these types I will explain using examples. So let's go ahead and let's see the examples in the next particular chapter. Okay, now let's talk about creating some variables and displaying it as output. And we might also talk about a few local variables or define a few local variables. So let's start with the most basic. So we have the primitive type of string. So let's create those variables. So before we create them, we need to declare them and then assign values to them. So I have a set of files that I have included in my project or in my root module. We have the main.tf. So main.tf is a place where you can declare variables, and you can do the same in your variables.tf file as well. So you can declare variables in either main.tf or your variable.tf. And I also have a terraform.tf where, so here is where you can actually assign values to that particular variable. And the output is where you can store your output that you can display while you're doing the Terraform apply. So let's start by creating the most basic. So let's create a variable of type string. So I will be declaring this particular variable in my variable.tf file. So to do that, let's create a variable block. So I've created my variable. The name of the variable is stringvar and it is of type string. So this is important. So the type will always be there, and this is the only mandatory field that is required in variable. So now let's declare a particular value for this string var. So to do that, you can go to your terraform.tf vars and you can declare a value for that particular string. So I have declared this particular value. String var has the value myFetchString. So now let's go to the output.tf. So in the output block, you can display the output of this particular variable. So this particular variable that I have declared in my variable.tf and the values that I have initialized in my tf vars will be displayed because of this particular output block. So let us run this particular Terraform file. So I'll do a Terraform apply. So it says the changes because this is the variable that I have created. So it will give you this particular as the output. So I will do a yes. And you can see the output. So this particular block, which represents the output block, has the value of this particular variable. That is the variable that you have declared here. That is myFetchString. So let's do our same and let's just change it to a number now. So I'll declare another variable. And this will be of type number. I'll change this to number as well. And here in the terraform.tf, so I will not assign values in the terraform.tf vars. I will assign it using the /var command when I do a terraform apply. So the only thing I'll do here is I just display it as output. So I'll just copy this. I'll just do a num and the value I will get from here, and I'll just copy it here. So in this particular example, this particular number I am assigning in my variable.tf. I am declaring in my variable.tf, and the values that I will assign once I run the Terraform apply. So let's do that. So I do a Terraform apply and I do a /var, and for this particular variable I will assign the value 100. I'll do a yes. And you can see that this particular, so if you go to the output.tf, you can see that this particular block of this particular name, that is output num, has the value of 100. So this 100 has come from the /var that I gave when I ran the Terraform apply. And as you know that this particular /var has got a higher precedence. Now let's create another boolean, and this boolean will declare not in our variable file but in our main.tf. So let's do that. Again, I'll declare the output as well. So again, I have declared the output, and instead of the variable.tf, I've used the main.tf to create or to declare this variable, and I have assigned my variable in the terraform.tfairs file. So let's run this again. Okay, so Boolean is not the correct type, so I need to change this to bool. So let me run this again. I'll do a yes. So you can see that the Boolean output has got a value of true. So this is how you declare simple variables. So in the next chapter, I'll discuss on how we can create complex variables and assign them as outputs. Okay, let's start by creating the complex types. So in the complex types, let's start with the collection type. So the collection type consists of list, map, and set. You could consider list and set to be like arrays and maps to be like JSON objects. So let's start by creating a list. So here I have a list of string and the variable name is list example. So I have declared my variable and let's assign a few values to this particular list. So I'll copy this variable list. I will save this. I will assign values to it in the terraform.tfairs. So it would be of type, it would be a list of strings. So I can just put some random values here. I have assigned list values to this particular value. So again, you can say that it's an array, and this array contains three values, and each of them are strings. So if you do not assign a string value, it automatically gets converted to string. So let me just get the output for this. So I just copy this. I'll go to my output, and I will assign an output. I will create an output block. I'll call it list. And the value would be variable.list example. So let me just run this particular Terraform file. I'll do a Terraform apply. So you can see that single quotes are not valid. So you need to use double quotes. So let's go back to our Terraform TFS and let's just change this to double quotes. Again, let me run this. I'll do a yes. So you can see the list has been displayed in the output. So let's assume that you just want to display one particular value, let's say B. So to do that, you can go back to your output file and you can just set it to 1 like you would do in an array. So it starts with 0 and 1 would hopefully give you the value B. So let's run this again. I'll save this file and let's run this again. I'll do a yes. So you can see the list currently has values of just B. Okay, so now the difference between a list and a set is that using set, you cannot do this particular operation. So let's just change this to type set of string. And if I run the same thing again, it will throw an error. So list and set are basically the same. The only difference is set does not have the concept of indices. So you cannot search for a particular value in that particular string like we try to do using the output. So this thing does not work if you're using set. So that's one thing you need to remember. So let's go back to our output.tf and let's remove this. And let's see if we are able to run it again. So let's do a Terraform apply. Do a yes. Now you can see that using your set, you can display all the values. So the only thing that is not possible using set is the concept of indices where you want to just target a specific value. So now let's talk about maps. So in our previous example, we talked about list and set. In this particular example, we'll talk about map. So let's define a map. So a map is basically an object. So to define a map, you can do it again in your main.tf or in your variable.tf. So let's do it in the variable.tf. So I have created a map of type simple map example, and the type is map string. So this particular variable will accept any object that has the value pair of the key value as a string. So once you have created this, once you have defined this variable, let's assign a particular value to it. So the kind of values that you can assign would be something like this. So you have an object and the object has two keys and the values are both strings. So this is a perfect example of type map string. So again, in the output, I'm just going to display the same variable. So let's run this particular example. So you can see the output again is just the key value pair. Now, if you want your values in your key values to be anything, whether it's a string, a number, a boolean, then you can change this from string to any. So once you've done that, you can go back to your TF and then you can just change it to anything. So like, for example, I can just have a subnet 3 and I can set it to a boolean. So I can set it to true and I can have one more subnet. I'll keep this as subnet 4 and I'll set it to a number. So if I set it to any, that means it will take any value. So let's just run this again. And I do a yes. So you can see that the output is valid. Okay, now let's change it from any to number. So let's see what happens once we do that. So I've changed it from any to number. And if we run a Terraform apply, it'll say that the values are invalid. So if you need to handle a situation where you do not know the type of the inputs, then you can always put any. So that's it for this lecture. In my next lecture, I'll explain to you what an object is. So in our previous example, we had learned about maps. So these maps are key value pairs where the value can either be of string, number, or boolean. That is, they can only be of primitive types. Now let's assume you want to create a map of key value pairs where the value is not a primitive but a very distinct object itself. So how do we do that? So to meet a scenario like that, we have to create an object first, and then what we'll do is we'll create a map of those objects. So let's start by creating an object. So the important thing to remember is that an object is a group of distinct types, and an object should always have a schema associated with it. So let's create a variable of type object. So here I've created a variable of type object, and this object can take two strings as key value pairs, the CIDR block and the region. So if I assign a value to this particular object example, let's see how it should look like. So I'll copy this and I will assign a value to this. So this has to contain the CIDR block and the region. So I'll just copy this, and the CIDR block I'll just define a value as 10.0.0.0/20, and then it should also contain a region. So I'll just copy this region and I'll set this to US East. So this is just an example. And I have to put a comma. So now what I've done is I have assigned this particular object example, the value CIDR block is equal to this and the region is equal to this. So let's output this particular value. So I'll copy this, I'll go to my output.tf and I'll paste that particular variable. So once I've done that, let me just run this particular Terraform up. So you can see that this particular output has these values. Okay, so this is how you create an object. Now, creating an object by itself has no value. What you need to do is you need to create a map of these objects so that the map can not just be linked to a primitive, but it can also be linked to a structure like an object. So to do that, let's go back to our variable again. What we'll do is we will define a map of objects. So what I'll do is I'll just copy this and I'll paste it. And now what I'll do is I'll create a map of objects, and then I'll go back to my terraform.tfs, and I'll just, so what I'll do now is I'll create a map, and these maps will have key values, and the value would be this particular object. So let me just copy this. I'll just have two subnets, and what I'll do is I'll just copy these objects as well, and I'll change it from test. Here I'll change the value as well, so I'll just keep it as 1. Okay, now what I'll do is I will just change this to, I'll change the value of this to map object example. I'll copy this, I'll save this, and I will output this particular variable as well. Okay, let's apply this again. Yes. So now you can see that I was able to create a map of, not a primitive, but a map of objects. So this is how you can use your map and objects, combine them together and get a useful variable created. So I've created a set of assignments. I hope you finish those assignments, because once you've done them, then I'm sure that you would have perfected everything with regards to variables. So I'll see you in the next lecture now. Hi, this is going to be a very short lecture on how or where you can declare and initialize your local variables. Your local variables have to be declared in your main.tf. Here I have an example of initializing a local variable and setting it a value of 100. Now, if I want to output this particular local variable, I have to go to my outputs, and here what I need to do is, instead of where, I need to do a locals. So I will do a local.a, because a is the name of that variable, and if I run this, then the output should return me 100. So let me run this particular. So you can see that the value is 100. So this is how you use your local variables and output them. Just remember that the scope of your local variables is only within your main.tf. So that is one thing you should remember. So I'll see you in the next section now. So now let's talk about the provider. So the provider consists of two blocks, the Terraform block and the provider block itself. So the provider is used to configure architecture or infrastructure in Microsoft Azure using the Azure Resource Manager APIs. That means these are the two blocks that enables Terraform to create architecture or infrastructure in Azure. Now, if you look at the Terraform block, it gives you which particular version of the particular provider you want to use. So 2.67 is the latest provider version. So if you go to this particular link, it will give you all the versions for this particular provider, that is the HashiCorp-Azure RM. So here you have a list of all the versions. So if you want to use a previous version which you think is a better fit for your project, then you could use that as well. So the only thing you need to change here is the version number. So you can just change it to 2.66 here. And apart from that, the provider block has also got a set of optional fields. So those include fields like the client ID, the subscription ID, and the tenant ID. Now, if you go back to your previous section, so there was a chapter in which I used service principal to connect Azure to Terraform. So in that particular example, I had used these particular values. Now, if you want to connect not using CLIs, then you can use these particular fields to fetch values for the subscription ID and the tenant ID. So once you do a Terraform init, after you've pasted your Terraform and your provider block, what Terraform does is it will download all the dependencies within the .terraform folder. So let's do that. So let me do a Terraform init. Before that, let me show you the folder structure. As you can see that the folder structure currently has just this particular JSON. So let's see what happens when I do a Terraform init. So what it does is initializes the backend and it downloads all the providers. So you can see that this particular registry.terraform.io has been downloaded. So this contains the provider for Azure and it has been downloaded. So now after you've downloaded this, now you can actually create resources within Azure. So that is something that we'll be doing in the next chapter. So the important thing to remember is that it is the provider that enables Terraform to connect to Azure using the Azure APIs. And it is this particular piece of code or this particular block, that is the Terraform block and the provider block, that enables Terraform to create architecture in Azure. Okay, so now that you've downloaded your provider, now you can actually start creating resources. So let's do that. So to do that, you need to integrate your main.tf with a resource block. So if you go back to that same example for the Azure provider, you will see that their example, they create a resource group and then a virtual network. So let's go ahead and let's create a resource group. So I'll just copy this piece of code. Now, of course, I will be explaining resource group in depth in the next section. So do not worry about the syntax, etc. All that you need to know is that this particular 3 lines of code or 4 lines of code will just create a resource group by this particular name. So, and it will be in this particular location. So now that you've created your resource group, what we need to do is we need to do an apply, a Terraform apply again to create this particular resource. And that's how simple it is. So just 3 lines of code and you've created a resource group. So let's run the Terraform apply command. So it's Terraform apply. I'll do a yes. And it has created that particular resource. So let's go back and check whether that particular resource has been created. So let's go to our Azure console. If you click on the resource group, you can see. So let's refresh this again. So you can see that this particular resource group has been created. So this is how you know that your Azure is connected with your Terraform and you're able to create resources. So once again, this is just a demo to just check whether your Azure is connected with your Terraform and you are able to create a resource. So I'll see you in the next chapter. So in our previous example, when we created that resource group, there was another very important file that got created, and that's called the terraform.tf state file. So if you open this file, it will show you all the resources and the outputs that have been created. So this is that particular file which maintains the state of your Terraform. So if you go through this particular Terraform file, you will see that there is an output created, and this output is basically a variable that we had created in our previous section where we discussed about variables. And along with that, we've also created a resource group. So if you go to the TF state again, so under the output, it shows you the output that you have created, and under the resource, it shows you the resources that you've created. So you've created a resource group, and the name of the resource group is example, and the provider, and all the other important attributes. So it's always important to know that there is a TF state file that is created when you do a Terraform apply. So now let's do one thing. So let's make a few changes. So I go back to my main.tf. So I'll change the name of my resource group from example resources. So let's say I change it to resources 1. So let's see what happens when you do a Terraform apply again. And this time you can see that there was one more file that got created. So it also created a backup file. So if you compare the backup file and if you compare the current TF state file, you will notice that the backup file contains the state before the Terraform apply. So if you look at the .backup, you will see that the resource name is again still example resources. Now if you look at the current state, so TF state, you will notice that the name has been changed to resource 1. So that's also another important thing for you to remember, that before you do a Terraform apply, the Terraform TF state has a backup taken. So that is it for this particular lecture. I will see you in the next lesson where I'll teach you about resources. So I'll see you there. Okay, so now let's talk about the most important block in your Terraform file, and that is the resource block. So resources are the most important elements in the Terraform language, and each resource block describes one or more infrastructure objects such as a virtual network, a compute instance, or even a high level component such as a DNS records. Okay, so now let's look at the structure of the resource block. So the block contains the name resource followed by the type of resource that you want to create. Now this type is different for different cloud providers, and you need to go through the documentation to find each particular type of resource. And then you can give a name to that particular resource. So here the name that I have given to my Azure resource group is example. And then apart from that, then there are a set of arguments. Now these arguments differ based on what type of resource that you are creating. So for example, here my Azure RM resource group has these arguments, that is the name and the location. Now apart from that, each resource block has a certain set of meta arguments. These include depends on count for each provider and life cycle. And as we go through the examples, we'll talk about all these meta arguments and how they come in handy. So let's start by creating our first resource. Okay, so now that you know a bit about resources, let's start creating an architecture. Let's start by creating the most basic and the most simplest architecture. So what we'll do is we'll create a resource group, which we already have in the previous section. So after we've created a resource group, what we'll do is we'll create a virtual network. And within that virtual network, we'll create a subnet. We'll also create a NSG, that is a network security group, and we will link a particular subnet to that NSG. So let's go ahead. So the first thing you need to do is you need to create a virtual network. Now we've already created a resource groups because we had already done it in our previous lecture. So I've just left it as it is. So you have a resource, and this particular resource type of this particular name will create a resource group, and the name of the resource group would be dev resource group, and the location would be in West Europe. Okay, so now that we've created a resource group, the next thing we need to do is we need to create a virtual network. So to create a virtual network, you need to create a resource block of type Azure Virtual Network, and the name of this particular type will be VNet. So if you're new to Terraform, you will always ask yourself, how do you find this correct type for creating a resource? So the easiest way to do it is basically to Google it. So for example, if you want to create a virtual network, you can always go to your Google. You can type something like create a virtual network in Azure using Terraform. So if you search for something like this, so the first response that it always gives would be the resource block that you need. So this is the resource block that you can use to create a virtual network. So let's go down and look at all the attributes that this particular resource block needs. So it needs the name, the resource group name. So the resource group name was something that we had previously created, the address space and the location. So let's go back to our code. So our code looks something like this. Again, we have the name, the address space, and the location and the resource group name. So the location and the resource group name I can just fetch by this particular method where I just append the resource type. So that is the resource Azure RM resource group, and then the name of that particular resource type that I have given as resource group, and then the attribute. So the location is the attribute. So using this, I can basically fetch this value. Similarly, the location also can be fetched. So you have the option of either hard coding this value or using this method to fetch that particular value. So this is a much preferable way to do it. Okay, so you've created the virtual network. So the next thing you need to do is you need to create a subnet. So here I'm creating two subnets. I'll use the same method. I can just Google it as well. So I'll just go to my browser and I'll just write create a subnet in Azure using Terraform. And here again, the first output I get is the resource block that I need. So I can just open this and it just says manages a subnet. So let's go down and look at all the attributes that it needs. So again, it needs the name, which is a required field, the resource group name, the virtual network name, and the address prefix. So let's go back to our code again. So this is our code. So here I'm giving the name, the resource group name like I fetched previously. And here I'm also fetching the virtual network name. So that is this particular virtual network that I just created. Again, it's the same way. So it's the resource type, the name of that particular resource type, and the name of the attribute that I want. So using that, I can just fetch this particular value. And similarly, the address prefix also have, so even though this is optional, I've just added this as well. So the value I've added here is 10.0.1.0/24. So it'll give around 255 IP addresses. And similarly, I've also created the other subnet. The only difference here is that the name is different as well as the address prefix. So after I've created these two, I've created an NSG, and the idea is that I will link this NSG to this particular subnet. So to create an NSG, again, you can Google it as well. So let's Google. So again, the first response you got is the resource block that you need. So you can just open this, go down and look at the attributes. Again, the name, the resource group name, and the location, and the security rule as well. Even though this is optional, but this is something that we will include. So the security rule has these parameters. So again, it needs the name, the protocol, the source port range, the source port ranges, or the destination port, or whether you want a multiple set of, or if you want a list of ranges, then you can define it here. So let's go back to our code and let's see how we've defined it. So again, the name, so this is the name, so this is the location, so it's basically the same location as the resource group, and this is the name of the resource group, and this is the security rule that I've given. So what I'm doing is I'll allowing all TCP connections. So I've given a higher priority than the default, and it's an inbound, and it will allow all TCP for all ports. So I've left everything as open. So after I've created the NSG, So after I've created the NSG, what I need to do is I need to link this particular NSG to this particular subnet. So there is another resource block that does that. So that particular resource block is known as the Azure Subnet Network Security Group Association resource block. So I have created a resource block of this type, and I've given it a name called example. And all that I've done is I have to give the subnet ID and the NSG group ID. So that basically corresponds to the ID, the resource ID that will be generated once that particular resource is created. So this ID gets generated once the particular resource has been created. So the output of subnet 1 should give you the ID. And similarly, the output of the NSG should also give you the NSG ID. Now you can always go back to your documentation. For example, here I'm in my subnet documentation, and if you go under the attribute reference, you will get all the attributes for that particular subnet. So for example, if you create a subnet with these arguments, these are the attributes that you can expect as the output. So it can give you the ID, the address prefixes, and similarly there are other attributes you can get as well. So this is a very important thing to know. You should always look at the documentation and see what are the attribute references for that particular resource block that you're creating. So okay, so once you have everything, you can always cross-reference with your diagram. So it's always imperative that you create a diagram before actually you start creating resource blocks. So you're able to at least visualize how your particular resource will look like, or how everything will look like, your architecture would look like. So once you've done everything, you can just do a go to your terminal and just do a Terraform apply. So let's expand this page. So here it will tell you all the resources that will be created. An important thing to notice is the ID is basically something that will be known only after the apply is done. So similarly, you will see that there are 6 resources that will be created. So let's just count the resource blocks that we have. So we have 1, 2, 3, 4, 5, 6. So a total of 6 resources will be created. So let's just approve this by saying yes. And let's wait for the resources to get created. Okay, so you can see that 6 resources have been created. So let's go back to our Azure console and let's see whether they have been created. So I go back to my resource groups. So you can see that the resource group has been created. And within the resource group, I can see that there's a virtual network. So this was the virtual network that we created. And this should have two subnets. So if you open the subnet tab, you can see that there are two subnets. And both these subnets have the same ranges that we had defined. And this particular subnet is linked to an NSG. So let's look at the NSG. So we go back again to the security group. And this was the NSG that we had created. So you can see that this NSG has one particular rule, that is it allows all TCP connections to flow in. So this is how you create infrastructure. So I hope this was useful for you and I'll see you in the next lecture.
Okay, so now let's talk about another very important block in Terraform, and that is called the data block. So data block allows data to be fetched or computed for use elsewhere in Terraform configuration. Use of data sources allows a Terraform configuration to make use of information defined outside of Terraform or defined by some other separate Terraform configuration. So let's suppose So now let's create a new Terraform configuration. Now in this particular Terraform configuration, what I will do is I'll create a virtual machine. So I already have a network and this network has two subnets, that is subnet 1 and subnet 2. So within subnet 1, I will create my virtual machine. But to create a virtual machine, I also need a public IP address. And this public IP address, I need to connect to my NIC. And this NIC will be connected to my virtual machine. So in total, I need to create three resources: a public IP address, a NIC, and a virtual machine. So let's look at the configuration. So this is a brand new configuration and it's distinct from the previous one. So here what I need to do is I need to use the data block and get information about this particular resource group that I had created previously. Now using this particular data block, I can get a lot of information about this particular resource group. So let's look at the documentation and let's see what all information we can get. So I go to my documentation and let's just paste this particular resource group. Again, you can do this using Google as well. Now, if you look at your resources, there are two. There is one resource and then there is one called data source. So data source is what we need to look into. So let's click on this particular resource group. So this gives you a documentation about the data block for your Azure resource group. So let's go down and let's see the attribute reference. So these are the attribute reference that you can get from this particular data block. You can get the ID, the location, and the tags. And the input that you need to give is the name. So again, let's go back to our code. So I've given the input as name and I can get the location, the ID, and the tags. Now here I need to get the location because I'll be using this location in a resource group later on. So here, for example, for the NIC, I need to get the location. So using this particular data block, I can get the location for this particular resource group. Similarly, I've also created a data block for the virtual network as well as for the subnet in which I need to get my virtual machine created. And again, for the virtual network, the input that I need to give is the name as well as the resource group. So this resource group I can just get using the concatenation of the resource group type, the name of that type, and the name. Similarly, for the data block for the subnet, I need to use three inputs: the name, the virtual network, as well as the resource group. So once we've created these three data blocks, then we can start creating our resource blocks. So let's start by creating the public IP address. Again, for the public IP address, you first need to give the name of the IP address, public IP address. Then there is an allocation type. This can be static or dynamic. Now again, you can look at the documentation for this particular resource block and get all the valid information. So let's do that. Again, I go back to my documentation. So now let's look at the arguments. So again, the allocation method is a required field and it defines the allocation method for this IP address. The possible values are static or dynamic. So a dynamic public IPs are not allocated until they are assigned to a resource. So that's the difference between a dynamic and a static. Okay, so we've created the public IP. Now let's create the resource group. Now let's create the network interface. Again, the network interface requires the resource group location that we get from the data block, as well as the name of the data block. And then you need to give the IP configuration as well. Now here you need to provide the subnet in which you want the NIC to be in, as well as the name of your IP configuration and whether you want it dynamic. And here you need to link your particular public IP address that you created previously. And again, this is the ID and not the name. So you should always remember that this particular ID is only created after the apply is done. That is after the resource has been created. And after that, you can just create your virtual machine. So again, you can go search for this particular resource block. So you can again Google it. So if you want to find the resource block, you can always type create an virtual machine instance in Terraform. So I will also specify Azure. So this is the resource block that I need to use. So here you can see that there are a lot of arguments that you need to give. So you can just go through this documentation. It'll take up a lot of time to go through them one by one. So if you look at the example, you can see that. So if you look at this piece of code, you can see that I have created a Linux box that is of standard B1S. This is basically the cheapest one, so it's preferable to use this. And then you've linked your NIC card. So this was the same NIC that you had created previously. Now again, this is the ID and not the name. So again, it's the type, the name of that particular type, and the ID. So this is applied once the NIC is created. And everything else is the same. The only difference here is that I'm using a password and not using a public private key. And this is the name of my user and this is the password. So let us deploy this particular piece of code. So to do that, again, I'll do a Terraform apply. And here it states that it's going to add 3 new resources. So let's just click on yes. So once again, let me reiterate all the 3 resources that we'll create. The first one would be the public IP address. The second is the NIC, and the NIC will be linked to the public IP address, and this particular NIC will be linked to the virtual machine. So overall, there are 3 resources that we'll create. So let me click on yes. Okay, so you can see that these 3 resources have been created. So now let's go back to our Azure console. Let's click on virtual machines. So here you can see that my virtual machine has been created. So it's still in the creating process. So let's just refresh this. So it's running now. So let's try to access this particular virtual machine. So I'll open this. I need to refresh it. And you can click on connect, click on SSH. So I'll not be using the private key, I'll be just using the password. So I can just skip this particular /i. So let me copy this and I'll just go to my command prompt. I'll paste this and I'll just remove the /i. Click on yes. And then you need to give the password. So the password is this is the password. It's password 12345. So let me just and you are able to log in. So this is how you can create a virtual machine using Terraform. So I hope this was a useful lecture. I'll see you soon. Another very important command that you need to know is the Terraform destroy. So the Terraform destroy command just destroys all the infrastructure that you've created. So let me just do this. I'll just do the Terraform destroy and it should destroy the virtual machine, the NIC and the IP address. Click on yes. It will state that it's going to destroy 3 resources. And you can see all those 3 resources have been deleted. So let's go back to our console again just to verify. Again, if I go to my virtual machine, so you can see that that particular virtual machine has been deleted. So that's how you destroy resources using Terraform. So I'll see you in the next chapter. Okay, so now let's look at another very important example. So in this particular example, we'll be creating a storage account. And within that storage account, we'll be creating a blob container. And that blob container will contain a static website. So let's look at how the architecture will look like. So the first thing we'll do is we'll create a storage account. And that storage account will have the static website enabled. And then we'll create a HTML website. And this particular HTML would be the index.html, and it would act as the root to that particular static website we are creating. And then this website will be transferred to a blob storage that will be created within the storage account. And then this will act as the index.html or the main page to the static website that we've created. So the only resources that we need to create here would be, the first is the resource group again. And after that, we need to create the storage account. Now, the important thing to remember here is that the storage account block has another block called static website within it. And this static website should have the index document and the error 404 document. So this points to the index.html, that is the main page. And this points to the error page, that in case there is no link found, then it will be transferred to this particular 404 page. So let's have a look at the documentation for this particular resource type. So I go to my website. So we are at the storage account page. So let's go through all the arguments that we need to give. Again, we need to give the name, the resource group name, and the location. And we also need to give the auto replication type. So everything else is optional. So the only extra thing we need to add apart from the required is the static website. So if you go down, you can see that there is a static website block. So I'll just copy this and let's search for the static website block. So again, if you look at the static website, it has the index document and the 404 document. So let's go back to our code. So again, these are all the required parameters, and this is the optional in which you state that you want the static website to be enabled. And this is the pointer to the index.html page, and there is a pointer to the 404 HTML. So these pages are something that we will create in our blob storage. So again, we create a blob storage. So this is the second resource that we'll be creating. So we'll name this as index.html. So it's basically the same as the index.document. And the storage account type would be again the previous account type that we've created. So this particular blob would reside within the account type that we had created above. So this blob would contain within this account. Again, the storage container name has to be $web. Now this is important. It has to be $web. And the source is basically the index.html that we have currently in our local, and that will be copied to this particular blob. And the content type is also important. If you want to view it in the browser, it has to be text HTML. Now, if you go through the folder structure, you can see that there's also an index.html. So this index.html is just a normal HTML page which just has hello as the output. So there's nothing special apart from that. So let's just deploy this application. So let's do a Terraform apply. So it's creating all the resources. So it should be creating a resource group and then a storage account. And within that storage account, it should be creating a blob storage. And that blob storage should contain the index.html within a $web folder. So all the resources have been created. So there are 3 resources created. One would be the resource group, the other one would be the storage account, and the third one would be the blob. So let's go to our console and let's look at the resource groups. So we had created this particular resource group. So let's open this. So this resource group has got one storage account. So if you open the storage account, you should see that there should be one container, and this container should have a $web folder within that, and this should contain the index.html page. Okay, so let me refresh this. So you can see that this is the index dot. So how do you view this particular page? So again, to view this page, you go back to your storage account again, and within the storage account, if you keep scrolling down under data management, you'll see a static website. So you just need to open this. So it has everything enabled. So the only thing you need to do is you just need to copy this, and if you paste it, you will see that this is the index.html page. So this is how you create a static website in Azure using Terraform. So I'll see you in the next lecture. So now let's talk about provisioner. So provisioners can be used to model specific actions either on a local machine or on a remote machine. So there are three kinds of provisioner. There is the local exec, there is the remote exec, and the file. So the local exec executes scripts on that particular local machine on which Terraform is installed. A common example of this would be, let's assume that you've created a virtual machine, and after you've created a virtual machine, you want a certain script to run on your local. So in that scenario, you would use a local exec. Now let's talk about the remote exec and the file. So the file is basically used to transfer files from your local machine to a remote machine. Now the connection of that remote machine is provided within the provisioner itself. And similarly, remote exec is used to execute a script on that particular remote machine whose configuration is provided within the provisioner block. So now let's look at an example of how this works. So now let's look at an example. So here I have a resource group that I'm creating, and within this particular resource group, I'm adding two provisioners. The first one is the file provisioner, and the second one is the remote exec. So the file provisioner will basically copy this particular file that I have in my directory here. So this particular file will be copied to this particular path, and here I need to provide the connection. So it's going to be an SSH, it's going to be an Azure user, the name of the user, and this is the IP address. So this is just a virtual machine that is on Azure currently, and the agent is true. And here I'm also using Pagent. So if you open your Pagent connection, so view keys, so here you should also provide the private key for this particular IP address. If you're using Linux, you can use SSH agent. I'll be providing the link to Pagent in the description below as well. So that's how the connection works. So the only thing you need to provide is the source and the destination. And this particular destination, and what I'm doing is I'm just copying this file to this particular destination. And then comes the remote exec. It's basically the same thing. The first thing I'm going to do is I'm just going to do a chmod, which will just give execute permission. And then I'm going to just run this particular script, and the output I'm going to store in this particular file. And again, the connection remains the same. So let's run this particular script. So to do this, before doing that, let me show you how the virtual machine looks like. So here I'm connected to my virtual machine. So if I log into my directory, you can see that there is no install.sh present. I'll also remove the install file. So here currently there is just the app codes and the main.tf. So once this particular Terraform configuration executes, it should copy an installed file here. So there should be an install.sh file, and then that install.sh file should be executed as well. So let's run this particular Terraform. So let's run this particular Terraform configuration. Also, another thing is, let me show you the install.sh. All that it has is a touch ABCD. So I'll just create a file by the name of ABCD. Okay, so let's run this particular configuration file. So let's do a Terraform apply. So let's revisit the architecture again. So what I'm doing here is I'm going to create a .sh file, and this .sh file will be transferred to my virtual machine, and this virtual machine will execute this sh file. So let's wait for the execution to complete. Okay, so the execution is completed. Let's go back to our virtual machine. So if I do an ls now, you can see that there's an install.sh, And you can also see that there was a file created ABCD. So that means that the particular script has executed. So that's how provisioner works. Now, provisioner should also be used as a last resort. Now, if you want to execute or run scripts in your virtual machine, you should always use custom data. And there's a important documentation given as well. So if you go to your Terraform, you can click on declaring provisioners. It's mentioned here that provisioners are actually a last resort, and if you're using Azure, you should instead use custom data within your Azure virtual machine to run scripts. So that's it for this lecture. I'll see you in the next. In this particular lecture, we can see how we can use two providers in our Terraform configuration. So we've used the usual Azure RM to create resources. Now, if you want to create a user, you need to use the Azure AD, that is the Azure Active Directory provider. So that is what we're going to do. We're going to create a user and we're going to assign that particular user read access to the subscription. So let's do that. So the first thing we've done is we've created the user, and for that we have to use the Azure read underscore user block. And in this particular block, we need to mention the principal name. So this is the user ID. And this is the display name. So this is the display name. And we can also mention the nickname as well as the password. So once we've created a user, we need to give this particular user access to the subscription, a read access to the subscription. So to do that, we need to use the other provider, that is the Azure RM. So here in this particular Terraform configuration, we are creating two resources. One is using the Azure AD, that is to create a user, and we are using this particular provider to give the user that we have created access to the subscription. So it's fairly straightforward again. So we need to use the Azure role assignment, and here what we need to do is we need to give the principal ID. So this particular principal ID is what we've derived from here. So it's again the Azure user, the type, the user, and the object underscore ID. You can go look at the documentation of this particular resource block. And then we also need to provide the subscription ID. So this subscription ID I have got using the data block here. So if you notice, this data block doesn't have any attributes. That is because it takes it directly from the configuration itself. So let's run this particular configuration. So let's do a Terraform apply. Okay, so the user has been created. So let's go back to our. So what we need to do is we need to go to the Active Directory, and here in the Active Directory, we need to click on users. So you can see that this particular user has been created. And the other thing we need to do is we need to go check whether this particular user has reader access to subscription. So let's open a subscription here and let's go to IAM and view the access to this particular resource. So let's click on this. So if you go down, you can see that that particular user has been given reader access. So this is how you can use multiple providers in your Terraform configuration. So I'll see you in the next lecture. If you go through the documentation of Terraform, it states that if you're just learning how to use Terraform, then it is okay to have your .tf state within your local environment itself. And that is precisely what we had been doing till now. So if you go back to the previous lecture, I told you what tf state is. And it basically just contains all the configuration of all the resources that you've created. However, you would want to store your tf state, which is actually the most important file in Terraform, in a separate environment, which is more robust. So for that particular reason, it is recommended that you store your Terraform either as a remote backend or with Terraform Cloud. We would be using the remote backend, and we would be using the Azure RM, that is the resource manager, Azure resource manager, to create the backend. So if you go through the documentation of Azure RM, it states that you can create your particular TF state within a particular group, resource group, and within this particular resource group you can have a storage account, and within that storage account you can have a container name by this name, and within this you can store your particular key. So let's do that. So here I have created a Terraform configuration, and here I'm using the backend Azure RM. I've created a resource group by this name, and within that resource group I've created a storage account, and that storage account has a container called tf state. So when I do a Terraform apply for the first time, a key by this particular name will be created, and that key keeps getting updated again and again as I keep doing. subsequent Terraform applies. So let's try to run this and let's see what happens. So the only resource that I'm creating here is just this particular resource group as well. So let's see what happens when you do a Terraform apply. Again, I go back to my terminal. But before that, let me just show you whether this particular container contains a key or not. So let's go to this particular container name, which is residing in this particular storage account. So I'm at my resource group. Again, let me open the resource group. This resource group contains this particular storage account, and within this particular storage account, let's go to the container. So I've created a TF state container, and as you can see that TF state doesn't contain anything. So let's do a Terraform apply and let's see what happens. So I run a Terraform apply, and let's go back to the resource group and let's see what happens here. So you can see that a particular file got created. So it's getting updated currently. So let's wait for this to finish. Okay, so a resource has been added. So let's refresh this. So you can see that there is a bit of data in this. So if you open this, then you see that this particular TF state has the resource that we want to create. So it has basically this particular resource that we are creating. So let's see if this particular resource has got created. Example resources. So let's go back to a resource group. So you can see that particular resource group got created. So this is how you would want to create your TF state file. So even if something goes wrong in your local, you can always refer back to your TF state file and get all the information you need about all the resources that you have created. So I'll see you in the next lecture.
So welcome to my first part series on Azure Basics. In this particular part, I'll explain to you the following concepts: Azure Active Directory, Management Group, Subscription, Resource Group, and Resource. So these are terms that you will keep hearing very often as you approach your journey towards Azure, and it's imperative that you understand all these concepts well. So let's waste no more time and let's start by talking about Azure Active Directory first. So now let's talk about Azure Active Directory. Azure Active Directory is Microsoft's cloud-based identity and access management service, and it helps users to sign in and access resources like number one, external resources like Microsoft 365, the Azure portal, and thousands of other software as a service applications. Now, from our perspective, we'll be using Azure Active Directory to log into our Azure portal. Now, we can also use Azure Directory to create apps that can be used within your corporate network and intranet. So this is something that we will see in a later course. But from our perspective, initially we'll create an Azure Active Directory to log into our Azure portal. So one important concept for you to understand is called the tenant. Now a tenant is an instance of an Active Directory. Now there are two kinds of tenants. The first one is the Azure Active Directory tenant. Now the Azure Active Directory tenant is used if you want to add users or create groups for a particular organization or for a particular business or a school or a college. Now, the other kind of Azure Active Directory is the Azure Active Directory B2C, that is the business to consumer. Now, if you want to create an application that you want to expose to the public at large, then you would use the Azure Active B2C. But from our perspective, initially we'll be using just the first one, that is the Azure Active Directory. Now, in the next chapter, we'll talk about how you can create a tenant that is an instance of an Active Directory. So I'll see you in the next chapter where we'll do that. Okay, so let's start this section by creating an Azure Active Directory as well as an Azure tenant. So I'll just click on Azure Create Account and let's create an account in Azure. So I'll just click on Build in Cloud with Azure Free Account and I'll click on Start Free. So here you just need to give a valid email ID. So you need to create a new one. Click on Next. Just give a password. Next. So I'll get a code in this particular email ID. So let me just fetch that and enter that particular code. So let me click on Next.
Okay, so here you need to fill in the appropriate information, and once you've done that,
You can click on Next here. And once you've done that, you need to identify yourself with a credit card. So I have already done this step. So unfortunately, I'll not be able to do this again. So all that you need to do after that is click on Sign Up and you will have your Azure Active Directory created. So in the next chapter, I will show you how your Azure Active Directory will look like. So I'll see you there. So once you have created your account in Azure, there is a tenant called default directory that gets automatically created. So the domain that is provided for your default directory is based on the email ID that you give while creating your particular account. So for example, the email that you give has name.surname@abc.com. The domain that gets created for you is name surname abc.onmicrosoft.com. So let us look at this in our console itself. So here I'm in my dashboard of my particular console. So to go to your Azure Active Directory, you can just search for Azure Active Directory here. So that's one of the ways in which you can get your Azure Active Directory. The other way is you can open your hamburger menu here and click on All Services. And underneath Identity, you will find your Azure Active Directory. And if you've opened it previously, it'll also come in under your favorites. So you can also find your Azure Active Directory here as well. So these are a few ways in which you can open your Active Directory. So let's open our Azure Active Directory. So here you get a few basic information. The name of your Azure Active Directory tenant is default directory. The tenant ID is this, and the primary domain is this. So this is based on the email ID that you have provided. And there is also a license. So the current license is Azure Active Directory free. You also get a paid version of this, which has more features, which includes creating roles, and also that is something that we'll talk about in the next chapter. So the primary objective of your tenant is actually to create users. So let's start by creating an individual user. So you can click on users here and you can click on new user and you can click on new user. So I'll click on new user and here you have an option of creating a user within this particular domain or inviting a user which does not belong to this particular domain. So let's start by creating a user which will belong to this particular domain. So I'll just call this Rohit at this particular domain and all that I need to give is just a name and you can have an auto-generated password. So I'll just copy this and let's click on create. So there's a user called Rohit that gets created. So what I need to do is I need to log in using this particular domain. So let's do that. So I'll just paste my password and what I need is this particular primary domain. So let me copy this. I'll click on sign in with a different account. And here I will click on use another account. So what I need to do is I just need to give Rohit at the rate and I'll just copy this and I'll paste it here. Click on next. And here I need to enter the auto-generated password. So I'll just copy this, paste it here, click on sign in. I'll create a new password. Click on sign in. And here I have logged in using my new user ID. So this is how you can create a user in Azure Active Directory. Now let's create another user, but this user will be a guest user. So I'll click on new guest user. So In our previous example, we had seen how to create a user that belongs to this particular domain. Now I will invite a user that belongs to a different domain altogether. So all that I need to give is a name, and I need to give the email ID. And I'll click on invite. So an invitation has been sent to this particular email ID. So let me go and log into this email ID and let's accept this particular invitation. So I get an email ID that looks like this. Let's open this and let's accept this invitation. So I need to enter a password. So let me just enter a password. I'll click on accept. And now what I can do is I can go back to my main page. I'll click on default directory. I'll click on sign in with a different user. And you can see that an account gets created. So I'll just open this. And you can see that I'm logged in using this particular email ID. So this is how you can use an external email ID to connect to your Azure Active Directory. So that's it for this particular chapter. I will see you in the next, where we'll discuss about groups and permissions. So I will see you there. Okay, so as you know that the default tenant got created on its own when you created the account. So what if you want to create a new tenant altogether? That is possible. You can just go to your Active Directory. You can click on Manage Tenants here. And all that you need to do is you need to create a new tenant. So I'll click on Create Tenant here. And here, like I mentioned in the slides previously, you have the option of creating an Azure Active Directory. This is for organizations and schools and colleges. However, if you want to create a Active Directory specifically for a particular application which will be targeted to the public at large, then you would want to use something like a B2C. So currently in this particular chapter, I'll be just explaining to you how you can create an Azure Active Directory tenant. So let's leave this for another chapter. So that's all that you need to do. You can just click on configuration. And here you need to give a name for your particular domain. So you can just mention the name of your organization. So I'll just call this as VLC.org. And similarly, I can just call this as VLC.org as well. So here the domain name would be VLC.org on Microsoft.com. So that is all that you need to do. So you can just click on review and create. And you can click on create here. Click on submit. And let's wait for this tenant to get created. And you can see that your tenant got created. So you can go back to your default directory again, click on manage tenants. You can see two instances now. So this is the default directory, and then you have another tenant called VLC on Microsoft.com. So just like you created users on this particular domain, you can create users on this domain. So now let's log into this particular domain. So to do that, you can just click on your default directory here and click on switch directory. And here you can see the new tenant as well. So what you can do is you can click on switch here, and your Azure console will be transferred to the new tenant, Azure Directory tenant. And now I'm connected to my new tenant. So if I go to my Azure Active Directory now, you can see that my Azure Active Directory is currently VLC.org, and I just have one user. So all the previous users that I've created are not present in this particular tenant. So I can again create a new user, a new guest user, and do the same activities that I was able to do in my default directory. So this is how you can create a new tenant. So I hope this was a useful lecture. I will see you in the next. So whenever you create your Azure Active Directory for the first time, there is a user that gets created for you. And this particular user has got the role of global administrator. So currently I am logged in using this particular user, and this particular user is the email ID that I used to create this particular account. So if you go to the users here, you will see that this particular user, and if you go to your assigned roles here, you'll see that the global administrator role is assigned to this particular user. Now, whenever you create a new user, you can assign to these users separate roles as well. So this is another user that I had just created. I can click on assign and I can assign a particular role to this particular user. So I'll click on add assignments. And what I can do is I can just assign a reader role. So a global reader has basically just read access to all the resources within the Active Directory. So now this particular user has been assigned the global reader access for this Active Directory. So if I go back to my default directory, you can click on roles and administrators. So you can see that there are a set of roles that are currently available for you to use. So these roles are all related to Active Directories. So these roles are all basically permissions within the Active Directory, and you can't assign these roles to give access to resources that are outside your Active Directory. So for example, if you want to give a user access to EC2, you can't do it using this particular roles and administrators. So that's something that we'll discuss as we proceed in this course. And another thing to note is if you're using the Active Directory free account, you do not have access to create new roles. So you can see that this particular icon is completely disabled. So here I have another Azure Active Directory account, and this particular account has got premium P2 version. So what I can do is I can go to my roles and administrators here. And here you can see that I can create custom roles. So I can click on these custom roles. So I can click on new custom role here, and I can give a name for this custom role. I'll just call this as custom role admin. I'll click on next. And here are a set of permissions that you can give to this particular role. So let's suppose I just want to give it application policy create. I click on next and I click on next again, create again. And you can see a custom role got created and I can assign any particular user this custom role. So this, like I said, is only available if you have a premium version of Active Directory. The free version does not support this. So another important thing to note is you can go to your roles and administrators. You can just open any one of these custom roles. And here in the description, you can see all the permissions that are assigned to this particular role. So this is something that will come in handy if you want to make a custom role and you just want to have specific permissions based on a previously created role. So this is something that you should always know. And one final thing to note is whenever you create a new user in your Active Directory, so based on whether it's a member user or it's a guest user, there are already certain sets of permissions that are available for you. So for example, you can see all the users and contacts, and you can also create security groups. So this is a very important URL that I will give in the description below. So it is not that when you create a new user, there is absolutely no permissions assigned to it. So these are the set of permissions whenever you create a new member user or a guest user. That's it for this particular chapter. Again, if you have any issues, please do not hesitate to get in touch with me. I will see you soon. Okay, so if you've used the Active Directory for some time, you will realize that the Azure Active Directory Free has got very limited capabilities and you would need to purchase the P1 or P2. However, if you want to get it free for a month, you can also do that. So you can go to your roles and administrators. So here it gives you an option of starting your P1, P2 as a free trial. So you can just click on this. And what you can do is you can just activate this particular button. And what will happen is that your particular free tier will get converted into premium P2. And this is just applicable for 1 month.
Okay, so I'm in my default directory right now, and you can see that the primary domain I have is based on the email ID that I had provided while creating this particular account. So how do I change my primary domain to my company's domain? So to do that, you can go to your custom domain and you can click on add custom domain. So here you need to give your company's domain name. So let me just do that. So my company domain name is verylazykoders.in. I'll click on add domain, and here it will ask me to add these values to my domain's DNS. So let me just do that. So I'm in my DNS for my particular domain. So all I need to do is I just need to click on add, and I need to add a text value, and this is the value, and this is the host. So I'll click on save, and I go back to my account. I click on verify. So it takes a bit of time for this verification to happen. So let's just wait till this verification is complete. Okay, so my domain is registered. So I go back to my default directory. I go to my custom domain names. I'll click on this particular domain and I will make this as my primary domain, and I'll click on yes. So currently this particular domain is my primary domain name. So I go to my default directory. So if you're creating a new user, you can click on users and you can use your domain to create a new user. So I'll click on new user, and any new user that you create will have this particular domain. So that's it for this lecture. So that is how you can set up your custom domain with your Azure Active Directory. So I will see you in the next chapter.
Now let's talk about the concept of groups and why do you need groups. So let's assume that you are the global administrator of an organization and there are a few individuals who have joined your team and you need to assign to them the user administrator role. An easy way of doing it would be to manually assign each one of them the. So now this is not a very good way of doing it because you have to manually do it for each one of them. A better way of doing it would be to create a group and you can assign the role user administrator to that particular group. And any member who is part of that particular group gets the role of user administrator. And on top of that, you can also assign an owner to this particular group. So the job of the owner would be to assign new members to this particular group. So in this way, the global administrator has delegated the work of assigning new members to the owner. And the global administrator does not have to worry about assigning new members to this particular group. So let's see how this works in practice. So now to create groups with roles, you need to use the Azure AD Premium license. So I have used another account to log into my Azure Active Directory. So this particular account has got access to Azure AD Premium. So currently I'm using the Global Administrator account. So the first thing I'll do is I'll go to my Users tab. And you can see that I have so many users within this particular tenant. So the next thing that I need to do is I'll go to my default directory, I'll click on groups and I'll create a new group. So I'll go to my new group. So here I need to give a name for my group. So I'll just call this as user admin. And you need to also give a description. And then you need to say, yes, the Azure AD roles can be assigned to this particular group. So I'll click on the roles here and I'll just select user. I'll click on user administrator and I'll click on select. And here I need to assign the owner and the member. So if I click on no owners assigned, so what I will do is I will assign this particular user the owner access to this particular group. So I'll click on and I'll click on select. And I will not assign any members to this particular group. So I'll just click on create, click on yes. Okay, so I've created this particular group. Now, of course, the global admin can also add members to this particular group, but so can the owner of this particular group. So let's do it that way. So let's go to the owners Active Directory and let's assign a certain set of users to this particular group. So I will just log out. And so what I'll do is I will log in using the owner account for this particular group. So currently I'm logged in using the owner of that particular group. So I click on View Active Directory. So I'm in the Active Directory for this particular user. So what I need to do is I need to go to Groups. I can open the user admin. And here I can go to my members. I'll click on Add Member. And here I will just assign Sam access to this particular group and I click on select. And you have done that. So what I need to do now is I will log out and I will log in using Sam's account. I'll click on View Active Directory. And if I go to my groups here, you can see Sam is a member of this particular group. So this particular group lets me create users. So if I go to my group again, default directory again, if I click on user here, I can click on new user here and I can create a new account. So let's do that. So I'll just call this as test user. And I can click on create. And you can see that a user got created. So one thing to remember is that at this moment of time, only Sam has got access to create new users. Rohit, even though he's a owner of that particular group, is not a member. So if I go back to my, so if I go to Rohit's account, you will see that Rohit would not be able to create this new particular user. So let's go and let's check if that's possible. So here I have logged into Rohit's account again. So like I mentioned before, Rohit is the owner of this particular group, but not a member. So let's go to the users and let's see whether Rohit is able to create a user. So you can see that the new user tab itself is disabled. So Rohit cannot at this moment of time create a user. So what we can do now is we can actually assign the owner, the member access to that particular group as well. So let's do that. So here I'm in my user admin. I'll go to my members and I will add the owner of this group as the member as well. So I'll click on add members, click on select, and let's go back to the user now. So you can see this is disabled now. That is because I need to log out and log in again. So let's do that. So I will just sign out and let's sign in again. Click on yes. Let's go back to our Azure Active Directory. I'll click on user here and you can see that it's currently enabled. So let's create a new user. I'll just call this test user 2 and let's create this particular account. And you can see that I was able to create. So that is how your groups work. So I hope this was a useful lecture for you. So I will see you in the next. So now let's talk about administrative unit. An administrative unit is a container that contains users and groups. So why do you need an administrative unit? So let's assume that you're a global administrator in an organization and your organization has branches in different continents. Let's assume in the US, Europe, and Asia. Now, what you want to do is you want to create a container that contains users just for a particular continent. So, for example, there will be an administrative unit for the US region, another one for the Europe region, and a third one for the Asia region. And within these regions, you can have administrators who would have privileges just for that particular administrative unit. So here in this example, I'll create an admin who has rights over just the users within that particular administrative unit. Now, the administrative unit can, like I said previously, contain both users as well as groups. So let's create an administrative unit in Azure. So currently I'm logged in as the global administrator and this is my email ID. So if you want to check what your permissions are, you can always go to your users and you can open your particular user. So this is the user that I am logged into currently. And here under assigned roles, you can check what your particular role is. So the role here is global administrator. So that is how you can figure out what is the role that is assigned to you. So you go back to your default directory, you can click on administrative unit. And here what I'll do is I'll create an administrative unit. I'll click on add and I'll call this as the US administrative region. And I'll click on review and create. So here what I need to do is I need to pick a role for the administrator. So here the only roles that are available are these. So there isn't much choice that you have if you are a administrator for a particular administrative unit. So what I'll do is I'll pick the user administrator and I will assign one particular individual the user administrative role for this particular administrative unit. So I'll pick this particular ID. Now this particular ID has, so now this particular user will have user administrator rights over this particular administrative unit. And I'll click on add and I'll click on review and create and I'll click and I'll create this particular administrative unit. So once I've done that, I can go to my administrative unit and I can add users to this administrative unit. So like I said, you can add both users as well as groups. I will add users currently. So I'll click on add user. So I will pick a few users who can be members for this particular, who can be members to this particular administrative unit. So I picked these two users. I'll click on select and I've added these two users. Now what I'll do is I will log into the administrator account for this particular administrative unit. So I had chosen Rohit to be the administrator for this particular unit. So I'll open this particular account. I'll click on view. I'll click on administrative unit here. So now being the administrator, I have just access to these two particular users. So for example, if I want to change some parameters for this particular user, I can do that. So I'll open this. So I can edit some values for this. So what I'll do is I will just change the last name to something else. And you can add all these information if you wish. So I'll just add these values and I can save it. And you can see that it got successfully updated. So if I go back to my default directory, and if I click on the users here, so these are the list of all the users that are currently available in the tenant. Now, if suppose I want to change some parameter for this particular user who is not part of the administrative unit, let's see what happens. So I click on this ID and you can see the edit parameter itself is disabled. And whereas if I open this particular user who has access to that who is a member of that administrative unit, you can see that the edit parameter is enabled. Okay, so now I am logged into one of the users of that particular administrative unit. So if I click on view here, let's go to the active directory. So now this particular user has absolutely no edit permissions for any of the users. So if I go to the administrative unit, and let's suppose I want to edit this particular user's information, I'll click on this particular user, and you can see that the edit itself is disabled for this particular user. So that is because this particular user is just a member of the administrative unit and not one of the administrators of this particular administrative unit. So one final thing to remember is that you have to be a global administrator or a privileged role administrator to create an administrative unit and to add users to that particular administrative unit. So that is one important thing to remember. So unless you are not assigned these two roles or one of these two roles, you will not be able to create an administrative unit. So I will see you in the next chapter. So in our previous section, we had talked about creating a tenant in Azure Active Directory, creating users, creating groups, creating roles. So our main intention of creating our Azure Active Directory was to log into the Azure Cloud Platform itself. Now there are many other things that you can do with your Azure Active Directory. Now this includes connecting with other apps using SSO, or you could even create your own business application that will make use of the users that you have in your Active Directory. And another very important aspect of Azure Active Directory is that you can actually connect your Azure Active Directory with your on-premise application via Azure Active Directory Connect. So these are some of the important things that you can do with Azure Active Directory. So in this particular chapter, we'll talk about how you can create your own business application and make use of the Azure Active Directory as an identity provider. So let's see how this can be done. So in this particular chapter, we'll create a single page application that will make use of the Azure Active Directory that we've created. Now to do that, you can go to your app registration, create a new registration here, and let's just call this as my single page application. And you want this particular application to have access just to the accounts within this particular Active Directory. So I'll just click on single tenant and I'll click on register. Okay, so once you've registered your application, all that you need to do is you can just go to your quick start and you have the option here of creating a web application, a mobile or desktop application, a single page application, or a daemon application. So what we'll create as our application would be just a single page application. You can just click on this and you can just click on JavaScript. So you have the option of Angular, React as well. So let's just click on JavaScript. And all that you need to do is you need to download this sample code that they have. And before doing that, what you need to do is you need to go to your redirect URI and you need to change your URI to localhost. So we will be running this application in our localhost itself. So what I can do is I can just click on this and it'll automatically update the redirect URI with this particular value. So let's just click on this and I'll just click on make updates here. And it has been done. So just to verify, you can go to your authentication here and you can see that there is a redirect URI that is set to localhost 3000. So, okay, that is done. Let's go back to our quick start again. Click on this JavaScript. So now that you need, so now the next thing that you need to do is you need to download this code sample. So I'll just click on this and it'll automatically download this in my local. So let me bring this code into my Visual Studio Code. So let's do that. So I have uploaded my code into my Visual Studio. So the changes that I need to make here are quite simple. You need to go to your apps. All that you need to do here is you just need to change this client ID. So let's get this client ID. So to get your client ID, you can go back to your overview here and you can just copy this particular client ID. So let me just copy this and paste it over there. And then you need to get this authority. Now let's go back to our console. You can just click on your endpoints here. And all that you need to do is you just need to copy this particular part. So I'll just copy this and I'll paste it here. So here, this particular value represents your tenant ID. So the tenant ID gets created when you create your tenant for the first time. So that's something that you need to remember. So this particular value here represents the tenant ID. And the redirect URI is again the local host 3000. So, okay, we've set up everything. Let's do an npm install. Okay, now you can just do an npm start. And our application is running on port 3000. So let's log into our port 3000. And you get a page like this. So all that you need to do is you need to click on sign in. And here you can use any of the users that are there in your Active Directory. So let's go back and check which all users are there in our Active Directory. So I go back to my default directory, click on users. So I can log in using any of these users. So what I will do is I will just log in using Sam. So let's log in using Sam. And here I need to accept this. I'll click on accept. And so you can see that I have been logged in using Sam. So let's sign out. And now let's try to sign in using an account that is not present in the Active Directory. So I'll click on use another account. I'll just take a random name. Let's say Teddy at verylazycoders.in. And if I click on next, I should get an error. It says that your user may be incorrect or make sure that you've typed it correctly. So that's because this particular user is not there in my list of users at all. So that's the reason why I will not be able to log in using this particular account. And if I go back again and let's try to log in using an account that is present. So this particular account is present in the list of users that I have. So if I log in using this account, again, I will be asked to accept this. I click on accept and you logged in using this particular user. So this is how you can use your Azure Active Directory as an identity provider for your single page application. Now, one thing to remember is that this particular application is just specific to an organization or a tenant. Now, to create applications meant for public at large, you need to create using the Azure B2C and not B2B. Now, that is something that I'll teach you in the upcoming courses. So I'll see you in the next chapter. Okay, let's talk about the concept of service principle. So in our previous section, we had created an application, and whenever you create an application in Azure Active Directory, there is a service principle that gets created. Now, this service principle is something that we'll use later on in this course. So one thing that you should remember is that service principle lets that particular application access other resources in Azure. So for example, if your application wants to access resources like your storage or your virtual machine, then you would want to, then you use something called as the service principle. So service principle is a concept that you will keep hearing again and again as you proceed towards this course. And let's look at the console and let's see where the service principle is created. So I'm back in my console. So if I go to the enterprise application, what you see here, this object ID represents the service principle ID. So let's suppose I've opened this particular enterprise application. So if you click on this object ID, you see that this is the unique ID of the service principal object that is associated with this application. So this particular object ID represents the service principal ID of this particular application. So that's it for this particular chapter. I'll see you in the next. Okay, so in our previous section, I had shown you how you can create your own business application that can connect to your Azure Active Directory. In this particular section, I'll talk on how you can connect your already existing cloud application with your Azure Active Directory. And here I'll be trying to integrate G Suite with Azure Active Directory, and I'll be performing two distinct tasks. One is SSO and the other is provisioning. So let's see how this is done. Okay, so I'm in my default directory again. So what I need to do to create my SSO is to go to the enterprise applications here and I'll click on new application. So what I'm trying to do here is to get my G Suite application connected with Azure using SSO. You can just click on this and you can click on this again and you can click on create. So this will create an enterprise application for my G Cloud. So let's wait for this to create. Okay, once you've created your application, if you go back to your enterprise application here again, you can see that there is an instance of G Cloud. So you can just open this. The first thing I need to do is I need to connect using SSO. So to do that, you can just click on your SSO panel here. And then you need to click on SAML. And once you've opened your SAML panel, the first thing that you need to do is you need to configure your SAML. So there is the documentation here which mentions all the values that you need to put. So the pattern that you need to put for your entity ID are these. So you can put google.com, and you can also put google.com with the domain that you have. So this is also a valid domain. So apart from that, you can also put the reply URL. The reply URL can also be in this particular format. So I'll just copy this. And and that's about it. And here the most important one is the sign-on URL. So the sign-on URL is basically the application to which your SSO will log into. So that is based on this particular URL. So if I give this as console.cloud.google.com, this will redirect to my GCP Google Cloud account. And if I wanted to redirect to my email account, my Gmail account, then I can just give this particular endpoint. So currently I want this to redirect to my GCP account. So that's about it for here. I'll just click on save. And the next thing that I need to do is I need to go down, and here I need to download this particular certificate. So I'll just download this. And apart from that, there are these URLs that I need to configure in my Google admin account. So let me just copy these endpoints as well. Okay, so now I'm in my G Suite account. The first thing I need to do is I need to check whether I have that particular domain that I configured in my Azure. So if you can go to your manage domains, you can see that this particular domain is registered to me. So now this is important. Without this, I will not be able to proceed further. So after this, I need to go to my security, and underneath security, there's settings. And here I need to configure my SSO with a third-party identity provider. So I'll just open this. And here I need to enable my SSO, and I need to add the sign in and the sign out page URL. So this sign in and the sign out page URL is basically these endpoints, the login URL and the logout URL. And apart from that, I also need to add my certificate. So the certificate that I downloaded here, I need to add over here. So I'll just click on replace certificate. So I've already uploaded it. I just copy this and paste it. Okay, so once this is done, your SSO is set up. So you can go back to your Azure account, and let's just test for a particular SSO. So before doing that, I need to add a particular user in this particular group. So I click on users here. So I've added two users here. So currently I can log in using these two accounts, provided that these two accounts are also available in my Google admin account. So there is a user called Sam at the rate of verylazycoders.in also in my particular Google account. So if I go to my Google account, if I open my directory here, users, you can see that there's a user called Sam Pro. So let's try to log in using our SSO. I will go back to my SSO here, and let's click on test this application. Click on sign in as someone else, and let's try to log in using Sam. I'll click on Sam, and you can see that it got redirected to my Google Cloud account, and I'm currently logged in using Sam. So let's try to log in using an account which is not registered in Azure. So if I go back to my Active Directory, let's take a user who is not present. So for example, if I try to log in using this particular ID, now this particular ID is there in my, now this particular user is there in my Active Directory, but it's currently not registered with my application. So if I go back to my application, go to single sign-on, and this particular user is also present in my Google account. So if I go to my Google account, you can see that this particular user is also present here. So let's see what happens if I try to log in with that particular account. So I need to log out of this particular account. Let's try to sign in again. So this time I'll sign in using this particular account. It says that this signed user is not assigned to this particular application. So let's do that. So I go to my users, I'll click on add user, selected, and let me add that particular user. I'll click on select and I'll assign it. And now let's go back and test for that particular user. Now you can see that I get a welcome to this particular. So now this is how you can connect your Azure with your G Suite account. Now let's take the third example where we have an account here, but we don't have an account in our Google Cloud. So what we'll do is we'll create a new user. So I'll go back to my default directory. I'll add a new user, click on new user. I'll just call this as my test user. And let me create a password for this. I'll click on create. So let's try to log in using test user. So the first thing I'll do is I'll go to the application. And I will add that particular user. I'll click on select, assign. And let's try to test using that particular user. I click on single sign-on. Let's try to log in using test user. I'll click on next. And because I'm logging in for the first time, I need to give my password as well. Click on sign in. It gives a response like this. Now that is because this particular user is not currently listed in our Google admin. So let's do that. So I go to my Google admin. I'll create a user by that same account. And I'll click on add a new user. Okay, I don't need to save this. So if I go back to my account now that I've created an account in my Google admin as well, I will test using the same account again. So I'll click on sign in as someone else. And let's click on test user again. Now this time because the user has been added in Google, that is why you see this particular page. So that is it for this particular lecture. I will see in the next lecture where we'll talk about provisioning and how we can create an account in Azure, and we don't need to create an account in GCP, and all the accounts will get automatically synchronized. So that's an important topic. So I will see you there. Okay, so one of the issues with our previous chapter was that whenever a new user was added into our Azure Active Directory, it had to be updated in our Google admin panel as well. So now to overcome that, we have something called as provisioning. So how provisioning helps is that anytime a new user is added in Azure, it gets automatically updated in Google admin as well. So once you've enabled provisioning, you need to choose the automatic one and you need to provide an admin credentials. So this admin credential is basically a G Cloud account that has admin access associated with it. So now let's go to our admin panel in G Suite and let's get a particular user who has access to admin. So now I'm so now I'm in my admin panel. So what I need to do is I need to go to account and click on admin roles. And you need to give a user with super admin access associated with it. So what you can do is you can just click on super admin here. And here you can see that one particular user, admin at verylazykoders.in, has super admin access associated with it. Now, if you want to have another user associated with the super admin, you can just click on assign users and just assign any particular user access to super admin. So let's take this particular user and click on assign role. So now I got two users, admin as well as Sam, who's got access to super admin. Okay, so once you've got these credentials, let's go back to our Azure Active Directory. And all that you need to do is you need to click on authorize. and you need to log in using that particular account. And I'll click on allow. So once the provisioning is done, all the users in this particular account will be synced with G-Cloud. So what we'll do is we'll create a new user and let's see whether that particular user is inserted into our Google account. So let's create a user. I'll go to my default directory. I'll click on users here. And now what I'll do is I'll add a new user. I'll create a new user called Chris. Chris, Chris Green. And let's create this particular account. Okay, once that is done, let's go back to our default directory. Let's go to the enterprise application here. Okay, so now that I've added that particular user, the next thing that I need to do is I need to add that particular user in this particular application. So I'll go to your users and let's add that particular user. I'll click on none selected. Chris test, and I'll click on select and I will assign it to this particular user. Okay, so once this is done, let's go back to our provisioning. So if you look at the details, you'll see that the provisioning happens every 40 minutes. So what we can do instead is we can just go to provision on demand and we can just take that particular user and click on provision. So this will automatically provision this particular user in your Google account. Now you can either wait for 40 minutes or you can do this if you want to do it immediately. So let's click on provision here. So you can see that that particular user was populated in G-Cloud. So let's go back to our G-Cloud account and let's refresh this particular page. And here you can see that that particular user was added. So this is how you can provision new users. So I hope this was a useful lecture. And in case you have any issues, please do not hesitate to get in touch with me and I will gladly help you out. So I'll see you in the next lecture. So in our previous section, we had created an application specifically meant for users within an organization. So what if you want to create an application meant for everyone? That is, anybody who has access to a social media account like Facebook or Google would want to use your app. Now to create an application like that, what you need to use is the Azure Active Directory B2C. Now, Azure Active Directory B2C provides a cloud-based identity and access management solution for applications that require social media IDs as well as Active Directory IDs. So let's see how we can implement a solution that uses Active Directory B2C. So I'll see you in the next section. So to create a B2C application, the first thing that you need to do is create a tenant, a B2C tenant. To do that, you can click on Manage Tenants. You can click on Create. And here we need to create a B2C tenant. So you can just choose the second option, go to Next. So let's give a name here. And you need to give a resource group within which your application will be contained. So I'll just give a random, or I'll create a new resource group. I'll just call this as VLC. Click on OK. And let's click on Review and Create. So you'll get an error like this. Now, to resolve this particular error, you have to go to your subscriptions, open your active subscription. You can open your resource provider. And what you can do is you can just get this registered. So I will just click on register here. Now to get more information about these resource providers, I will send you a link in the description below so you can just check that out. And once you have your Microsoft Azure Active Directory registered, let's go back to our Active Directory and let's create a tenant again. So let's go to our Manage Tenant, click on Create, click on Next. And let's click on review and create. Let's click on create. Okay, so we've created our tenant. So the next thing that we need to do is we need to switch to this particular tenant. So I'll just click on this and I will just click on switch. And here, what you see here is basically the Azure Active Directory B2C. So here, what we need to do is we need to create our application. So again, let's click on application registration, a new registration. And here, let's just give a name for our application. So I'll just call this as B2C application. So now this particular application that we'll create is not specific to a particular tenant or organization. This is for public at large. So that is one thing that you need to make sure of. So you should always choose the third one. So let's click on register. Okay, so now that you've created your application, the next thing that you need to do is you need to create a user flow. So you can go to your user flow, and what we're going to do now is we're going to create a user flow. So what we're going to do now is we're going to create a new user flow, and this particular user flow is just to sign up and sign into our application. Now, for this particular demonstration, I will not use any external identity provider like Google or Facebook. It's just going to be the default. It is just going to be the default Azure Active Directory users. So let's click on create here. So you need to give a name for your flow. So I'll just call this as default flow. And here I'm just going to use the local account, that is the Azure Active Directory. So I don't have much choice because I've not registered any of the external identity providers. Now that's something that I'll do in a later course. And so I've disabled multi-factor authorization, and the type of authentication is going to be via email. So let's click on create here. Let's open our user flow. Okay, so now that you've created your user flow, the next thing that we'll do is we'll create a few users. So I'll go back to my main page here and let's add a few users. So I'll just click on users here. So what I'll do here is I'll just create a Azure Active Directory B2C user. I'll click on create, email. So I will just choose a email ID. So let's choose my email and I'll click on create. Okay, so now that you've created your application in Azure Active Directory B2C and you've created your workflow, the next thing that we need to do is we need to download the boilerplate code. So the boilerplate code is in this particular GitHub repository. So this particular part to this particular, so the part to this particular GitHub, I will give you in the description below. So all that you need to do is you just need to clone this particular GitHub repo, and this is specifically for JavaScript. Now, for other languages, you can just go to your Azure samples and get the same. So I have loaded my piece of code in my local directory. So the next thing, the first thing I need to do is I need to go to my auth config and I need to change the client ID here. So let me just remove this. And let's populate this with the client ID that we have. I go to my users again. And I'll just copy this. So I'll go to this app. And everything else remains the same. So once you've done with your auth config, the next place where you want to go is the policies.js. So here what you need to do is you need to change the authority and the sign-in authority and the edit profile authority as well as the authority domain. So to get these information, you go back to your page again, click on endpoints. So you can just copy this particular path and just paste it here. And this particular suffix represents your user flow. So let's just remove this and replace it with the user flow. And also this particular domain should also be the same. So I'll just copy this and I'll paste it here. So again, this is just the tenant endpoint and nothing more than that. And it's going to be prefixed, or should I say suffixed by the user flow ID. So I go back to my user flow and I'll just copy this and I'll paste it here. So currently the edit profile, I will just leave it as it is. I do not want to have an edit profile. I just want to have a login and a sign in profile. So again, I'll just copy this and paste it here as well. And I'll leave this as default. I'll just have a placeholder. And apart from that, if you go to the auth config again, and one last thing you need to do is you need to configure the redirect URI. Now this particular application will run on this particular port. So let's also configure this redirect URI. I'll just copy this. I'll go back to my B2C application. I'll click on my authentication here. And here what I need to do is I need to add a platform. So it will be a single page application. And I'll just paste this particular URL and I'll click on configure. Okay, so we're done with all the settings. Now we can run our application. So what I'll do is I'll run this terminal. I'll do an npm install. And let's do an npm start to run the application. Okay, it's listening at port 6420. So let's open our localhost at 6420. So I've opened my localhost at 6420. Let's click on sign in. And here I'll try to log in using the user ID that I just created. And here you can see that I'm not connected to any external identity provider. So this is just my Active Directory that I'm going to use currently. I click on sign in. And you can see that I have been logged in. Now, if you're creating an application for customers, you would also want to connect your application with external identity providers like Gmail, Facebook, etc. Now, that's something that we'll see in the next chapter. So I'll see you there. Okay, so in our previous chapter, we created a B2C application. However, this B2C application is only connected to our Active Directory and not to any external identity provider. So if you go check out applications on the internet, you'll see that the login redirects not just to their local directory, but also to other identity providers like Google and Facebook. So let's add an identity provider to our application as well. So what we'll do is we'll add the Google identity provider. Now to do that, you can go to your Azure AD B2C. You can click on identity providers. And what we're going to add is basically the Google identity provider. So you can just click on this. And here what you need to add is basically the name, the client ID, and the client secret. So how do you get these values? So to do that, you can just click on this particular page and this will tell you all the details on how you can add these values. So let's click on this. So if you browse through this page, it will ask you to sign in to this particular Google Developer Console. So this is basically the GCP console, that is the Google Cloud Console. And all that you need to do is you need to create a credentials. And within this credentials, you need to add these values. So let's do that. So I'm in my GCP account now. I need to go to credentials. Now, of course, if you have any issues with this particular flow, you can always get in touch with me. I'll be glad to help you out. So what you need to do is you need to create a So the first thing that you need to do is you need to create a consent screen. And this consent screen should have this URL as the authorized domain. So I'll just copy this. So if you go back to our GCP page, click on the OAuth consent screen. So here, let me give a name for my particular consent screen. I'll just call this as my Azure B2C app. And I can just give a user support email. So this is fine for me. And what you need to do is the authorized domain you need to change and you need to add this particular authorized domain. And you also need to add a developer contact information. So this is also the same ID as before. So again, like I said before, the only thing you need to add here extra is the authorized domain. And this authorized domain would be the b2clogin.com. So I'll click on save and continue. And let's click on save and continue here again. Okay, so we've created our OAuth consent screen. So the next thing we need to do is we need to go to credentials. and you need to create credentials and click on OAuth client ID. So this has to be a web application. And here the important thing is you need to add these two values. So that is the authorized JavaScript origin and the authorized redirect URI. So I'll click on the add URI here. Let's go back to our page here. And it mentions here that for authorized JavaScript origin, you can either enter this particular domain, or if you're using a custom domain, you can enter this particular custom domain. Okay, so for this particular tenant, we don't have any custom domain. So what I'll do is I'll just copy this and let's go back and paste it in our, and here I need to change your tenant name and I'll paste it here. Okay, so this is done. The next thing you need to do is you need to add the authorized redirect URI. So let's go back to our documentation again. And here for the authorized redirect, you just need to copy this and let's paste it here. And here I need to change the tenant name here as well. So I'll just copy this again and let's paste it here as well as here. Yeah, so this looks fine. So I will click on create. So this will give me a client ID and a client secret. So what I need to do is I just need to copy this and paste it there. So I go back to my Azure activity, click on the application, identity providers, Google. So I'll just call this as Google and the client ID, I'll just paste it here as well as the secret. Let me copy the secret and let's paste it here and let's save this. Okay, so once that is done, you're done with the configuration. So the only thing that you need to do now is you need to go to your user flows and add Google. So I'm in my user flows. So we've already created a user flow in our previous chapter. So you can just refer to that, open this, and under the identity providers, you'll get a drop down with Google. So you can click on this and save. Now let's run this particular user flow. So I go back to my Google account and I click on sign in. And now you can see Google here. So you can just open this. Let's try to open using any of the Gmail accounts. So I'll use this particular account and it gives an error like this. So now that is because I had made a mistake while configuring my account. So if I go back to my Google account and under the OAuth consent screen, what I had made this was internal. So only internal users within the organization can access this app. So what I need to do is I need to make this as external. So I'll just make external here and it's only for testing. So I'll just click on testing here and I'll click on confirm. Okay, so let's try to log in again. Let's click on sign in again. And now you can see that I was able to log in using my Google account. So that is how you can use your external identity provider to log into this particular application. So I hope this was a useful lecture. So if you have any issues, like I mentioned earlier, please do not hesitate to get in touch with me. This might get a little complex. So if you have any issues, please always get in touch with me. Yeah. So I'll see you in the next chapter. Okay, this is going to be a very brief lecture on how you can view your sign-in logs. To do that, you can go to your directory and underneath monitoring, you can click on sign-in logs. And here you can get all the information about all the individuals have signed into your Azure console. Another important and useful tool that you have is also the usage and insights. You can open this and here it will tell you all the applications within Azure AD that has been used. So this includes all the applications like the Google Suite, the Azure portal. So this is basically the same portal that we've logged into, as well as other applications that you have created. So here you can also see all the sign-in activities as well. So you can click on your view sign-in activity and you can see all the success and the failure on each particular day. So this is certainly going to be a useful tool if you want to monitor all the sign-ins that have happened within your particular organizations. So now let's talk about subscription. So what is subscription? A subscription is basically a logical container used to provision resources in Azure. It holds the details of all the resources that you have created, like your virtual machine, your databases, etc. Your subscription has two main tasks. One is related to billing. So using your subscription, you can know how much has been spent by you for all the resources that are within that particular subscription. And the second important task of subscription is to group resources together within a resource group. So let's see how a subscription looks like in the Azure console. So now let's talk about subscription. So what is subscription? A subscription is basically a logical container used to provision resources in Azure. It holds the details of all the resources that you have created, like your virtual machine, your databases, etc. Your subscription has two main tasks. One is related to billing. So using your subscription, you can know how much has been spent by you for all the resources that are within that particular subscription. And the second important task of subscription is to group resources together within a resource group. So let's see how a subscription looks like in the Azure console. So when you open your dashboard, you can just search for subscription and you can find it over here. Another way of finding it is you can go to your hamburger menu, click on all services, and underneath general, you can find your subscription here as well. So let's open a subscription. So currently I have just one subscription and I am the owner of this particular subscription. So here is the subscription ID as well and the current cost for this particular subscription. So this keeps increasing as you keep adding more and more resources into the subscription. So let's open this particular subscription. So here you get a lot of information with regards to the cost for each particular resource in your subscription. So for example, this will tell you the cost for each resource within my subscription. And it will also tell you about all the free services that I'm currently using. And it will also give you a forecast on how much it forecasts that the cost would be for this particular month. And if you keep going down, you can click on invoice and you can get the invoice of all the previous bills. And apart from the billing, like I said, you can also group your resources within resource groups. So here within this subscription, there are two resource groups. That is your Cosmos backend and my serverless example. So if you want to create other resource groups, you can do so from here itself. You can click on create resource. And here you can just name a particular resource group. So I'll just call this as my new resource group. And I'll click on review and create. Click on create. So here you have created a resource group within your subscription. Now, a resource group is something that I'll explain in the next upcoming chapter as well. And here are all the resources that are there within my subscription. So you can just open this and you can see that these are all the resources that are there within this subscription. And these resources will be built by this particular subscription. So and these resources also reside within these resource groups. So these resources over here are within the my serverless example, and this one resource is within the Cosmos backend resource group. So these are some of the important features of subscription. Now to create a new subscription, you can go back to your subscription again and click on add. So here are the subscriptions that I can avail to. I can either avail to a free trial, a pay as you go, or Azure for Students. So a free trial gives you $200 that you can use within the first 1 month. So the problem with the free trial is that some of the quotas are limited, so you can't increase the quota for some of the services within Azure. So be careful while choosing a free trial subscription. However, if you're just beginning with Azure and if you just want to know how it works, then go for the free trial. Now, pay as you go is basically you just pay for what you use. So Azure for Students, again, if you're a student, you would probably need a student's ID to avail to this particular subscription. So these are the subscriptions that you can avail to. So now you can just select any one of them and you can create a subscription. So I already have a subscription, so I will not create another one. And one more thing, if you open your particular subscription, here you can see what kind of subscription you're currently available to. So you can see that currently I'm available to the pay as you go model. So that is it for this particular chapter. In our next chapter, we'll see how we can link your Azure Active Directory to your subscription. So I'll see you there. Now let's talk about an important concept called resource group. Now resource group is a word that you will keep hearing again and again in Azure. So it is important to understand what a resource group is. A resource group is a container that holds related resources for an Azure application. The resource group can include all the resources for a particular solution or only those resources that you want to manage as a group. Now you can decide how you want to allocate resources to a resource group on what makes best sense for your particular organization. Now, generally, you should add resources that share the same life cycle to the same resource group so you can easily deploy, update, and delete them as a group. Now, let's take an example and let's see how this looks like. So you have a subscription, and this particular subscription has two resource groups, and each of these resource groups have resources for a particular application. Now, resources are basically services within Azure. So this can include things like your virtual machine, your subnet, your storage. Now, resources are something that I'll keep explaining to you as we further go down this particular course. So, suffice to say that whenever you create an application, let's say you're creating a web application, and your web application can contain things like a virtual machine, a database, a virtual network. Now, all these things can be clustered together within a single resource group, and this single resource group can belong to a particular subscription. Now, similarly, the same subscription can also contain another resource group. Now, this resource group could be something like a mobile application, and it could have things like a function app, etc. So even though all these resources belong to the same subscription and are built together, however, these resources are logically separated based on which particular resource group it belongs to. So I hope this was a useful lecture. Resource groups are something that you'll keep hearing again and again. So it's important for you to understand this particular concept. So I will see you in the next lecture. So I'll see you there. So now let's look at a few ways in which you can create your resource group. So I'm in my main dashboard. You can go to your subscription and you can open any subscription within which you want your resource group to be in. So this is the only subscription I have. So I'll just open this. And then you can keep going down and you can open your resource group here. And you can create a resource group within this particular subscription. So I can just click on create. And let me just call this my temp resource group. And I'll just click on review and create. And the validation passes. I click on create. Okay, so this is one way in which you can create your resource group. Another way in which you can create your resource group is you can just type resource group and you can create it from here as well. So you can click on create here and here you can choose in which particular subscription you want your resource group to be in. So for me, it really doesn't matter because I just have one. So I can just choose that and I can just rename this as, I can just call this as my new resource group and I can click on review and create. And let me just click on create now. So as you can see, I have two resource groups now created. So in our next lecture, we'll see how we can add resources to this particular resource group. So I'll see you there. So in our previous chapter, we talked about resource group, and in the definition of resource group, the term resources kept coming again and again. So what is a resource? A resource refers to an entity that is managed by Azure. A resource could include things like a virtual machine, a virtual network, a storage account, etc. One important aspect of a resource is that a resource must belong to a resource group. So that is something that you must always remember. And a resource group must belong to a subscription. So this particular hierarchy is something that you must know initially itself. So that is it for this lecture. I will see you in the next. Okay, so let's add a resource in a resource group. So I had created these resource groups in my previous chapter. So let's take any one of them. So I'll take the new resource group. And here I'm in my resource group currently. So let me click on create. And here I have the option of creating resources. So what I'll do is I'll just create a storage account. So to add a storage account, you can just search for storage. Click on storage account. Click on create. And here again, you need to mention the resource group in which you want this resource to be in. So here again, I will take my new resource group and here I need to give a name for my resource group. So let me just call this as temp. And I'll just make this as standard. And let's just make it as a locally redundant. And let's click on review and create. And the validation is happening here. And here you get all the detailed information that you want. So here is the subscription, here is the resource group, and here is the location in which my resource would be located. So this is just to show you how the exact process works. So I'll click on create. And here, if I open my resource group again, you can see that this particular storage account has got created. So this is how you add resources within your resource group. So Once again, let me just reiterate the hierarchy again. So there is the subscription, and this subscription contains this resource group, and this resource group contains this particular resource. So I hope this was a useful lecture. I will see you in the next. Okay, so now that you know what subscription, resource groups, and resources are, let's talk about management group. So management group as a beginner to Azure is not something that you will hear quite often, but it is important for you to know what management group is. So let's say you're working in a large organization which has multiple departments and is located in multiple geographies. Then you would obviously have more than one subscription, either based on the geography or based on the department, or it could be even based on your application itself. So there could be a subscription for each particular application. So how do you manage these subscriptions? So that is where management group comes in handy. So if you have an organization that has many subscriptions, you may need a way to efficiently manage access, policies, and compliance for these subscriptions. And that is where management group comes in handy. So let's see a demo of this. Okay, so let's talk about management group. You can just search for management group here. So this is how my management group currently looks like. So whenever you create a management group, there's a root group that gets created, and you can create management group within that. So currently I have one management group called USA, and this within this particular management group is my particular subscription. So what you can do is, let's assume that this particular management group represents an organization. So let's create management group based on geography. So I have one in the US. So let's create one more. So I'll just call this as Europe. I'll click on submit. And similarly, let's create one more management group for Asia. Okay, so now that you've created Europe and US, what you can do is you can actually create management groups within these management groups as well. So let's open Europe. And what I can do is I can subdivide Europe based on department. So let's click on create here. And what I'll do is I'll just create departments within Europe. So I'll just call this as HR, click on submit. I'll create another for finance, click on submit again. So my final product will look something like this. So I have Asia, Europe, and the US. And within Europe, I have created another management group called Finance and HR. Now I can add subscriptions within these particular management groups. So what I can do is I can just click on add subscription. So I can click on add subscription and add an existing subscription. So currently I just have one subscription, and this subscription is pointing to the US. So there's no point of moving it from the US to Europe. So what you would ideally do is you would create a new subscription, and once the subscription gets created, you can just add it from here from the drop down itself. So this is how you can actually configure your organization based on geography or based on departments, and then add subscriptions to it. So here the important thing to note is that the reason why you would actually create management group is to give access control and policies to each of these management groups. So you can create users who have access just to a certain management group so that they have no control over other management groups. So that is something that we'll see in the upcoming lectures. So that is the main gist of creating management group. That is to create roles and policies specific to a management group so that you give the principle of least privilege to each user. So I hope this was a useful lecture. I will see you in. So now let's talk about Azure role-based access control. Now this is a very important topic for you to master, and it deals with giving users, group service principles, and managed identity, which can be clustered together and called as security principles, roles or permissions to resources within Azure. Now resources within Azure can be segregated as scopes. There are four scopes in Azure. So they include the management group, the subscription, the resource group, and the resource. Now, these are terms that we had talked about earlier as well. So one important thing to note is that these scopes have a parent-child relationship. So what that means is that any access that is granted to the parent will also be granted to the children as well. So for example, if I give owner access to the management group, so all the resources below that will also get the same owner access. So let's see a few examples of how these things work. Okay, so I've created a new super admin for my organization, and this particular super admin has got two roles. He's the global admin for the Azure Active Directory. Now, with this particular role, he'll be able to create new users. And he's also the owner of all the management groups within my organization. So currently, as seen in the previous chapter, we've got three management groups, one in the US, one in Europe, and one in Asia. So the first thing that this super admin will do is he'll create a user called admin.usa. And once he's created that, he'll give the owner role to the US management group to this particular admin.usa. So let's see how he's able to do this. Okay, so I'm currently logged in as a super admin. So the first thing that I'll do is I'll create a user. So let me click on users, click on new user. I'll create a user called admin.usa and the admin's name is Chris Green. And let me click on create. Okay, so I've created the user admin.usa. Now the second thing I need to do is I need to give this particular user the owner rights to this particular management group. So let's do that. So I am still logged in as a super admin. I'll go to my management group. So I log into the US management group. And what you need to do here is you need to go to access control. And here the first thing you can do is you can see what access the super admin has. So if you click on view my access, you can see that the super admin is currently the owner. So what I can do now is I can go to the add assignment and click over here. And I can grant owner access. I click on owner, go to next to a particular user group or service principal. So I'll select a member. So the member that I'll select would be Chris Green. I'll click on select and I click on next, review and assign. So what we'll do next is we'll log in as Chris Green and let's see what he's able to see in his management groups console. So I will sign in as a different user. Click on next. So let's go to the management group. I say now admin.usa, who is basically Chris Green, can only see one particular management group, and that is USA. So let's open this and let's click on access control again. And let's see view my access. And you can see that the admin.usa is the owner to this particular management group. And now because he's the owner to this particular management group, he will also be owner to the subscription within this particular management group. So if I click on subscription here, so there is one subscription linked to this management group. So let's open this. And again, let's go to the access control for this particular subscription. So I click on IAM here and let's check view my access now. And you can see that Chris Green or admin.usa is the owner for this particular Azure subscription. And that is because he is the owner to the management groups and thereby he will be owner to all the children of this particular management group. So I hope this was easy to understand and I will see you in the next chapter. Okay, so in our previous chapter, we had created the super admin and we had also created another user called admin.usa, who is basically the owner of the management group USA. Now what we'll do is we'll create a user admin and the job of the user admin is just to create new users in the Azure Active Directory. Now this particular user has absolutely no control over the scope. So his only job is just to create users. Okay, so after that, the user admin will create a few users in the Azure Active Directory. And after that, it's the admin.usa who will assign roles to these new users who have been created. So let's see how this is done. Okay, so I'm logged in as the super admin. The first thing I'll do is I'll create a user. So I'll click on users. I'll create a new user called user admin. Just give a random name. Click on create. Okay, so after that, let's go to Steve Brown and we'll assign a role to Steve Brown. So I click on use assign roles, click on add assignments, and what I'll give him is the user admin and click on add. Okay, so let's refresh this. Okay, so now the user Steve Brown has user admin access. So now what we'll do is we'll log in using Steve Brown or the user administrator and we'll create a few users. So let's do that. Okay, I'm logged in using user admin. So let's go to the Active Directory. And what we'll do here is we'll create a group. So let's create a group, and within this group, we'll add a few users. So I'll click on groups, click on a new group, and I'll just call this as a developers group. Click on create. And after this, I'll add a few users and add them to this particular developer group. So let's go back to the users. Okay, so now what I'll do is I'll create a few users and I'll add them to this particular group that I've created. I'll click on new user. I'll call this as dev1. And I'll click on create. Similarly, I'll create a new user again, dev2. I'll click on create again. Okay, so let's add these two users to the group. So let's go back to the group again. Click on the dev group. Click on members, add members. And I'll select. Okay, so now that I've created these two users, the next thing I'll do is I'll log in using the USA admin and give access to these two guys to a certain resource group so that they can create resources only within that particular resource group. So let's do that. So I'll log in using the admin.usa. The first thing that I'll do is I will create a resource group for these guys. So I can go to my subscription, click on resource groups here, and I create a resource group. So I'll just call this as new application, new dev application dev, and I click on review and create. Click on create. Okay, now let's go to this particular resource group. And now what I need to do is I'm in this particular resource group. I'll go to my access control. I'll click on view my access to see what role I have. So basically I am the owner because I've just created this particular resource group. So the next thing I'll do is I click on add role assignment. And here what I need to do is I need to give contributor access. So contributor access gives you full access to all the resources, but does not allow you to assign roles to this particular group. So that's precisely what we want to do. We do not want to give them owner access. We want to give them contributor access. I'll click on next. And here I'll click on user group and service principal. I'll click on select member. And here I'll choose the dev group. I'll click on select. I'll click on next, review and assign. Okay, so the group has been added to this particular resource group. So let's look at this view access to this resource. So I click on view and you will see that this particular group has got access to this particular resource group. So if I open this dev group, I'll click on the members. So you can see that these two users have got access to this particular resource group. So I hope this was a useful lecture. I will see you in the next. So in our previous chapters, we had given access to users and groups to a particular scope. And in this particular chapter, we'll do something different. So we had created previously a web app or a single page application. Now what we need is that we need this particular single page application to have access to a single resource within. So the first thing that I'll do is I'll create a new resource group. And within this resource group, I will create the resource that my single page application needs access to. So let's create a resource group. So I'll just call this as a single page application resource group. Click on review and create. And within this particular single page application, I will create a storage account. Now a storage account contains static files that my single page application might need. So I'll click on create. Click on storage account. I'll create one. So here I need to give the right resource group. So this is the resource group. And let's just make it a locally redundant storage. And let's click on review and create. Click on create. So let's wait for this resource to get created. Okay, my resource is created, so I'll go to that particular resource. And what I need to give is just read access and not more. So I click on access control. Again, I'll click on, okay, let's see what access that I have. So as you can see, I have the owner access because I'm the admin. And let's click on add role assignment. And what I need to give is the read access. So I'll click on read. I'll click on next. And here, what I need is basically the service principal. I'll click on select member. And the name of my service principal is my app. So this my app is basically the service principal that is connected to my single page application. So I'll just click on this and it got selected here and I'll click on select, click on next, review and assign. And now my particular single page application that I had created previously. So I will give you a link in the description below as to where I had created that particular single page application. So you can just check out that chapter once more for reference. So once you've created that, you can just go to view access to this resources. And let's type my app. And you can see that my app has just got reader access to this particular storage account. So that's it for this particular chapter. I hope this was useful. I'll see you in the next chapter. Okay, so in this particular chapter, we'll talk about the concept of policy. So Azure policy helps to enforce organizational standards and to assess compliance at scale. Now, common use cases for Azure policy includes implementing governance for resource consistency, regulatory compliance, security, cost, and management. Now, policy definitions for most of the use cases are already available in Azure, so you do not need to build them. But however, there is an option of creating custom build policies as well. Okay, now similar to the role-based access control, you can define policies based on all the four scopes that are available in Azure. So you can define policies within the management group, the subscription, the resource group, and the resource. Now we'll start off by creating a very simple policy, and this policy will make sure that the resources that you create within the USA management groups are within the US region itself. So it this particular policy will make sure that you are not creating resources that are outside the US if you are in the USA management group. So let's see how this is done. Okay, so I'm in my management group. So let's open the management group USA. And what I will do is I will add a policy, and the policy that I will add will make or will restrict resources from being created outside the US. So let's open a policy. What I need to do is I need to click on assign policy. And here you can mention the scope. So you can mention the scope as the US. Of course, you can also do it at a subscription or a resource group level as well. So if I click on this particular subscription, and I can choose a resource group as well. So this particular policy, if I do it at a resource group, would be applicable only for that particular resource group. But let's do it for the entire USA management group. So I'll just clear selection, cancel. And here is basically the policy definition that I need to implement. So this policy definition is already inbuilt in. So I don't need to write a new policy. So I can just search for location. I click on allowed location. So this particular policy enables you to restrict the locations your organization can specify while deploying resources. Use this to enforce your geo compliance requirements. So I'll click on select. And then I will choose the parameter. So here I can choose the region. So here I'll choose the region and resources can be only created within this particular region. So what I'll do is I'll just choose US East. So I'll just choose East US. And I click on review and create, and I'll create this particular policy. Okay, so my policy has been created. So if you go back to the management group US, if you click on the policy, you can see that this particular policy has been created. Now the problem is that I had already created other resources which are not in the US East region. That's why you're getting so many non-compliant states for my particular policy. And now what we'll do is we'll try to create a new resource within this management group, and let's see what happens if you try to create a resource that is outside the US region. So I'll just open any one of my resource groups and I'll try to create a storage account. Click on create. I'll just choose any random resource group. And here what I'll do is I'll try to create it in another region. And when I try to do that, I get a policy violation error. And it says that the policy enforcement value does not meet the requirement on resource. So I can only create this in the US East region. So if I go back to my US East region again, and if I click on review and create, so I'm able to create this particular resource only because it's in the US East region. So this is how you can implement policies that can restrict resources from being created outside the region that you want it to be in. So I hope this was a useful lecture. I will see you in the next. Okay, so in our previous section, we had created a policy that would restrict users from creating resource outside the USA. Now, in this particular section, what we will do is we will create a policy within a resource group, and we will create a policy in such a way that within that resource group, you can only create a storage account resource and none of the other resources can be created. So this kind of policy comes in handy whenever you've given a set of developers access to a resource group, but you do not want the developers to create any other resources apart from the ones that you want them to. So let's see how we can do this. So I'm in my dashboard right now. So what we'll do is we'll go to that resource group. And what I need to do is within this particular resource group, I need to add a policy in such a way that only a storage account can be created within this particular resource group and no other resource type can be created. So what I'll do is I'll go to policies. I'll assign a policy. And here, what I need to do is the scope has been automatically set for me. The scope is only valid for this particular resource group. So I don't need to change anything here. What I need to do is I need to add a basic policy definition. So I open the basic policy definition, and I need to go to the built-in one, and let's search for resource type. When you type resource type, you have two options. That is the not allowed resource type or the allowed resource type. So what you'll do is we'll just click on the allowed resource type, and I'll click on select. And after that, I need to go to the parameters, and I need to select the resource type that can be created. So what I need is basically a storage account. So let's go to the storage. And here within the Microsoft.storage provider, I will select all the checkboxes. So let's do that. Okay, once that is done, all that I need to do is go to review and create and click on create. Okay, now if you go back to your policy, you can see that this particular policy has been created within this particular group. So what we'll do is we'll try to create a resource within this particular resource group. So if I click on create, let's try to create a function app. So this is basically a serverless application that we can create. And let's see what happens if you try to create it. I'll click on review and create. You need to give net. And let's make this as US East. Click on review and create. So let's try to create this application. So it's trying to validate this. And here you can see that there is an error saying that this particular request was disallowed by policy. So let's try to create a storage account and let's see whether that works. So let's go back to the same resource group. I'll click on create, go to the storage account. Click on create. We choose the resource group there. And here you can see that the validation passed. So let's click on create. And here you can see that the storage account was created. So this is how you can implement a policy using which you can just restrict a certain type of resource type from being created within that particular resource group. So I hope this was a useful lecture. I will see you in the next. Okay, so in our previous chapters, we had used a built-in policy. So in this particular chapter, what we'll do is we'll create our own custom policy and we will define it in a particular resource group. So let's see how we can do that. You can go search for policy in your search bar. You can open this. And here what we need to do is we need to author a particular definition. So you can go under authoring, you can click on definition. And here you can click on policy definition. So here you can give a basic definition for your policy. So you can give it at a scope level. So I would want my policy to be within the management group itself. I'll click on select. And I will call this as tag validation. So now if you look at the basic template that gets created for you, the most important part for you to remember is this policy rule. So it's based on this particular policy rule that defines whether your policy fails or passes. So let's look at this particular policy rule. So this is basically the default policy rule that gets created. So what this policy rule states is that if this particular policy fails, then the effect is audit. So what audit means is that it'll just create a warning. It will not deny that particular resource from being created. So if you look at this particular policy definition, it passes in a parameter. This parameter is an array that contains a set of location. So if your resource is created within this particular allowed location, then this particular rule passes. Else, it creates an audit. And this audit is just a warning. Now, to get more information about how to create a policy definition, you can just go through this particular page. So if you open the page, you'll get all the information that you need on how to create a policy definition. So the important aspects that you need to remember are the parameters. The parameters are properties that you can insert into the particular policy definition. So if you look at the previous example or the basic definition, you can see that the parameter here is of type array, and it also has a certain set of metadata. So if you go through this particular properties, you can see on how you can actually define a parameter within your policy definition. And then comes the policy rule. The policy rule states consists of an if and a then block. So if within the if block, you can define one or more conditions that specify when your policy needs to be enforced. And the then block, you define the effect of what happens if the condition is fulfilled. Another important aspect of your policy rule is the logical operator. Now, using logical operators, you can combine multiple conditions together. And here, if you want an AND operation between your conditions, then you can use an all of. Or if you want an OR condition, you can use an any of. So this is an example of logical operator. So what I'll do is I'll just copy this and I'll paste it in the default that we had previously created. So I'll just copy this and let's just paste it over here. And let's remove the parameter because this particular definition doesn't need a parameter. And let's make the effect as denied. Okay, so now let's try to read this particular policy definition. So this particular policy definition states that if the kind of resource that you're creating is of type storage account, and if it does not contain the tag application, then the effect is denied. Then the resource will not be created at all, and this particular policy itself will fail. So let's try to create this particular policy. I'll click on save. Okay, so once we've created this particular policy definition, the next thing we need to do is we need to assign this policy definition to the resource group that we had previously created. So let's go to that resource group. So this was the resource group. And here let's go to policy and add that particular policy that we just created. So I'll click on policy, click on assign policy. And here again, it's just specific to this particular resource group. So I'll go to my basic here. And here what you can do is you can just type your custom. And if you type your custom, you can see that there is a tag validation policy that has been created for you. So you can just click on this, select this, and you can just click on review and create. And once you've done that, you can go back to your policies. You can see that this particular tag validation has been assigned to your particular resource group. So now let's test this particular tag validation. So what we need to do is we need to create a storage account within this particular resource group. I'll open a storage account. I'll create a new one. So this is applicable just for this particular resource group. I'll call this as my storage account. Let's click on review and create. So here you can see that this particular creation fails in the validation. So what this requires is basically an application name to be created. So let's create one. So once I create a tag by the name of application, then you can see that this particular validation passes as well. And here you can see that the validation has passed and you can create this particular storage account. Now, creating a policy definition requires a bit of time. So you need to dedicate a bit of time in trying to read this documentation and getting your fundamentals cleared. However, if you have any issues with this, please do not hesitate to get in touch with me. I'll gladly help you out. So I hope this was a useful lecture. I will see you in the next.